matter where you find yourself, no matter what kind of stuff is going on in your life, underneath it all, everything's actually all right. You're okay. You have more power than you might be giving yourself credit for. And if you have something that's going on in your life right now that's challenging, painful, it's just a reminder to take a little bit better care of yourself. You're worth it. You can have this feeling anytime you choose. underneath it all, everything's actually all right. You're okay. You have more power than you might be giving yourself credit for. And if you have something that's going on in your life right now that's challenging or painful, it's just a reminder to take a little bit better care of yourself. Because you're worth it. You can have this feeling anytime you choose.
Wow, what a wonderful day. I'm excited to welcome you to Prisma Day. So good morning, afternoon, and evening, depending on where you're joining us from today. This is our third annual Prisma conference. Prisma Day is a two-day event of talks and workshops by members of the Prisma community on modern application development and databases. Yesterday was filled with workshops in 11 languages covering a variety of different topics. So those of you who have participated, I hope you had a fruitful learning experience. Before we get started, I want to thank you for joining us today. The last year has required us all to adjust to a new reality with the global pandemic, and we greatly appreciate the momentum that the vibrant Prisma community has kept up. I'd also like to thank our amazing speakers for taking the time to prepare and share their knowledge and experience in this online format. I'm Daniel, a developer advocate at Prisma, and I'll be your host today. A little over a year ago, we launched Prisma Client to general availability with the conviction that confidence and productivity are some of the properties you seek as a developer when building data-intensive application. Since then, we've released 27 versions of Prisma. We launched Prisma Migrate, Studio, and the full ORM to general availability. We announced the Ambassador Program and started building a vibrant and diverse community of talented ambassadors. We've also seen companies, both small and large, adopt Prisma for production workloads. And finally, we've seen the global Prisma community grow and thrive. And All of this was possible thanks to the feedback and faith that the Prisma community has placed in our vision to make developers confident and productive with their database. Today is a celebration of this community, the Prisma community, a prospering community of creators. Now, since its inception, the internet has continuously grown, and much of that growth has been shaped by developers. The practices and tools for application development are constantly evolving, and the landscape of development tools is reshaping how applications are architected, built, and deployed. Prisma Day is structured in the spirit of two trends: reinvention and preservation. On one hand, celebrating the innovation in developer tooling, showcasing the power of modern libraries and cloud services. On the other hand, preserving the established wisdom of relational databases and type safety. Today's speakers will give you a glimpse into the thriving Prisma ecosystem and inspire you to learn more about modern application development, databases, and everything in between. In an effort to avoid technical difficulties, we've pre-recorded the talks so that you can get all of the talks without any glitches. However, I am live and the Q&As will be live. And in addition to that, the speakers will also be hanging out in the Slack Prisma Day channel. For shorter talks without a Q&A, you can still submit your questions directly to the speakers in the Slack channel where they'll be hanging around. Now, we know an online event doesn't compare to an in-person event, but we'd still love to hear from you during the event. So if you haven't already, I invite you to join our Slack via slack.prisma.io, where you'll be able to engage with the speakers, get real-time information, and also meet the other attendees. We'll also be running a raffle where you'll have a chance to win one of the following. We have Prisma's new t-shirt design, which I'm currently wearing. We also have $150 sponsorship to an open source project of your choice. We have a ticket to a conference of your choice of up to $500, a Lego robotics set, and finally, a Bedrock license. To participate in the raffle, you need to quote retweet the raffle tweet, which is pinned to the Prisma Twitter account. The raffle will close at 5 p.m. Central European Summer Time. So if you haven't already quote retweeted, you can do so now. We also have some Prisma Day speakers. And if you're interested, you can sign up at pris.ly/Prisma Day speakers. We'll also drop a link in the Slack channel and we'll mail those stickers to you. Lastly, I want to ask you to take a look at our code of conduct. It can be found in the footer of the Prisma Day website. Now, let's get started. I'm delighted to introduce Søren. Søren is the co-founder and CEO of Prisma and a longtime database geek. He's been building application data infrastructure for more than a decade before founding Prisma with the mission to bring advanced application data tooling to developers around the world. His work has been instrumental to Prisma's architecture and focus on developer experience. So now, without any further delay, I bring you Søren.
Welcome to the second day of our annual community conference, Prisma Day. We've been organizing developer conferences for half a decade, and this year's Prisma Day is the largest by far. Yesterday, we had a full day of workshops organized by a dedicated community, spanning the gamut from introductory sessions to deep dives on frameworks like Next and Redwood. We had a jam-packed day with 19 sessions in 11 different languages. Just incredible. Since we last met at Prisma Day 2020, we have been hard at work improving the Prisma ORM. We have implemented hundreds of highly requested features, including the ability to order results by relations and a much more powerful aggregations API. We've talked to literally thousands of you on Twitter, on GitHub, and in the Prisma Slack community. And your feedback and consistent desire to push Prisma forward is what has enabled us to make Prisma the fastest growing ORM in the Node ecosystem. Every 4 months, the number of developers building apps with Prisma doubles. And every month, 2,000 developers start a project on GitHub. Prisma is an open source library, so many developers adopt it at work without ever talking to a Prisma employee. And that's great. This year, we've made it our focus to engage with developers using Prisma at SMBs and enterprise companies to make sure that Prisma works, not just for hobby projects, but for large-scale production workloads as well. Many of the latest features and improvements are a direct result of this effort. And as we are talking to developers at enterprises, we are also learning more about their unique situation and use cases. You will hear from a couple of companies at the event today, and we look forward to sharing many more case studies on the Prisma blog in the future. Prisma Day is a celebration of all of the people who make the Prisma community what it is. But it is also a time for us to tell you more about what we have planned for the rest of 2021 and beyond. Hervé will go into much more detail in his session later today, but I want to share just a few things with you already. First, it is important to say that the Prisma ORM is at the heart of everything we do. We have invested heavily into adding highly requested features over the past year, and we are going to continue to accelerate this investment. We believe that the Prisma ORM has a 10 times better developer experience than any other ORM in the Node ecosystem. And we want to make sure that we also have the most feature-rich ORM in the Node ecosystem. Many of you have talked to us about the challenge of using a relational database for applications deployed to serverless environments. Whether you deploy your backend to Vercel, or Netlify, or use one of the function as a service options from the big cloud providers, the challenge is the same. Mature databases such as Postgres and MySQL all make use of a stateful connection between application and database. This is great for maximizing throughput between two beefy servers, but it is a poor fit for the ephemeral nature of serverless environments. Modern databases such as DynamoDB solve this challenge by moving to a stateless connection model. Unfortunately, they also come with a radical new data modeling and querying paradigm, essentially asking developers to give up on a decade of accumulated knowledge just to get a connection model better suited to a modern cloud infrastructure. Later this year, we are launching the Prisma Application Data Platform, which will include the ability to add a stateless connection to your existing relational database. This will work with any of the databases supported by Prisma and allow you to connect to your database from serverless environments with improved performance and scalability. And with that, I want to welcome you to Prisma Day, and I hope you have a wonderful day.
Thank you for the concise keynote, Søren. Exciting times ahead for Prisma. I would like to now introduce Martina Velander. Some of you may know Martina as Prisma's docs queen. Martina writes documentation for developers and switches between dark and light mode at random in every app just to keep things exciting. In previous careers, she has been a front-end developer, a .NET developer, a consultant, and a build server goblin, and looks forward to the day when database cartoonist becomes an essential job. Martina's talk title is The World's Worst Pool Party, Connection Management with Prisma. Quick reminder that you can post your questions in the Prisma Day Slack channel, and we'll get to that in the live Q&A. So now I bring you Martina.
Hello, everyone. My name is Martina Velander. I am an education engineer here at Prisma and primarily responsible for writing documentation in my team of now 2 documentation writers. I am a former developer that decided to write docs and also a Swede that decided to move to Denmark. And you can follow my inability to make up my mind about anything on Twitter and GitHub with the links on your screen now. And I'm here today to accompany you to the world's worst pool party. We are starting Prisma Day with a primer on all things connection management and Prisma. And for those of you that are already well-versed on this topic, there will be plenty of cartoons to enjoy instead over your morning or nighttime coffee. And I'm doing this presentation because I suffered through writing the docs. So this is essentially a dramatic reading of the connection management guide. And you can find the fruits of my bitter writer tears on the doc site if you search connection management. And there I am crying over text, just another Tuesday. So onwards, today you're going to meet a varied cast of characters, all hand-drawn, that includes your long-suffering database and all its needs and limitations and demands. And of course, Prisma, with its little pool of wriggly connections. It's a pool that can be configured and tuned to maximize throughput, and we're going to learn how to do that today. Our story takes us through the following 4 questions, things to ponder in the pool. So first of all, why does a database get tired? What does it mean to exhaust your connection limit? What is the Prisma client connection pool and how exactly does it work? And how do I tune and configure my solution to get the very best out of my database? And last but not least, what's the big deal with serverless connection management and why should I be a little bit scared? So let's dive right in, no apologies for the pun, with why does a database get tired? So I'm going to use Postgres as an example for most of these. And you might have seen an error message like this one, connection limit exceeded. Or maybe this thrilling message, sorry, too many clients already. This is your database telling you that you have reached its configured connection limit, which for a plain old Postgres database hosted locally is 10 with 100, cannot read, with an additional 15 for super users. If you're using something like Heroku, their dev and basic starting tiers give you about 20 connections. And if you're using Amazon AWS, then this fancy little formula calculates how many connections you have and your connection limit. And for TT too small, it's about 198. So it all depends on what you're paying for and where your database is hosted. And no matter how fancy your database is, it's going to respond like this if you make too many connections at once and stress it out. Limit exceeded. So no more connections allowed. It's just gonna not serve you. And that's because connections use RAM. And if there's no more RAM allocated to create connections, then there's nothing the database can do. And you're like, okay, well, sorry, I had some unexpected traffic, or my app is just growing. I'm selling cake. It's really popular right now. And you might, in your mind think, can I just increase the database connection like a little bit? And I'd say, yes, you may be so bold. And eventually, most apps need a slightly chunkier database, but not as the first step. So here's why. If you have a hosted database, it's probably going to cost you, especially if you're just using an increased connection limit to put a Band-Aid on another issue. And if you host it yourself and you are responsible for the hardware and you decide to set a really high connection limit, then a great mother operating system might eventually shut down your database because the amount of RAM being used is threatening her general well-being. So to start with, what we need to keep the database from getting exhausted and too tired is a pool and a queue. And that brings us on to the first bit of our architecture, which is the Prisma client connection pool. So connection pools, I mean, the Prisma aren't the first people to come up with a connection pool. It's a fairly common concept, but I'm going to tell you how this one works. So the Prisma connection pool dictates the maximum number of concurrent connections that an instance of Prisma client will open to the database. And this value is configurable, but there is a default based on the number of CPUs you have, and we'll look at that formula later. So when your client starts up, queries start coming in, boom, there's your pool of connections. And here is how this connection pool works. So first of all, The query engine generates queries. For instance, get me all the blog post, insert these orders, filter these plumbuses, or delete all of the dingle hoppers, whatever your business model happens to be. These requests are handled by a little pool of available connections, so our Brave 4 that we've created for example purposes. And they take these requests and send them onto the database, which apparently I've decided is right through its brain. And Prisma will never let more than 4 simultaneous connections through, and the database doesn't get overwhelmed. So it's just a happy story. Pause for water. Then the other cool thing is, if there are too many requests coming in, they get added to an orderly queue. And I really do mean orderly. It's a first in, first out queue. So the first query to come in should be the first one that's dealt with. And you might, in a moment of scaling mischief, ask yourself, can I just let the queue grow and prevent the database from becoming overwhelmed? And sometimes, but we'll get to that. So not really, because there is this timeout. And queries will expire if they're in the queue for too long. Kind of like in that movie In Time, where people die once their clock runs out. It's really morbid. I've tried to capture the horror of the movie in this diagram here with the little SQL query getting sad because his friend's exploding. You can actually disable this timeout if you think this is too traumatic. And let the queue just grow. But then you really need a lot of RAM because it's an in-memory queue and therefore a potential RAM gobbler. And a long queue of queries also means a potentially longer waiting time for a response. So tread carefully there. There are some instances where it makes sense to really increase the timeout or disable it completely. But we'll get to that a little bit later. All right, so you have a pool now and you have a queue. It's all very exciting. Let's tune and configure the living crap out of this pool. Starting with something completely unrelated to configuration settings, and quite a common problem that we see cropping up, and that is that you need one Prisma client to rule them all in your app. So I mean, instantiate Prisma client once and reuse it. And here's why. When you instantiate the client, you create a query engine or an instance of the query engine, and you create a pool with our 4 little cuties here. And if you instantiate clients all over your app every time you want to use Prisma, you create many clients and therefore many engines and therefore many pools. And Prisma, this is important, does not currently do anything under the hood to merge these instances. So what you're going to end up with is you think you have a pool of 4, but you have so many client instances that you might have a pool of 30. And now you get this error again because you're passing on too many connections to the database and it gets tired. So making sure you only have one instance looks something like this. I'm going to show you a part of an Express app that hosts a GraphQL API. So here we have the root of the Express server. And inside app use, you pass in a context. And in that context object, you have your Prisma client. And that Prisma client, because it's exported from this module, it gets cached and reused across the entire application. And you can guarantee that there's only ever going to be one connection pool. Related to this, somebody somewhere on GitHub had this splendid idea that you can use a linter to make sure there's only ever one instance of the client. It's really useful if you have a big project or disparate teams that don't necessarily talk to each other. So you'd make up a rule that says only one instance of Prisma client, and then you'd get a warning if you try to create more. While we're on the topic of Prisma client, let's go through a couple of extra Prisma client tips that are related to connection management. So tip number 1 is that there's no need to explicitly connect or disconnect. Prisma connects lazily when the first connection is made. You can, of course, call connect if you need an instant response, but you don't have to do it. And for our purposes, disconnect is probably more important, because if you disconnect every time you issue a query, you then have to reconnect again next time, and establishing a connection takes time. So you should reserve explicit disconnects for when you're running like a one-off script to do a job and you really do want to disconnect, but you don't need to do it in a long-running application like a website where you don't need to disconnect because you're always serving requests. So that's a little performance tip. Next is Next.js. Tip number 2. If you're using Prisma with Next.js and you're using hot reloading in a dev environment, that's to see changes as you develop your app. That's cool. But to do that, Next has to refresh the module, potentially to refresh the module that exports the Prisma client. And remember, we're relying on caching to have only one instance. So you might see in a dev environment, another client being created or multiple other clients, and suddenly you're exhausting your connection limit in a dev environment, and that might be really concerning. But all that's happened is that the caching isn't working as it should in a Next.js context. There is a workaround on the doc site that you can search for, but in short, you need to store the Prisma client as a global variable and just do that in dev environments. So that means it doesn't get cleared. So that's another Prisma client tip whilst we're talking about the Prisma client. So you have a pool, you have your client. Let's tune the pool. So in case you missed it, here's our pool. And we have a couple of configuration options at our disposal. The first option is called connection limit. That's not to be confused with database connection limit. That's configured on the database end. This is the maximum allowed pool size of connections, these little guys. And we'll talk a little bit about the specifics of this setting. So it's calculated by this formula by default. So if you have 2 CPUs times 2 plus 1, that's 5 as your maximum connection limit. But you can also set it manually by appending connection limit to your connection string. The pool size should generally be less than the database connection limit, so you're not letting through more connections than your database can handle, because that would be mean, I think. And also be aware of other apps accessing the database. So if you have multiple apps with connection limits accessing the same database, then you got to share. You got to be nice to each other. So that's the connection limit parameter. The second one is this pool timeout. And that concerns that queue we were talking about of queries coming into the pool. And this setting determines how long queries sit in the queue until they expire. And as we said, if you have a really massive queue, you're eating up RAM and you're also potentially delaying the response time. So why would I ever use this parameter? Well, there are some scenarios that make sense. So let's say you're importing several 100,000 rows as part of an update job that you run every week. You're going to be submitting batches upon batches of update queries, and you just want them to be handled at some point. So you might actually be okay with the queue getting quite large. In fact, you might not only increase the wait time, you might just disable the queue entirely because you have the RAM and you're just doing it, and that's fine. So that's one of the scenarios where it's sort of okay to have a massive queue and take up a bunch of RAM and just let it do its thing. But ultimately, it's about balance. So achieving some kind of balance between what your database can handle and making sure your requests are handled in a sort of sensible time frame, and paying ideally as little as possible for the actual database. So a lot to think about. So that's a connection pool and how to tune it and configure it and when. So I feel like, now we're older and we're wiser and we're done and know because serverless. All right, let me tell you about serverless because this caused me quite a lot of pain when I was trying to figure it out. Serverless and connection management. So here's the challenge. And I'm going to be using AWS Lambda as an example. And in AWS Lambda, you create these little Lambda functions. And the idea is that they spin up, they do a task like book a room or buy a cake. They're isolated unit of functionality, and then they're done with their job. And you can use Prisma on board this little Lambda function. And as you can see, it has a connection pool. Now imagine this happens. So for one night only, rooms are very discounted, or cake is very cheap, or whatever your business model is, and you get a massive spike in traffic. It's beyond what you had anticipated from the point of view of your database tier. It's just crazy. Luckily, you have AWS Lambda, and behind the scenes, Lambda scales to meet demand, and that is what it's supposed to do. So you're going to get copies of these functions running like, okay, yeah, take in the bookings, do it, cake, wow. Which is a good thing. It's what it's designed to do. Here's the problem with databases, though. Suddenly you have 200 concurrent Lambdas, and each of them has a Prisma client, and each of those has a pool. Let's go through that slowly. You have 200 concurrent Lambdas floating about in space. You have 200 separate Prisma clients also floating around in space. Each one of these has maybe, let's say, 5 connections per pool. I think that's what the default ends up being if you don't set it explicitly. Just some seconds here to do some maths. That's suddenly 1,000 connections because of this spike. That is a very large and scary pool of connections, which equals a very scary database. It just wasn't prepared. So that's the problem with serverless. The functions scale, but the database does not necessarily scale, or at least not that fast. So you might end up, losing queries because your database can't keep up. So what can you do? We're going to start with some small potato stuff. First of all, you can instantiate your client outside of the function handler. That means this. You can see there's a new Prisma client above the handler, and that is supposed to increase the chance, but absolutely not guarantee, that your instantiated client gets reused. You have no control over when AWS decides to close down a container and spin up a new one, but this gives you a chance at least. The second thing you can do is set your connection limit parameter, your pool size, to 1. And what this does is Prisma will only allow 1 connection through at any one time. The net effect being that in your swarm of Lambdas over here, each one is only able to open 1 connection. And you might think, oh, but aren't the queues going to get enormous? Isn't it better just to have more connections? And the answer is it depends. So setting the connection limit to 1, it might be appropriate if 1, you are not using a connection pooler. More on that in a couple of seconds. And if you've designed each of your Lambdas, or if you've designed your Lambda function not to run a huge number of concurrent queries, then you're not going to have a queue. It's going to spin up, do its 2-3 queries, and done. So the queue shouldn't add a lot of waiting time. All right, let's say you've done all this, you're still exhausting your connection limit, especially during traffic spikes, which is the big problem. You might even have set a concurrency limit for your Lambdas, but you're like, oh, but then I can't, then it doesn't scale in that wonderful way. So the answer to that is that you might need a bigger pool, specifically something called a connection pooler, and specifically something called PG Bouncer. PG Bouncer is supported by Prisma. You make a few tweaks to the connection string for your database, and then you can use it. PG Bouncer, in my mind, would look something like this, the strongest, swollest database and pool in all the land. And the way it works is it sits between all the Prisma clients coming in, all the Lambdas, boom, there it is, and the database. So as connections come in, PG Bouncer pools them and also puts them in a queue and only passes them onto the database when the database is ready. So it's like a super mega pool, the great defender against the Lambda horde. And generally, this is a pretty good solution to the serverless challenge for traffic spikes and that sort of thing. And now we're kind of coming to the edge of my research for the docs, but what lies beyond PG Bouncer? So I had a little bit of a chat with everyone at work and a little bit of a research. And here's just some things you should consider. Beefier databases and different architectures, aka the end of my knowledge and aka food for thoughts. These are just ideas. So for instance, you might want to consider a database architecture that's been built for serverless, like Aurora Serverless v2. It was launched in December 2020. It's still in preview, I believe. And the thing here is that you don't choose a database class size, you choose a range. So you are anticipating, that kind of scaling. It auto scales on demand, apparently quickly. I haven't tested it myself. And with something like AWS RDS, which does scale, I think you had to scale manually, which isn't what you want. So that's the promise of Aurora Serverless anyway. And I can see that loads of other vendors are starting to do a similar thing where they want to help you solve the serverless problem. So option one, beefier database, which is always good, but of course it's going to come with costs. You might also want to start to think, is my architecture really suited to how my app has evolved? So the second thing to think about is architecture. And I'll leave you with this final picture of a cake and some words. So I've been thinking, perhaps you have one layer or one horde of Lambdas exclusively responsible for handling incoming requests, like buy a cake. So you scale out infinitely to capture all these requests for cake. Maybe you then write these requests to a highly scalable queue instead of directly to a relational database. Perhaps you then have a second Lambda responsible for reading these messages. The Lambda uses Prisma client. It has maybe a concurrency limit, so it never gets out of hand, which is an AWS Lambda thing, like how many concurrent Lambdas can I have? And maybe it sends queries in bulk with a create many to avoid stressing the database. So you've separated your architecture out into two parts: the data collection piece, which needs to be able to handle a fire hose of data, and the writing to the database piece, which maybe can take a bit more time. It's just an idea, not preaching by any stretch. And now you know as much as I do about connection management with Prisma. And I hope I have given you a decent overview of connection management in general and the sort of buttons and levers you can modify or tweak in Prisma. I hope I've given you ideas to research, or if none of that, I hope I have given you a good laugh to start your Prisma day. Thank you very much for your time.
Okay,
Testing.
so our very first question is, AWS has its own connection puller called RDS proxy. Does Prisma support RDS proxy?
So you can use it, but it will not give you any benefit. And that is because Prisma client uses prepared statements. And when RDS proxy receives a prepared statement, it will pin your connection. So your horde of Lambdas will come, your queries will come in, and because they're prepared, you'll get a pinned connection rather than the connection being able to be reused for all the incoming queries. So you just won't get any benefit from using it, but you can, but there's no reason to really.
I see. And now PG Bouncer only works with Postgres as far as I know. Is there an equivalent for users who are using MySQL?
So nothing that we have tested. I think there's even a live issue to try Proxy SQL as an alternative. So you can follow that on the Prisma GitHub issues list. But I think Postgres, it's quite expensive to make connections, and I think you have maybe less of an issue with MySQL, but I think it's on the list to be investigated.
All right. We also have an upcoming talk about planet scale, so I'm sure that we'll get a chance to get a look at that from the perspective of planet scale. We have one more question. So You mentioned that you need this sort of connection parameter when using PG Bouncer with Prisma Client. Why is that weird connection parameter necessary?
Okay, so if you use Prisma, which I'm sure all of you do, you have a connection string, and then you have this little, by the way, use PG Bouncer at the end. And you might wonder, like, why do I need that? And here's why. Again, it's to do with Prisma using prepared statements. In order to send a prepared statement onto PG Bouncer needs to be in transaction mode. And that is because with PG Bouncer, if you're not doing everything in transaction mode, then it might prepare the statement on one connection 1. You've made your pasta in your restaurant, and then try to run it on connection 7. So it's, you're not going to put your pasta on your plate. So in order for these two things to happen simultaneously, and for the connection to, or the query to go through, Prisma needs to know, like, oh, hey, I'm about to send something to PG Bouncer. I need to do it in a transaction, even if it's just reading some data. So it's a way to tell Prisma to do certain things slightly differently, because the sort of hole that's flinging its connections into expects something different. So that's why you need that little parameter to change Prisma's behavior slightly.
I see. Let's see if we have any more questions coming from our audience. So we had Dries, who made a comment, I'm never going to think about PG Bouncer the same, thanks to Martina's cartoon. So thank you for the cartoons.
Oh yeah, that was a horrifying one. It was the last one I drew, so it was, the well was pretty dry at that point.
Yeah. All right, and if there aren't any more questions coming in, I'd like to thank you again, Martina. It's always a pleasure viewing your talks, and hope to see you soon.
Thank you very much. Enjoy the rest of Prisma Day, everybody.
Okay, I am now honored to invite Scott Chacon. Scott Chacon is the founder of Chatterbug, a San Francisco and Berlin-based online platform for language learning. Aside from Chatterbug, Scott has previously co-founded GitHub and is a renowned entrepreneur known for his numerous achievements, keynote talks, and speaking engagements in conferences. Scott's talk title is Get a Safe, Minimized Version of Your Production Database on Your Laptop in Minutes. So now, without any further delay, I bring you Scott.
Hello, everybody. My name is Scott Chacon. Thanks for having me. I did want to talk a little bit today about databases. I find databases really interesting in the software development lifecycle because there's something that we don't have a lot of developer tools for. I think, I was one of the co-founders of GitHub. I spent a lot of time thinking about the development lifecycle and developer tools. And one thing that I've worked at in every company that I've worked at, including GitHub, is how difficult it is to work with databases in development. Most of the time, they go down one of a couple of different routes. Either we do seed data, which I can kind of demo real quickly. So if I was working on a Prisma project, for example, in Redwood, I would reset the database, or I'd start up a new one and I'd run a seed on it, and I would say, okay, great. And then the problem with this is that it's very, very difficult to keep this close to production, to keep it close to the data you really want to do. It's impossible to debug problems. It's usually a minimal set of data, so you're not dealing with a lot of performance issues. And it's very hard to keep up to date. So I don't think I've ever spent any significant amount of time on a team that could keep that up to date in a realistic manner. And have data that was really valuable for people to work with. On the other hand, you can download a copy of a production database, which has happened in every company I've worked at, including GitHub, and run it on a local developer laptop. And that's bad for lots of reasons too, right? It's really big, it's really slow. In a lot of cases, you can debug data, but you have personally identifiable information on everybody's laptop, and that's really not ideal. One of the things that we're trying to solve, me and Peter Pistorius, who's one of the core developers on Redwood, is to help make working with development data a a little bit easier. And so we're doing that with a project that we're calling Snaplet. And so what I want to show you here is sort of an example of what that might look like. So I did a quick demo of just kind of something that normal people would run into when working on something. So if I've seeded my database and I run my Redwood project here, you can see I have a couple of customers in this sort of video rental thing. It's really beautiful. I think everybody can appreciate the beautiful design that went into this, mostly on my part here. But we can see we have this development snapshot. Everything looks fine. The video is returned. If we actually go to production, so here's our production. Somebody's told us this problem that this person is both returned and not returned. How does that work, right? And it's really difficult to figure that out because I can't. You can shell in somewhere and run SQL commands and try to figure out what does the data look like. You can actually look directly at the database, but actually to debug this is difficult. And I think everybody's really run into a problem like this. So what I'm going to do is I'm going to demo what Snaplet looks like. So Snaplet, essentially what Snaplet does is you connect to your database. We will pull it down. We'll clean any information that we need, and then you can get a copy of that. We make a snapshot of that every day, and you can pull down a cleaned sort of version of that database and load it into your development environment and use that in a way that is easy and fast and not dangerous. And so if I here type Snaplet restore, what it will do is pull down a snapshot of the development of the cleaned version of the production database and restore it locally so that I can work on it in a safe manner. And so I'm going to back up my database that I was working on. So I have a copy of it that I can go back to. And it says that it restored the snapshot. So now if we go to production, before we didn't really have, we only had a handful of customers. Now we have essentially all of the customers that we have in production, except they've all been anonymized. And so I can actually take this same customer ID that we have in production, and now I can pull it up here. And you can see also that instead of Scott Chacon with my email address, don't email me. I'm just kidding, you can email me. We have, Betsy Hain with a completely made up faker email address, and we can go through in Snaplet and we can decide, for any of these, what tables do we not want to include. If they're really big log tables, we don't have to pull them down, saving us some time and space. We can replace, we can say what are P2 sort of suggestions, and we can say replace the city with sort of faked cities and things like that. And the next snapshot that we make, it will clean that data out. So I hope that you've enjoyed this presentation. I thank you for your time, and enjoy the rest of Prisma Day.
Thank you, Scott. Snaplet looks like a really useful tool when trying to replicate your production environment locally. I should say, if you have any questions about Snaplet, Peter, Scott's co-founder, will be also hanging out in the Prisma Day channel, so feel free to hit him up with any questions you might have. Now, I am thrilled to invite Nick van Vigeren. Nick van Vigeren is the Director of Engineering at PlanetScale, where he runs the teams responsible for the API, front-end database clients, and much more. Previously, he worked all over GitHub's product and in many other developer-facing products that you know and hopefully also love. Nick's talk title is PlanetScale in Prisma, Building in the Cloud. And now I bring you Nick.
Hi, everyone. My name is Nick Van Wiggeren, and I'm a Director of Engineering at PlanetScale. Today, I have the pleasure of presenting our product, how it works with Prisma, including some tips and tricks, and to look to the future to understand how the two of us are working together to build the best possible cloud database experience. Before I go any further, I'd love to talk about why we built PlanetScale and what it is. From a high level, we built PlanetScale because we were frustrated with what exists in the database world today. We feel that databases haven't kept up with the rest of software development. They're crufty, old, and difficult to use. We've made huge strides in how we deploy and scale applications, and databases just haven't kept up. They're difficult to scale, they're difficult to change, and they're extremely difficult to debug when something goes wrong. If any of this sounds familiar, you probably understand why we built PlanetScale. One of the most important decisions that we made was building the product on top of Vitesse. If you're not familiar, Vitesse was built at YouTube to handle the outrageous scale of the website. Vitesse allows MySQL to scale out in immense ways that weren't possible before. For example, one Vitesse instance, one PlanetScale database, can scale to thousands, if not tens of thousands of connections without worrying about adding proxies or bouncers in front of it. And the best part is all of these code paths are proven at scale. These aren't new technologies being developed right now. They're already running on some of the hyperscale websites that you're familiar with. You can sleep soundly at night knowing that other companies have paved the way, along with the Vitesse team, at making sure that these technologies will work no matter how big you grow. But underneath, it's still the database that you love. It still looks like MySQL. If you're using Prisma, Rails, or any other technology, you can rest easy knowing that you won't have to make massive modifications to your application in order for it to work with PlanetScale. You won't have to learn a new type of SQL or learn how to deploy a new type of database. It just looks like MySQL, but it's much better. We call this zero to scale. The user experience that we've built at PlanetScale will help you get going from day one, but can help carry you as far as you need to go. Whatever growth you're planning, whatever growth you anticipate, don't worry. PlanetScale is right there with you. And we've done it all while building for developers. We're software engineers, and we've used all the databases around. We know how they tick, and we know why they're difficult to use. So you can trust us to make sure we've built a product that you'll love to use and that you'll love to keep scaling with. The best example of this is the concept that we introduced of database branching. Fundamentally, the way that we change code and the way that we change databases is incredibly different. With code, it's very easy to create a new branch and start risk-free experimentation. With databases, you have to stand up a new instance, copy the schema over, get seed data, or copy the data over. It can be quite a bit of time before you can just get to experimenting with the database. What if it wasn't that hard? What if creating a new branch of your database was as easy as typing a single command? I'm happy to tell you that it can be. With PlanetScale, you have developer-focused workflows that never leave the command line. If you want to experiment, change a row, remove or add a whole table, all you have to do is use the pscale command, create a new branch from your production database, and you can start experimenting. These commands here show a complete deployment workflow. A user is able to create that new branch, add an entire new table for the feature that they're adding, create a deploy request, examine the difference between the database that they were experimenting with and their production database, and then go deploy it right to production. And the best part is those deploys are safe, and those deploys will not impact production negatively. With PlanetScale's non-blocking schema changes, you can trust that when you click that deploy button or run that command, behind the scenes, we're making sure that the schema that you have and the schema that you created are compatible. There are no problems, and we're deploying it in the background in a way that won't impact performance and won't bring the website down. This is all done without writing a single line of code on your end. It's just part of the deployment flow of using PlanetScale. That probably sounds pretty cool. I'd love to show it to you in this demo. Now, I'd love to show off that same workflow we just talked about, but using Prisma. Down here on the command line, I've created my database, and I'm going to go ahead and create my development branch to add the blog. I'm also going to create a shadow database, which will help Prisma understand the difference between the two branches. Up here in the code, I've got my Prisma setup configured. I have my two models, a post and a user, and then I've got my database set up. As you can see, according to Prisma, I'm just using the MySQL provider, and then I've got some optional configuration over here in PlanetScale mode, which I'll talk about more a little bit later. I've also got my database and shadow database set up to copy from the environment. And if we go over to this, we can see I've just got it configured to point at localhost. That's because I'm going to be using the pscale CLI to create secure tunnels to both of these databases so that I never need to worry about passwords or any other authentication. We're going to go ahead and spin up that proxy I was just talking about. This will securely tunnel on port 3302 back to my add blog branch. And this will tunnel port 3301 back to my shadow branch. Once these are up, I can go ahead right here and I can go ahead and run db push. This will tell Prisma to go out to PlanetScale and take a look at the difference between the two database branches. Prisma will spin up, connect to the proxy, and it'll say, congratulations, your database is now in sync. This has just gone to our development branch in PlanetScale and synced the state of my Prisma models with that development branch. This hasn't deployed my schema to production, but it is part of the overall code workflow and database branch workflow that we have here at PlanetScale. What I'm going to do next is I'm going to go ahead and I'm going to create a deploy request from my add blog branch to my main branch. This goes out to PlanetScale and it says, hey, I just added the schema in add blog. I want to see what it would look like if I were to merge it back to main. This is very similar to a merge request or a pull request if you were writing code. Much like that, I actually can go ahead and look at a diff and see what's the difference between those two schemas. As we can see, it's pure addition. I've created a post table and I've created a users table. Because I have that deploy open, I can actually just merge it. So let's go ahead and click deploy. This goes out and says, hey, PlanetScale, I want you to use your non-blocking schema migration, and I want you to make my main production database look like this development branch that I just checked out. We can see what that looks like by hopping onto a MySQL shell, again through the pscale command line, which will connect us to PlanetScale. And I can go ahead and see we created those two tables. And that's it. Every schema migration that you do can be as easy as running these sets of commands and deploying them to PlanetScale. There's no need to worry about downtime deploys. There's no need to worry about what's going to happen when larger changes are done. PlanetScale will handle making sure that your database looks the way that you want. It's this easy. That demo was great, but only showed us adding a little bit of schema. Let's take a look at what happens when we want to modify our schema. Right here, as we can see, I still have my main branch, which I just merged some schema into. I still have my shadow branch, but I've created a published at branch. And that's because instead of having a Boolean to determine when I've published a post, I want to create a timestamp so that I can schedule things in the future and so that I know the time that my documents were published at. So we're going to go ahead and we're going to change published to published at. We're going to make it a date time, and we're going to make sure that the default time is now. Just like that, I've updated my Prisma models. Let's take a look at what it looks like if I want to change those in PlanetScale. Over here, I'm going to repoint that proxy on port 3302 to point at my new branch. I don't have to update my Prisma configuration because it's already pointed at localhost 3302. All it's going to do is get the difference. Over here, I'm going to rerun db push. Now that I've started that proxy, let's see what happens. It's connected, and now my database is in sync. It's now going to look at generating. I probably should have skipped the generators, but that's okay. Generated the Prisma client. Let's go ahead and do the same thing we did before. Let's go ahead and create a deploy request. So instead of using the add blog branch, we're going to use the published app branch. Let's create that deploy request in PlanetScale, and let's go ahead and let's get a diff. What do you say? So this is going to be deploy request number 2. We're going to go ahead and we're going to ask PlanetScale, hey, what looked different? And look at that. Just like we saw before, instead of just adding this table, I've gone ahead and removed the tiny int, which is how it maps a Boolean, and we've created a date time with the default of the current timestamp. Just as we did before, I can go ahead and I can deploy my deploy request number 2, and PlanetScale's gone and done it. Let's go ahead, go look at the shell, hop into that MySQL shell, and we'll do a describe post table. And look at that. No more published, and we've got published ID as a date time. Again, all your schema changes could be this easy. That's the power of PlanetScale. Let's take a look at what this looks like on the website. As we can see, I'm in the PlanetScale application looking at my Prisma database. If I go over to look at the branches tab, I can see I've got my production branches over here, the main branch that we've been merging things into, and I can go ahead and take a look at my schema. This is a representation of what my schema looks like today. We can see the published at daytime that I changed is reflected here, as well as all of the other schema we've created. We can also go back to the home page and we can take a look at the deploy requests that have happened in this database. The two that we did during this demo are both here. I can look at the add blog deploy request, which tracks the addition of these two schemas. Notice the old style published. And I can also go back and look at the second deploy request, where we modified that schema slightly. This has the same diff that we saw in the command line, and a summary of what happened. It looks like it took a total of 8 seconds to get that merged, which could be faster, but I can handle. Of course, if there was a bunch of data in the table and we were making larger modifications, this might take a little bit longer, but it's pretty much instant right now. As I start to use this table, as I start to read and start to write, we also get some stats here. We can see the query load as well as how much storage we're using. Right now, I don't have a lot of posts. I think I need to scale my website up a little bit, so I'm only using 1 megabyte of storage. Hopefully, you all have a lot more to store than that. We'd love to get your data on PlanetScale. All right, let's recap what we've seen so far. I showed a little bit about the history of PlanetScale and why it exists. Then I gave a demo of using PlanetScale and Prisma together to create a brand new database, seed it with some schema, and then modify that schema all through the Prisma client and the PlanetScale command line. We went over how that can be done safely and securely, time and time again, in an environment that looks a lot more like code modification than it does changing a database. We also showed what those processes and steps look like in the PlanetScale UI to show what we think the best practices are around how to change your schema. I hope this has been edifying and informative, and everyone is ready to give PlanetScale a try. We're really excited to have more and more people sign up and try it out while we're in beta. Your feedback is essential to making sure that we build a product that all of us want to use. In that vein, we're working very closely with the Prisma team to enhance the experience. There are a number of blockers and pieces of friction right now that make using PlanetScale and Prisma just a little bit more difficult than we would like. A very good example of this is making sure that Prisma and PlanetScale's support of foreign keys don't cause people to run into issues. Right now, there's a PlanetScale mode flag that needs to be enabled so that Prisma won't try and add foreign key constraints, as PlanetScale's online schema migration flow doesn't support them. We'd love to continue to evolve how the Prisma client tracks this so that it feels a lot more natural to turn these off. And we'd love to continue to add documentation and resources to help people understand why PlanetScale has made this choice. There are also a couple of features that we'll be adding in the very near future to make using these two products together much easier. The biggest one is connection strings. Right now, the primary method of connecting to a PlanetScale database is using our CLI, which creates a proxy. This is awesome for local development because it means you never have to reconfigure your client. All you have to do is pick the database and the branch and create a secure tunnel to that database. This is encrypted over the internet. It means that you can easily swap connections no matter what. However, this also causes some difficulty. In serverless and other deployed environments, it can be very difficult or impossible to run this proxy alongside your application. PlanetScale is acutely aware of this blocker, and we're working on adding connection strings to the product that you'll be able to copy and paste from the UI, API, or CLI. This will enable you to safely deploy your application and connect to PlanetScale just like any other database as a service. I don't have an exact date for these, but just know It is incredibly important to us, and we're working on them as quickly as we can. We're also working on tracking Prisma migration metadata. This is metadata that Prisma adds to the database every time it runs a migration on your behalf. This allows it to check what's already been run and allows it to make sure that things are functioning properly. Right now, the merge process doesn't copy that data from your development branch to your main branch, or when creating a new branch, from your main branch to your development branch. PlanetScale currently has this feature for Rails, where it will look at the data in the schema migrations table and copy it around. Very soon, we'll be enabling this for Prisma as well to make sure that the migration flow works as you would expect it. Hopefully, you'll hear more from both PlanetScale and Prisma about this very soon. There are a number of other smaller considerations that both of our teams are tracking. In this issue, 7292, in the Prisma repository, there are a list of current blockers and workarounds and/or processes that we're working on to make them better. Both of our teams check this very frequently and are actively working on making sure that we can reduce this list to as small as possible. We care very deeply about this being a good experience for both users, and we're very excited about making sure that PlanetScale and Prisma work incredibly well together. As I mentioned earlier, we would also love to hear your feedback. The more people that we have on PlanetScale during our beta period, the more users and the more we understand about what people want out of a developer-focused database. We love hearing from developers, and we want to hear from you. Please use PlanetScale. Please write to support. Please tweet at us, or whatever method of communication works best for you. We would love to know how you're using PlanetScale, how you want to use PlanetScale, and if there's anything standing in between what you want to do and what you're able to do. Thank you so much for your time. Again, my name is Nick Van Wiggeren. This is my Twitter handle. Please feel free to follow up with any feedback, questions, or concerns. I would personally love to hear from you, and I know the rest of PlanetScale would as well. Thank you so much.
Well, that was a thoughtful and thorough introduction to PlanetScale. Thank you, Nick.
Yeah, thanks for having me.
I must say that I've been personally excited about PlanetScale, I think since your announcement back in May. Yeah, I think we're going to do a live Q&A, and a quick reminder to our viewers that you can drop your questions in the Prisma Day channel on Slack. Nick, are you ready to take some questions?
Let's go for it.
All right, let's do it. So I saw that you have quite a generous free tier that includes 3 free databases with 10 gigabytes of storage each. What should developers know about this?
Yeah, I think that the message that we want to send to developers is that PlanetScale is a place to build. And in my talk, I said, I think 0 to IPO is kind of how we think about it. And we just want to make sure that we really hit that 0 mark well. We want to make sure that when people come and they're looking to start off, they know that PlanetScale is something that they can actually build a real production service or real production website on, and we will be with them the entire journey. And we strongly believe that the most important part of that is helping people get started out. So we think our free tier is generous. We're very happy to be able to offer that generous free tier, and we plan on continuing to do that as PlanetScale continues to evolve, because we know that what developers want is a powerful database, and the fact that we can offer it for free, we hope will hook them and make them not want to look anywhere else.
Got it. So sort of like referring back to Martina's talk previously, which talked about some of the difficulties with connection management, how does PlanetScale work in serverless environments where there's a lot of database connection churn?
Yeah, that's a fantastic question. And that's something that we're really proud of hoping being able to solve in PlanetScale as time goes on. Because PlanetScale is built on top of Vitess, and because it uses some kind of technology from other hyperscale companies, we've actually been able to largely avoid needing to have the user really think about connections at all. We've seen, single Vitess instances support 10,000, 20, 30, 40, wow. 50,000 connections at one time. I wouldn't necessarily recommend going out and saying, I'm gonna throw 50,000 connections at my free tier PlanetScale database today. But we're lucky that essentially we have our own built-in kind of, what you would say PG bouncer or serverless MySQL that can handle kind of combining all of those connections down into something that MySQL can handle. So it's one of those areas where even as we build out the serverless experience, and I talked about, in my talk, some of the pieces that we're adding to make it easier and easier, the kind of core infrastructure here is really well set up for the serverless style of deployment, where you have a ton of nodes connecting to a single database. And you need to be able to do that as you deploy and kind of not have to worry about setting up your own infrastructure to handle the database's limitations.
Right. Great. And you mentioned that PlanetScale is built on Vitess, which looks just like MySQL. Are there any differences between Vitess and MySQL that developers should be aware of?
That's a great question as well. And we go through quite a bit of work to make sure that Vitess and MySQL are as compatible as possible. We run through test suites for common frameworks like Django, Rails, Rust, and Prisma to make sure that what works on MySQL also works on PlanetScale and works on Vitess. Sometimes you may run into kind of character, like string parsing differences and things like that. And Vitess will error when maybe MySQL would be able to kind of handle it. And MySQL can, and Vitess, and PlanetScale will get a little bit less compatible as we move into like sharding and things like that. But for the getting started experience, we care very much about making sure that what runs on MySQL runs on PlanetScale and runs on Vitess as well. A kind of quick example about that, as we're building the PlanetScale website, kind of our API and stuff like that, we actually currently, deploy it on top of PlanetScale, but we also use local MySQLs to test and develop to make sure that it's kind of compatible with both. And that's a great kind of check for us because it makes sure, does our own website and the code that we write work on both, a kind of standard vanilla MySQL and a standard Vitess. So I look forward to hearing, and I'm sure people will run into slight differences. No system is one-to-one mapping, but by and large, we hope that from day one, people can start with existing applications or new applications, and they really can feel like it's MySQL.
I see. So does that mean that if you say I have an application that is built with Vitess, that you can locally develop with just a MySQL instance, or what is sort of your recommendation there?
Yeah, we want more people to be doing cloud development on top of PlanetScale. We would like to see people actually, we'd like for ourselves to be able to get rid of the local MySQL, to be able to get rid of the MySQL in CI and actually use PlanetScale everywhere. But it's sort of a phased approach. There's latency concerns. We have people who work on this product all over the world. If you're in Europe and you have a West Coast USA database, for example, the latency there would make development incredibly painful. And so as we make PlanetScale more global, ironically, no pun intended, and as we get farther and farther and farther, we're hoping to be able to make it easier and easier and easier to get rid of local development entirely. But right now, a lot of us are still kind of splitting time between both. And I wouldn't recommend maybe going all in quite yet, but dipping a toe in and going further and further and further as we add more features and things like that.
Got it. Thank you. Now, in the demo, you showcased how easy it is to create database branches with PlanetScale and then deploy those branches back into the main branch. I can imagine that this opens up quite a wide world of opportunities that includes like PR previews that include a database. But more broadly, how do you sort of envision migration workflows in environments where a lot of these application deployments are handled by continuous integration and continuous deployment?
This is a fantastic question. And I think this is an area where we really can innovate in the near future. So part of the reason we built the branching flow and part of the reason we built the schema migration flow is to match the rest of the software development lifecycle, is to match how people write code. Imagine if you had to change your code the way you change your database today, with like every line that needed to be changed was a process that needed to be ran. So we're exploring a lot of different areas. A really good example, I think, of something we'd love to do in the near future is tying in GitHub Actions with PlanetScale. So if you can run your application's migration script in a branch, you can send that off to PlanetScale and ask PlanetScale if there are any differences. If so, automatically open a deploy request and automatically merge that deploy request when the pull request is merged. So I think there's a lot of opportunity to kind of tie PlanetScale in with the rest of the CI/CD workflow. And that's something that we're very interested in doing more and more as the product kind of evolves and as we figure out how our users are using it and kind of what they need.
I see. Thank you. And we're just about to run out of time, but maybe you could just quickly sort of share what can we expect in the coming year from PlanetScale?
Yeah, so I mentioned a couple of features and things like that we're looking at adding immediately. And a lot of what we're looking at adding in the next few months is just making it easier to get started. So we want to help people connect directly to PlanetScale so they don't have to worry about how to deploy PlanetScale. We want to help make it so easy to get started that PlanetScale is the clear choice. And then we just want to continue to add features that people expect from databases. We have a lot of people who are very knowledgeable about databases, and we want to extend their knowledge to everyone using PlanetScale. So how are your queries working, kind of query insights and things like that, all the way over to making sure that, as you're using PlanetScale, we can kind of help you grow and help you scale out. So there's a lot on the horizon, but one of the things we care about the most as we do all of this is kind of developer happiness and making sure it works for developers. So everything we set out for is making it easier to get started with PlanetScale, easier to grow, easier to make sense of what's going on at PlanetScale and things like that.
Nick, it's been a real pleasure having you. Thank you so much for presenting and for the live Q&A, and I hope to see you soon.
Thanks for having me. Have a great rest of your day.
All right. We're going to now take a short break, and we'll be back soon. And a quick reminder before we take the break that ultimately this conference is for you, and we're really interested to hear from you. So share with us on the Slack channel, what are you building? What are some of the challenges that you're facing? And a quick reminder that we also have the raffle. You can find all of the information on the Prisma Day website and also on the Slack channel. So enjoy your break, and we'll see you soon.
Okay, that is a pretty neat bit.
And hit refresh, run that again. Do we get another one? We do. Oh, how cool is that? Nice.
Thank you for giving examples, Prisma. You're the best.
Ooh. Ah, look at that. This is so nice.
I'm not gonna lie, this is really cool. Like, I did not know that this was a feature, and this is a really, really handy feature that this is, a thing that we can just very quickly stand up. I like that a lot.
But yeah, this is awesome. This is really cool.
Exactly.
This loads up in the browser.
I'll submit these links. They're gonna go in the database. This is how easy Prisma makes working with databases.
This is Hudson. He's a 6-year-old Arctic fox who is one of the ambassadors of Woodland Park Zoo in Seattle. We wanted to ask Hudson a couple of questions, and these were his answers. Hey Hudson, are you excited for Prisma Day? Nice. Well, we wanted to ask you a couple of questions. Wait, we haven't even started yet. Come back. Okay, so we wanted to ask you a couple of questions, but before that, do you want to hear a joke? Okay, cool. So a SQL query walks into a restaurant, sees 2 tables, and asks them, "Can I join you?" Come on, it's a good one. No? Okay, well, we have an important question. Do you have any idea about what happened to production yesterday? Hudson, where you go? Hudson? Okay, that's not suspicious at all. Hey, did you know you can use Prisma with Go?
Seriously?
Yes, it's part of the Prisma ecosystem.
So what do we get?
You'll get an auto-generated type-safe query builder, declarative data modeling, schema migrations, and visual data management. So the complete Prisma experience.
That's so cool. How can I try it?
It's still in early access, but we would love for you to try it out and to give us your feedback. So if you're interested, go to Prisly/go.
Welcome back. In the first part of today, we learned from Surin about the direction that Prisma is taking. Martina gave us a visually engaging deep dive into database connection management with Prisma. Scott showed us Snaplet Dev, a nifty tool to get a minimized version of your production database for local development. And Nick from PlanetScale gave us a taste of the future of databases in the cloud: scalability, developer experience, and serverless friendly. Building on the database momentum, I invite you to also check out Prisma's Data Guide. Prisma's Data Guide is an online, constantly expanding resource of tutorials and articles on databases such as Postgres, MySQL, SQLite, MS SQL and MongoDB. And you can find a lot of articles about how to choose a database, how to use them in your application, and understand the underpinnings of how they work. So you can do that at prisma.io/data guide. We'll also drop a link in the Slack channel. Now, let's get started with the upcoming talks. So the second part of Prisma Day will be a showcase of companies using Prisma. And we will start this with a Prisma in Production discussion panel, where you will learn more about real-world experiences using Prisma in production, with a discussion with engineers using Prisma in a variety of industries, and about their highs, lows, architecture choices, and more. And this discussion panel will be also followed by a live Q&A. And so you can, throughout the panel, you can drop your questions in the Prisma Day channel. So now I'm really excited to introduce the participants in our Prisma in Production panel. And I'll start with Ricardo Almeida. Ricardo Almeida is a software engineer at Grover with having more than 15 years of experience, and he's passionate for technology. Ricardo is also a minimalist, a vegetarian, and addicted to sports and Brazilian dances like Foro and Samba de Garafeira. I hope I got that pronounced right. Vasil Popovsky. Vasil is the co-founder and CTO at Panther, a startup that's on the mission to help companies champion talent over location. Vasil is passionate about all things tech. He spends every non-working moment with his soon-to-be 3-year-old getting into random trouble. He also plays the violin, loves gaming, and good craft beer. Finally, we have Emil Fuglin. Emil is a backend and DevOps freelancer. He helps enterprises build products using the latest practices like GraphQL and infrastructure as code. He's been using Prisma 2 in production for almost 2 years and has been an active member and contributor to the Prisma project and community. So now I bring you the Prisma in Production panel.
Hi, everyone. So just to introduce myself, I'm Ricardo, very excited to be here in this conference. And I'm software engineer at Grover, working mostly in TypeScript projects and GraphQL. And we also work with some database optimizations. And that's about me.
Hey everyone, happy Prisma Day. My name is Vasil, I'm a software engineer and I'm one of the co-founders at Panther. So what is Panther? I would say that one good thing probably that came out of COVID is that a lot more people and organizations are recognizing that talent is everywhere. It's not confined to a single country or a region. And because we know this, having our own internal team being distributed and remote, what we do at Panther is take care of all the legal work from compliance with local laws, payroll to taxes and benefits on behalf of our clients so that they can hire the best people globally in whatever country. This matters not just because employees want to find flexible and remote jobs, but because the traditional way of employing people internationally is too expensive and time consuming. To give just a quick example, if you want to hire person X in country Y, you would have to set up initially a subsidiary in country Y, learn all there is to know, like all the details about local laws, compliance, track all the changes, spend literally tens of thousands of dollars into banking fees, deposits, guarantees, and all of that, which can take months. And all of these, like even before you have to hire before you even get to hiring the person. So Panther eliminates all of that because we automated payroll and compliance in one single platform. All the client has to do is add a new hire to the platform, and from that point on, within minutes, we move on to drafting and onboarding the employee. And when the time comes for the whole team to get paid, with a single click in every local currency, everyone gets paid immediately. So if I had to summarize the whole thing, I would say that we are really on a mission to help companies champion talent over location. Thank you.
So hi everyone, I'm Himel. I hope you have a wonderful Prisma Day. I'm a freelance DevOps and backend developer, so I help clients build and make their system into production on various stacks, and one of them lately has been more GraphQL and Prisma 2. And I've been an active member of the community of Prisma. I've contributed a lot to, sometimes to the code base and finding bugs, reporting issues, and I'm really excited by this technology. I'm really passionate about it. So I'm really happy to be on this panel to discuss my experience of making it into production and helping the other developers be productive with it. What are the pitfalls? What are the good things? And why I decided to use Prisma. So I hope this will be informative for you, and as it will be almost for me to meet all my co-panelists, and I hope you have a good day.
Thank you, Emil, Ricardo, and Vasil. It's a pleasure having you all here today. We will start this panel with some quick, fun yes or no questions for which you have the yes. Could you raise the yes for me? And you also have the no. Could you raise the no for me? So the way it works is I will ask the question. As soon as you hear the question, you raise whether you answer yes or no. Are you all ready for this?
Absolutely. Yes.
Okay, great. Let's get started then. So first question, have you ever pushed a breaking change to production? Okay. Will machines rule the world one day? Okay, Vasil is a bit torn. Monolith before microservices. Is daylight savings time a good idea? Okay, next question. Are giant spiders worse than giant chickens?
Oh, yes.
Okay, next question. If tomatoes are fruits, does that make ketchup a smoothie?
Yeah.
Okay, next question. Goats make great pets, yes or no? Next question. Is Switzerland too perfect? Okay. Final question. Is a picture really worth 1,000 words? All right. Thank you so much. I feel like we got the vibes moving. Let's get into
I feel
some...
like I need to elaborate on some of these. But
Yes, please. Feel free to. Maybe we can do a round of the most controversial question that you found from all of these.
Yes, some of them were controversial.
The chickens thing is going to haunt me probably.
Yeah.
Ricardo, what was your most controversial yes/no question?
Oh, that about Switzerland, I had to think a little bit, but yeah, definitively we don't have any perfect places yet. Yeah.
Yeah, I think the most controversial is monolith versus microservices. That you can start a flaming war between any two technologies.
Okay, I think we're ready to get some more serious questions. So, Ricardo, I have the opening question for you, and I'd love to sort of like hear your thoughts and the rest of you. What are your highest priorities right now in your company or even personal projects?
Yes, sure. At Grover, the highest priority right now is growth and acquiring. So a lot of our initiatives at the moment is in the direction of performance and scalability. And in this way, GraphQL is helping us a lot to define our architecture, to be faster, to improve our architecture, and all our initiatives also in front end and infrastructure, everything related to performance and scalability is our goal at the moment.
Got it. Anyone else wants to chime in on this?
Yeah, I would agree. Like performance and security on my end are among the top priorities internally, as well as hiring and expanding the team. Which coincidentally, Prisma, the questions around Prisma are one of the interview questions, and yeah, we do ask people to read up if they haven't worked on or with the platform before.
Got it.
It's an interesting. I think productivity is definitely improve an important point also for me. And because of this, I usually work with smaller clients. So the goal is mostly to ship an MVP or ship a product or features fast, because we only have like a couple of developers and we don't have a lot of time for that to ship. And one of the things is also like I've been working mostly with type safe languages from mostly unsafe types languages before, and I think type safety allows us to also ship faster code. So type safety is definitely important for us, and from a design and just like if you need to do refactoring. So yeah, those are the two things.
And what is one tech industry trend that you recommend or that you have embraced?
Yeah, that's also a good question. And I think it goes also with the typing thing, that I think TypeScript, and I think we all agree probably that TypeScript is a big trend that is replacing a lot of JavaScript in libraries and commercial code base also, because of the type safety. The compile times type safety reduces the amount of stuff that breaks at runtime, and it's just easier to work with that code. You don't need as big of a mental model when you work with TypeScript code, because you know your input, you know your output, and you just have to figure out if you need to refactor the middle. So it's much easier than just like trying to figure out what the hell you got an input and what you need to return to your caller and all that stuff. So and I think it goes with the Prisma ecosystem really well because of the emphasis on type safety.
Yeah, I totally agree in this point. I also see the industries going toward these static typing possibilities, or if it's not originally a static typing language, like a dynamic language, we are providing ways to type our code. So for example, TypeScript for JavaScript, and we have also other cases like Ruby and Python that they have in last versions, the possibility of typing the code as well. And yeah, I love also the example of Rust, because Rust uses the compiler even to identify memory allocations. So it saves on not only the coding, like auto-completion, all this stuff, but the memory allocation as well. So you can identify problems in your code in terms of memory, what is amazing.
Yeah, absolutely. One thing I would add quickly to that, without starting a war, is that we have embraced microservices and sort of a domain-driven approach to designing our platform. And on the operational side, I would just add that we're also fully remote and distributed. So that's kind of a big thing happening everywhere. No central office, no hub, no nothing, just everyone working anywhere they want.
Thank you for all the insightful answers. The next question is, what are the biggest problems that Prisma solved for you?
A bit again on the type safety, and I guess it goes with having this single schema, right? That you used to before. You use either to like do your migration and then recreate that in the model, so you have like both in sync, or you do your models and then generate your migration from it, and then with Prisma, like you have this single place and then you have the single schema, and then it automatically generates the model for you, and then automatically generates the migration for you that you can tweak on the migration side if you need. But like mostly that's really interesting because you keep them in sync. Like you don't have a choice. You never go out of sync with your database, and if you followed all the steps correctly, but like it's really harder to be out of sync with your database. And then you also get, with the type safety, you get a compile time error for every places that that now is like using it wrongly. So you have much less possibility for runtime error in code, especially like for code paths that are less used or like really like infrequently used. So you might not even like, if it was a runtime error, it could take like a week before you detect it, because you never like, it's a one call and then but that call is important, but like if it breaks, you just don't see it after a week. So that I think is the most important thing I got from Prisma 2 compared to other ORM out there for the JS ecosystem.
Yeah, sorry, go on. I also agree, and in our case, is mostly the productivity of using a toolkit to access the database, right? So the typings everywhere, like it helps a lot, and the easy migrations. So working in different branches, and you have the Prisma reset, just get the right state to continue your feature. So it really helps the day working using Prisma. And also the Prisma Studio, sometimes it's handy just to have a place to put your data there. So it's everything. I would say that for me, most important is the typings, and all the other features. It's just aggregating to this excellent tool.
Yeah, Ricardo kind of beat me to it on the productivity, and I was going to say that as well as I would just add time to market, because for a startup it's very important to roll out your MVP or get to like your first user base, and with Prisma doing literally all the heavy lifting for us and just plugging into the API and utilizing all the functionalities and resources, it's been really easy to get from like first line of code to MVP in no time.
Thank you for all the answers. Moving on to the next question, what role does caching play in your architecture?
Okay, I'll take this one. The short answer would be very important. Longer answer, without going into too much like technical details, I would say like performance is one of our main drivers, as I imagine for a lot of organizations and people. So we're still experimenting on like different methods of caching, and have gone through several iterations, both on the front end and back end. On the front end, utilizing even stuff like hashing validations and everything that goes with that. And starting like with even simple stuff like utilizing a CDN. I would say on the back end, there's been a lot of debate around our use of like Redis versus something else, and whether caching should take more of a database layer versus application layer approach, and what the benefits or pitfalls are between both. But overall, it's of the utmost importance because it boosts performance, scalability, and above all availability, especially in a microservices based architecture. If like one node or something goes offline, you still have that sort of a caching layer to rely on to still provide the service.
It's an interesting topic, and definitely evolving. I also think like caching is multiple layers. You have like more edge caching from the front end, and you have like all those clients like Apollo client that does a bit of caching on its own, and then you have like more edge like GraphCDN that just got launched today. Actually, I just received an email. You have GraphCDN, StepZen, WonderGraph, all those types of middlewares that can like cache on the edge. And then most importantly for like the Prisma side is like if you're doing a GraphQL API is like data loaders pattern. I think we didn't touch on that, but like that's really an important pattern for GraphQL. For REST, it's less of a problem. And then also like you eventually will probably have Prisma layers that's going to do some caching too. I'm excited to see what's going to happen there. There's already a bit of batching, but not much more than that. So yeah, I think it's a multifaceted problem. And also like I've seen a lot of people say like you can't cache on GraphQL servers, but that's not true. And we're starting to see that it's just a different way of caching than we're used to.
Yeah, I totally agree. This batch loadings to optimize the querying database, it's really handy. It helps a lot. And the possibilities to cache in the front end side using what you said, like Apollo client and React query and all these things that provide us easy way to cache our data. It's really amazing, right?
Yeah, the data loaders comment was spot on. Like, we do utilize that, and I skipped that for some reason.
That's why we have a panel.
Absolutely.
Okay, so moving on, I think some of you have already spoken about the role of GraphQL. So I'd like to open this next question with, how do you approach building GraphQL APIs with Prisma?
Yeah, that's a good question. In our case, we are using GraphQL Federation and Apollo Gateway as a single endpoint, right? So in this way, we can create our subgraphs, our services behind of this gateway. And it means that in our case, we have different architectures running in the same graph, I would say. So we are free to create new projects and decide the architecture, the language that we want, and in the end, it will be just attached to this main graph. And in this way, we can grow faster. We can create more features. We are more decoupled, and in the end, it helps to deliver it faster to our clients. So that's what it's really handy in our case.
You want to go, or I could just
no
say,
argument. Ricardo just covered 95% of like what I was going to say. So, like, basically just this.
I would add a few things maybe on the. There's an interesting thing right now. Is like, Apollo is pushing hard on their federation spec, but there you also have the guild with schema stitching on the other side, and I think that is going to caught on more and more this year. I'm expecting that schema stitching will be more popular in the end than federation, because it's better integrated, in my opinion. It's just easier, and you have like for example, if you want to do like federation with a code first approach with Nexus or type GraphQL, it's still clunky, not really well integrated, and that's mostly a fault of Apollo that they're not using really standard stuff technically. Like, I don't want to get into the technical detail, but I like it's pretty. It's just like they're using those annotations that are not really well supported back in annotations.
I want to just add the point that is really nice. In our case, we have projects using Nexus and Nest.js, and so having these different approaches, in the end, we don't have a lot of problems using GraphQL Federation, but we do have sometimes some conflicts that we need to solve. So I totally agree that there are other ways to solve and stitch the graphs together. In our case, I would say that it works good, but I'm always looking to other options. That's really amazing to have more options that we always learn with these new possibilities, right?
I agree. And I think we're going to see a lot more push on the code first approach versus, well, that's my opinion. Well, like I don't see like the schema first approach scaling as well for a larger organization. And then it's also like you can build better tooling around code first approach for connections and reusable components like that. So I'm expecting we're going to see more and more of that.
Yeah, and our experience there, for me, code first is much better, like having the code like generated for you. And we are focused only in one language. We don't need to really create all the GraphQL language as well. So for us, it really helps a lot. So we had a project that we started in SDL first, and all options, next options were like using the code first, and it was much better in our case.
For the code first approach, what were you using, Ricardo, if I may ask?
Yeah, code first, we have Nexus, Nest. We have also some other languages using some generated tools. For example, Ruby, there is a gem that generates the code as well. And only one project using TypeScript that we started as the first, but I would say that is harder to maintain, like in terms of creating interfaces, all this stuff. I would say that is better to have it generated and focus on the code. My experience that it's faster in development terms speaking, it's better.
I see. And sort of moving on to the next question, it was quite a nice sort of detour on GraphQL, even going beyond just the actual construction of GraphQL schemas and speaking about, like actually bringing together multiple services that have a subgraph into one sort of consolidated graph and the different techniques there, federation, stitching, and so on. So sort of moving on from there and back to something that is a bit closer to Prisma and choosing technologies. So the question is, what are some of the factors that you considered when investigating and choosing to use Prisma?
Okay, there's a sort of a theme developing over the course of this panel of type safety and microservices, like for which I'm guessing, advocating. So I would, without reiterating everything that was said in terms of type safety and using TypeScript, I would just reinforce our decision by saying that having a microservice-based architecture and relying on a lot of internal APIs, Prisma and the type safety that it provides, it kind of guarantees that the data and the shape of the data that gets funneled through the main GraphQL API on our end is valid and is of a specific shape. Because specifically speaking for our product, runtime verification of the shape of the data is a big no-no. So having Prisma, the advanced guide types that's on your website as well, like the documentation, utilizing that part along with extending on those types as well as TypeScript overall was one of the main reasons that we love and use Prisma. But on the operational side, I would just have to say that I did a lot of investigation into the support by its creators, like if it's something that's here to stay that we can rely on in the long run, and all of that, as well as the community, which I think is a very important factor in when choosing or diving into any new technology that you're trying to adopt or switching to a technology, as well as what I just mentioned, the documentation itself. So it kind of ticked all the checkboxes on our end, and we've been loving it ever since.
Yeah, it's an interesting thing. Really, it spun up I don't think Prisma 1 was really that popular compared to Prisma 2 from what I've seen, and I've heard about Prisma starting from Prisma 2. So for me, the real choice was I don't like ORMs because I've seen too much problems going with ORM. You load the whole object, you change one property, and then you hit save. You don't really know what's going to be changed, and it's all a bit magic, and I don't really like that. But it's also it's a kind of a query builder, but simpler, so it goes really you don't have to think really about the SQL. You do have to think about a SQL that is generated in the end a bit because it's going to impact performance. So you do need to think about it, but it's for most of the time you can forget about it and then at least get your feature ready, and then you can optimize it later on. And I think that's the sweet spot that Prisma is on right now. And I talked a bit about not having to write models before, and I think that's also nice to have. And I agree on everything that Vasil said on the documentation that is quite good, and community and just commercial support that we know that there's actually a commercial entity behind it. So
yeah, interesting you mentioned the documentation, because in our case, because we are creating these new graphs, we have the possibility to start with a different stack, and we were analyzing possibilities for ORMs, and so what we have in TypeScript ecosystem, right? And when I saw, and we were analyzing, we saw the documentation about the comparison documentation that Prisma has. It was very interesting to analyze and really see what will be the benefits that compared to the tools that we are using right now. And the fact of having the typings everywhere, like already built in this toolkit, was a really really high decision. It really helped our decision to choose Prisma. So this typings and possibilities of having this easy migration. So we were in production with the Prisma migration, not the final version yet. So it was like a previous version. But everything was very smooth. We didn't have any problems with it. So it was really right decision. And we are always looking to continue creating new products. And Prisma is really it's the first option. When I see some products being created, I will just analyze this possibility.
Thank you. We have one final question. What are you most excited about in the Prisma roadmap?
Yeah, I'm gonna be quick since we don't have a lot of time yet. I say the NAPI binding stabilization of that is gonna bring a lot of performance back into Prisma. The Cascade support, that has been a long-awaited thing that's finally gotten some good going. And what I'm really most excited is the custom extensible part of Prisma, like custom validation, custom typing for JSON, stuff like that. Date versus datetime, locks on datetime. If we could use the locks on datetime, I would be really happy, and stuff like that.
Yeah, I would agree with that, and I would say the being able to split the Prisma schema file into multiple files is high on my priority list.
Yeah, in my case, would be the Prisma migration field renames that will help a lot the developer to identify when it's dropping the column or not. So when it loses the data, I'm very excited to Nexus plugin Prisma because I really like the Nexus idea, the minimalist idea of this tool, and also the serverless Prisma bootstrap. It's something that I'm also excited.
Well, it's been a real pleasure speaking to all of you and hearing sort of your different angles on Prisma. On that note, I would like to thank you all, and we'll now move to a live Q&A.
Thank you for having us.
Thank you very much.
We're now back for a live Q&A. Quick reminder again that you can post your questions in the Prisma Day channel on Slack. Now, let's get right into it. And I'd like to open up this question with the following. What challenges do you face when working with multiple databases in your architecture? And I would love for you, maybe, Ricardo, to open up this question with an answer.
Of course, yes, a really nice question. Yeah, so we do have case of multi-databases, but maybe it's not the context because this is a legacy project that we have and it's not GraphQL oriented. But what we do to solve this kind of multiple database is that because we are using GraphQL Federation, we have subgraphs that is different systems, and they end up having different databases. And then we extend entities using the GraphQL Federation, And this is kind of a join between different databases. So it's how we are solving these issues or problems, or just a nice way to have stitched entities together, and providing the graph, or what the front end needs, right, in terms of data that we have in different databases. So that's how we are solving this problem. Yeah, so.
I think it's a general good practice anyway to not have multiple services connecting to the same database, because if you change the schema, then potentially breaks multiple applications. So in general, it's like, because if you all connect to the same database, you effectively have like a distributed monolith instead of having real microservices that talk to each other.
I see. And moving on, we touched a bit on microservices. So using microservices gives you a scaling advantage, but comes at an operational cost. How do you sort of handle things like inter-service communication, for example, in situations where you need information in one service from another? Perhaps you could chime in on this, Vasil.
Yeah, absolutely. That's a really good question, actually. At the very basic level, I would say two things. Log everything. I feel like there's no such thing as an overkill when it comes to logging everything that happens on a microservice, in a microservice-based architecture, just because of like the way the system is distributed, and each module, each entity or unit exists as an ecosystem on its own. And another thing when it comes to messaging, whether you decided like that should be synchronous or asynchronous, the way the microservices communicate between each other is, and this is more of a general approach, I would say, don't limit yourself to a single solution of communication, meaning experiment whatever works best for you. Like, use a request response for one microservice maybe, or notifications for a different one, publish, subscribe for a third one, or whatever. So don't be afraid to model the communication and everything that happens according to your system's needs, and just based on someone else's solution as canon, or as like, the ultimate design. But at the heart of it all, I would say log and log. You cannot go wrong there.
And try to have like a request ID that you can follow from the customer.
Oh, absolutely. Yeah. Sorry, that was like,
it's like obvious, but like
for the novice developers and the junior developers, I would say, you have to work within the universal scope of IDs that something that you're using across the microservices does not repeat, or it's universally like unique.
On terms of security, I would say like usually people start with like the service is basically an admin of every other service, so you can fetch like every data you want. But like later on, it's better to have some kind of like a service A request a token and says, well, I'm having this request from this client and I need to access that data from another service. So you can like more restrict that on. It's more of a OAuth flow where every service say I'm impersonating for this user, and so if this user doesn't have access, then the service can't have access, because otherwise it will make no sense, or the access pattern.
Yeah, we can definitely discuss security for a long time there. Like, but you're absolutely right. Security is something you can manage both on like user role or service role, as well as like scope within that role, just so that you'll be able to fetch different pieces of data or chunks of data depending on which service has access to which other service on behalf of what user. But yes, you're absolutely right. Yeah.
So we saw how this quickly turned into an interesting discussion around security. And Emil, I sort of want to do a follow-up question. How do you, more broadly speaking, how do you approach security as an application grows?
Yeah, it's an interesting topic and always evolving. I would say like at first, I'm working a lot with GraphQL APIs, and usually I put a lot of logic at first in the GraphQL, like GraphQL Shield or something like that there. And then as the application grows, usually you turn to more like on the GraphQL side, you only have scope. So the user has access to writing post. but then the actual object that is written is like more dependent on the context. So you push down the context of who's asking for that resource or who's asking to modify that resource, and then it's more in the business logic that you have to verify that the user really has access. And Facebook pattern, like if you take a look at what Facebook did a post a while ago on GraphQL, and they have this model where every time they request an object or write to an object, they verify the ownership of that object with the caller of the function, basically using the GraphQL context. So that's my approach, really.
I see. So basically, injecting basically the requester ID or some universal identifier about the user who's making the request, and then using that essentially in the different layers in order to determine.
And usually it's really, if you're lucky, you can like just by the object itself know if the user owns that object, but usually you have to go a parents or two parents up. So that's why data loaders also with like caching can help, because then if you already loaded those parents, you don't have to query the database again. So yeah, but like, yeah, usually you have to check in the business logic because it doesn't scale to put everything in the GraphQL layer at a bigger scale.
I see. And what is one of the most important lessons that you've learned when working with databases?
Yeah, I really like this question. I really consider the importance of having the constraints. So we can have, of course, validations in application level, but we shouldn't forget these constraints in a database. So it's very important for the consistent, right? So usually database has this problem with consistency, and it keeps the consistency, or at least a bit. What I also learned that is very important, the right indexes for the tables, right? And sometimes partial index is also important to define in a database. So just a quick example, sometimes we add some soft deletes to our application, and it can completely destroy all the index that we have before, because if this delete add, for example, is always included to the SQL query, and we are not considering it in our index, it's just not taking the right index. So that's what I mean. And cascade delete also to keep the consistency is also important to have this ability of defining the cascade delete. And very important, don't forget your tech debts.
Got it.
Yeah. The most important thing I learned is null is not equal null in SQL. That's something that every junior database engineer will learn painfully.
Okay, we had one question from Robert in the Slack channel, and he asked if you found any places where you had to break out of Prisma and write raw SQL. Is this something which you think Prisma can solve in the future, or will there always be use cases for raw SQL in ORMs like Prisma? I'd love to.
I write quite a lot of it for statistics.
Yeah, I was going to say analytics. Yep.
Yeah, analytics and statistics, complex queries that require like generating series of data and then merging that series with other data and like per day sales or whatever. That's where what I would like Prisma to do is like, because now you can kind of parse SQL with TypeScript because it's like Turing complete TypeScript. So I think you could have a parser there. That would be really helpful, or at least the basic.
I see, in order to basically verify template screens. Okay. Vasil, Emil, and Ricardo, would like to greatly thank you for joining and sharing your experiences working with Prisma in production, and I hope to see you soon.
Absolutely.
Thanks
for having us.
Yes.
Okay, I'd like to now welcome our three next speakers for the next talk. We have Artur Mrozowski. He's a data engineer and architect at Trig, and his motto is functionality before technology. We have Justin Joseph, a big data engineer with over 8 years of experience in design, development, and automation of big data pipelines, ETL flows, streaming applications, data lakes, and web-based applications. And finally, Lasse Abelson. Lasse is a DevOps engineer at Trig, interested in continuous integration, environment management, and configuration management. And their talk title is Democratizing Data, Trig and Prisma, how Trig transforms billions of records from different data sources and exposes a single data model via GraphQL. So now, without any further delay, I bring you Arta, Justin, and Lasse.
Hello, and thanks for joining our presentation on democratizing data. For the first 1/3, we will be going over data modeling and time-aware mirror maker. And then for the last 2/3, I'll be going over continuous integration and Prisma, how we democratize data in practice. But to start, I'll hand this over to Arthur, who will be elaborating on our problem and data modeling.
Copernican revolution in data processing is a term introduced by Gordon Everest, 1986, who wrote a book called Database Management. In the same way, Copernicus argued that center of the solar system shift from Earth to the sun, our view of data processing shifts from software to data. The software and data will become more independent of each other, and both are independent of the hardware and closer to people. It took a while, but today we are in the middle of it. We have data-centric manifesto, shifting from application-centric to data-centric view, becoming data-driven, and data penetrates many aspects of our daily work. The reality we were facing was a range of different sources spread across 3 different countries, and all with a slightly different definition of the same concepts. Acquisition of the data would require a deep dive into all the caveats of these sources, so potentially time-consuming and error-prone. We saw a clear need for a platform that would democratize access to that data across the sources without requiring to become expert in each and one of them. We wanted to make it available and easy to traverse for anyone in the organization, even people not necessarily trained in SQL and entity relationship diagrams. This is where the idea of a semantic graph or graph data model was introduced. So we couldn't reuse the sources data models for several reasons. These were built over decades and result of many fixes, workarounds, and compromises, and very source specific. We wanted to abstract that away. And as you know, we can solve any problem by introducing an extra level of indirection. For that, we have chosen Accord. Accord is an industry standard information model, an implementation of semantics technology ability to harmonize entire vertical, segmented by organizations' objectives, processes, languages, locations, and other points of diversity. It provides a uniformity of meaning of heterogeneous data that is widely technology, software, and hardware agnostic. Data in any type of system can communicate with other data with these standards. So design approach that looks at the data entities and their real-world attributes and relationships first. And Accord comes in a range of different formats, either as an entity relationship diagram or UML derivative. Since we wanted to represent this model as a graph, we loaded it into Neo4j using APOC libraries. And it contains a lot of information, but we are only interested in a subset of it. So now we had to identify business entities, attributes, and relationships between them. And so now we arrived and we have at a labeled property graph. And so it has node properties, edge properties, typed nodes, basically the same properties as GraphQL. From that graph, we generate Prisma PSL schema as input to our automated infrastructure pipelines that Lasse will tell you about. So Prisma is a huge technical enabler for us here. Now we have all the necessary components to create a platform that will enable data acquisition across the company. So we gather observations made in the source systems. These are replicated by CDC pipelines and stored on Kafka, or a single version of facts. We use GraphQL as an API and common language to interact with the data. And we have Accord that provides context and facilitates interoperability and reusability of the data. And all of these components result in our data broker platform called Trig 360. This is implemented and runs in production. And we also learned a few things doing it. For example, common language is good, but common understanding is better. So we are looking into techniques like event modeling to sharpen our domain model and facilitate communication and collaboration around it, trying to turn Conway's law to our advantage. This also introduces how one can think around events and facts and how they are stored on a timeline. We use Kafka not only as a real-time message broker, but also as a mediator of state that can be replayed at any given point in time. That poses, of course, a few challenges, and Justin will tell you more about it. Personally, I think we should allow more than one model and delegate ownership of it to domain teams and organize API around how it is used, not how it is stored. Thank you.
Here I'm going to talk about one of the components in our pipeline called time-aware mirror maker. We have introduced this as a solution to one of our critical problem, data synchronization. As you see, we do have a lot of sources, and on top of those sources, there are several data transformation pipelines running. And these streaming pipelines runs with different speeds, meaning some pipeline may finish in minutes, some will take hours, someone will take more than that. Because of that, if we try to get the data from our target at any time, they will give us a wrong data, means it won't give us the current data. So to avoid this problem, we have introduced this TAM. So TAM will make sure all of the data pipeline gets data in correct order based on the time. Also, it will make sure that none of the applications will go faster than others. If TAM sees any of the application is slowing down, then it will make sure that other apps which is going faster take a pause until the slower one in sync with the others. So all the apps moves forward to the target in sync with time and speed. With this approach, we will make sure target has the most recent, current and latest data.
All right, generating a full environment via CI. I'd like to just explain what I mean by that. Here on the left, I've tried to illustrate that we have a lot of different sources. These sources we are loading into a Kafka cluster, a very large cluster. The data loaded in is with all the raw data, so none of the data here has been transformed. It's just laying here waiting to be consumed by us. The data here is actually live streamed in here. So that means when we generate environments, we will also be able to have live data in our environments. Our environments consist of everything inside this purple box. So when we deploy an environment, we deploy time-aware mirror maker, we deploy a local Kafka cluster. What this means is that when we deploy 1, 10, 100 applications, we don't want to load all the data from all the sources. We only want to load the data that our particular application for the environment needs. So this cluster will only contain the data that the particular environment needs, and will of course only deploy the applications that we feel are necessary for this particular environment. A developer might only need a single application or a few applications. When we do performance testing, we might need all of them or a few of them. And for production, of course, we're deploying all the applications that are ready to transform data. So the applications consume data from the Kafka cluster with the synchronized data, and then they transform it and load it into a Cockroach database. And then we deploy a Prisma pod that has access to this particular environment's database, and we're able to expose this to users or systems. The way we orchestrate this is we let Kubernetes handle all our resources. We just define them in Helm charts, so we can template all of the infrastructure. That means we can auto-scale, and we can do a lot of things via templating. And I'll show a little bit what that means and how we're doing that. But just to reiterate, we want to be able to auto-generate the database based on a schema, and we also want to auto-generate Prisma based on a schema. And then, of course, we wanted to be able to deploy any application or source or combination of those. And of course, we want to be able to do it with one click. Why not? So let's have a look. I'll start off with the schema. The Accord model is proprietary, so I can't use it. So therefore, I have prepared 2 dummy Prisma schemas. So here's presentation 1. Oops. With user, post, comment, group, and a dummy model. And if we go back and look at presentation 2, the only difference is that there is no dummy model in the end. That's the only thing. I mentioned earlier that we are using CockroachDB. And as you may know, that's not supported by Prisma at the moment. But CockroachDB is compatible with the PostgreSQL wire protocol, so therefore Prisma is still able to communicate it with it. The Prisma CLI is just not able to patch the database. So what we have done is we have set up a pipeline that triggers whenever someone pushes a new file into this repository. This pipeline just pulls the entire repository, checks for any Prisma files, and checks inside Kubernetes where we eventually want to deploy environments, check if the files exist as config maps. If they exist, it just tells us that already existed. If it doesn't, it will add the Prisma file. So you can see here. It's cloning the models repository. It says the config map presentation 1.prisma not found, and then it creates it. And the same for the presentation 2. The other schemas already existed, so it doesn't do anything. And then we use Prisma CLI to actually patch a Postgres database, and then we just extract all the DDL from that. And this we save as a file inside Kubernetes, so that when we spin up our Cockroach database, we can use the extracted SQL to patch the database. That way we have the Prisma schema and the SQL file matching perfectly. So let's create some environments, because this is one click, and I just want to show how that works. So here, let's create a random environment, or an environment with a random name. We will deploy it into dev. We'll not deploy any applications for this demo. And then we want to deploy this particular environment with the schema named presentation1.prisma. And this is what the pipeline will use to set up Prisma and to patch the database. All the rest here we can change the scale of how large the environment will be. So we use the exact same pipeline for dev, test, and production, so that you don't have something working in dev but not working in production. This way we are sure that whatever we test in dev, the only difference will be the scale of the target environment. So in dev you might have a Cockroach database that is just a single pod, but in production you might have 18 pods to be able to handle the load. So I'll just start this pipeline with the presentation 1 schema. Then I'll create another environment just to show that this is live with a random name. We'll also deploy it to dev. The only difference will be that we will deploy it with a different schema version where we're using presentation 2. So let's run that pipeline, and we'll just do the one-click deploy, play. And when this one is ready, I will say deploy. So let's just have this running in the background for the rest of the presentation. So I mentioned that we're using Helm to deploy it into Kubernetes, and we're able to template all our deployments using that. The reason why that's important is that when we deploy Prisma, for example, we can tell Helm to mount a file into the pod, and that's what we're doing when we are setting up Prisma. We can say that this Prisma pod should just use whatever input we gave when we started the pipeline to determine what config map to mount. And here we're mounting schema presentation 1.prisma into the pod, for example, because we provided the value presentation 1.prisma as the schema version. So this just means that when the Prisma deployment starts up, it will mount that particular one. And if another person uses the pipeline and provides a different version of the schema version, his Prisma pod will simply be using that version. So let me just show the Docker file of Prisma. Here we just start from node 12, and all we do is we add the code of our particular Prisma server, and then we install pal.js. Pal.js is a really cool tool that Ahmed, one of the community members, made, and this is able to auto-generate resolvers and type definitions based off a schema. So this is a large part of our infrastructure, what is making it possible for us to have an automated infrastructure. Then we run a script, entrypoint.sh here, and then we just run yarn dev. So let's have a look at the entry point. What it does is it just allows us to do development on Prisma locally. So if we run it inside Kubernetes, there will be a file in the mounted directory, in which case it will just prepend the schema file. So it will take all this text inside the Prisma file, and then it will just prepend this text here, which is necessary for the Prisma client, so that when you run Prisma generate, it knows what to generate and what data source provider you're using and what the URL for the database is. Let's just keep this running in the background. Yeah, and in the end, it will just install any dependencies that we have. Then it will run yarn generate, which is actually just Prisma generate. And let me find the entry point again. Then it will run pal.g, and this is what will auto-generate our resolvers and type definitions based off the schema, and then it will just start our Prisma server. Yeah, so hopefully our deployment is done. It is. Took 3 minutes, but now we have it. So all the infrastructure that I showed you before should be available to us, at least the Prisma part and the database part, since we are not really interested in the loading applications and Kafka and so on. So let's just have a look. If I say get config map, so what I'm doing here is I use kubectl CLI for Kubernetes to just ask Kubernetes, give me all the config maps. And here you can see that we have the presentation 1.prisma and .sql that was generated by the pipeline. And if I similarly say, show me all the pods running in this particular namespace that my alias is pointing to, I can say grep Prisma, and our developers have a lot of environments running. So I'll probably have to take a look at what I called my environment, called RDR. I think that's, I have to grab RDR. So here's a Prisma pod. You can see it's been running for 111 seconds. And let's just have a look at that, what is going on. So yeah, fun fact, the schema files that we have, they are over 10,000 lines long. They are over 1 million characters long, and Kubernetes doesn't support that large config map. So we have to compress our schemas before we add them to Kubernetes. So our pipeline also does that. And then we decompress them inside the Prisma, but that's why it says compressed. We install all the dependencies. We generate the Prisma client. So that was Yarn and Yarn generate, and then PLG. So here we generate all the type definitions and resolvers for the particular schema, and then we start our server. And another cool thing that we set up in our pipeline is that whenever the deployment is done, it shows us that we've deployed to dev to this environment, and I can click on it, and I can see that it was created 6 minutes ago, and I can open the live environment. And here we should be able to query the model that we set up. So find many, and you can see here I have, let me just make it larger. You can see I have find many dummy. If I go to our other pipeline, looks like it's also done. Let's just go to the top, go to the environment, open it, and here we shouldn't have dummy. So if I say find many dummy, you can see it doesn't really autocomplete to it. And if I try to select anything from it, it says it doesn't exist. But if I ran this on the environment where we used the model that had it, you can see that it actually finds it. And you can see that it actually does have connection to the database. There just isn't there isn't any data in the database. If we take a look at the inside the pod, I'll just bash into it. So now we're inside the pod that's running in Kubernetes, and I can go to source GraphQL, where we have the resolvers. You can see that PLGS has generated resolvers for all the models that we had defined. So you can see if I cat comment /resolvers that they have been automatically generated. And this is exactly the same thing we do when we run our real environments. Of course, we just use different schemas. And this is what allows us to democratize data. We will have a very quick development cycle where a developer will be able to spin up an environment at the click of a button, call it whatever he wants, deploy the applications that he wants. He'll be able to look at the data after it's been loaded. He'll be able to check it live. He'll be able to share the URL with a user perhaps that has to verify it. And this just makes it for very fast iterations, because if you had to set up environments manually, or you had to wait a long time for any load to happen, you can imagine with as complex a model that we are using, with as much data as we need to load, it would simply take too much time to get close to a finished product if you didn't have a setup that would allow you to generate everything. So we are very happy that we went with Prisma and CockroachDB, as they enable us to generate everything based on code. And that's all we had for you today. So thanks for joining. Hope you found it interesting, and have a nice day.
We're back now for a live Q&A. Thank you again, Arthur, Justin, and Lasse. That was a very insightful talk. In particular, the application of theory, its application in democratizing data at Trig, and the role that Prisma played along in that journey. So we're now going to start this live Q&A, and if you have any questions, please feel free to shoot them via Slack channel. And now to sort of open up this Q&A, I'll start with a question to you, Arthur. So you mentioned how common language is good, but common understanding is better. How do you achieve this in a large organization with multiple teams focused on different domains?
Yeah, good question. And it is of course, a challenge. And we try to harness opinions and perspective across the organization, trying to create cross-functional teams and basically involving people in creating the data products, in data analytics. So rather than creating something for them, we create it together with them.
I see. And in your talk, you described how you created essentially this Trig 360 platform to enable data acquisition across the organization. And you've used a variety of different technologies and techniques, for example, CDC, which is change data capture, Kafka, GraphQL, and Prisma. And I'm curious to hear, what were some of the challenges that you faced in the design of this architecture? And I assume that there was also a lot of legacy technology that you had to sort of deal with in creating this new platform.
There was, the whole solution has been through quite a lot of iterations. There was a lot of testing going on with different databases. We also tested out Hasura, and we tested the performance of different parts of the infrastructure, because when you need to load that much data, it's important that it doesn't take half a year or take a very long time. So a lot of our time was actually spent testing out different technologies. And with databases, we found that their reliance on disk I/O on a single master, for example, was just a no-go for us. We just couldn't get the throughput we needed. And then for me, personally, one of the challenges was to automate everything into one button, so that once we want to enable our developers to be able to have a very easy and quick cycle. So when they need to use a new schema, when a new model comes out, we want to make it easy for them to develop their applications. So deploying a Cockroach database and the Kafka cluster and automating the GraphQL code and everything at the click of a button and parameterizing everything, that was also a bit of a challenge.
Quite the undertaking, but it looked, based on your demo, it looked quite impressive, just going from a single click and a couple of parameters to a working environment. Moving on to the next question. If I understood correctly, the time-aware mirror maker essentially solves the problem of incorrect data due to synchronization disparities between the different data sources that you're essentially putting together in this Trig 360 platform. And you're doing that by relying on time. Does this mean that synchronization latency will be determined by the slowest transformation pipeline?
Yeah, it's actually happening in two ways, actually. The first one is, of course, the time. We will only copy the data based on the timestamp. And of course, the next one we are considering the fact is the latency of any data pipelines, because if there is a data pipelines which has huge data set, means in a second, if it is getting more than 10,000 or 20,000 records, and it just doesn't make any sense that other pipelines which is faster should complete. So based on the slowest one, we just make sure that everything goes in a synchronized way. And obviously, we are just making sure that there is no slow runners. Even if you have a lot of data, we just make sure that it runs faster.
I see. So does this approach, would you say that this approach favors consistency at potentially the cost of some latency?
Yeah, you can say that. We just actually wanted the consistency actually. So yeah, when you say at cost of time, yeah, obviously as I mentioned earlier, we just make sure that there is no slow runners in our data pipelines.
I see. So I guess these are constantly monitored to ensure that this doesn't happen.
Yeah, exactly.
Okay, well, I would like to thank the three of you. It's been really insightful to learn about your journey using Prisma and about Trig's architecture. So thank you so much, Arthur, Justin, and Lasse, and I hope to see you soon.
Thank you.
Thank you.
All right. Okay, I'm now thrilled to invite Sylvian Simao. Sylvian is the CTO at Travis, a social travel platform which allows travelers to curate ideas and plans for trips based on other people's travel stories. He is also the co-creator of Prisma AppSync, which speeds up GraphQL API development. Before joining Travis, he spent 12 years working across various software engineering and tech leadership roles, both in France and in Australia. He loves full stack web development, creative technology, and serverless. Sylvian's talk title is Real-Time GraphQL APIs with Prisma and AWS AppSync. And now I bring you Sylvian.
Hi, everyone, and welcome to this lightning talk. So today we're going to talk about real-time GraphQL with Prisma and AWS AppSync. More precisely, we will see how to use Prisma AppSync, a generator built for Prisma, to speed up APIs development. My name is Sylvain Simao, and I am CTO at Travis, a social platform for travelers where you can curate ideas and plan trips based on other people's recommendation. Now, apart from my work at Travis, I am also the creator of the open source Prisma AppSync package, which will be at the core of today's talk. All right, so let's jump right in. This talk will assume that you are already familiar with Prisma. And in the first part, we will see what is AWS AppSync and how we can use it with Prisma. Then in the second part, we will do some live coding and build an API from scratch using the Prisma AppSync generator. So what is AWS AppSync exactly? Let's start with a description extracted from AWS website. AWS AppSync is a fully managed serverless GraphQL service for real-time data queries, synchronization, communications, and offline programming features. Now, the most important thing to retain is what's underlined. In other words, AWS AppSync sort of is GraphQL as a service. But let's see how it works in practice. This diagram represents a common GraphQL API architecture. On the left, we have the client doing a GraphQL API request. Now, this can be the browser, a native app, or anything really. At the center, the GraphQL server, whose role is to understand the request, communicate with the database, apply some business logic, and return a response to the client. Finally, on the right, we have the data source. This can be a Postgres or MySQL database, for example. Now, there are lots of ways to create GraphQL servers, but two very popular approaches with Prisma are using Apollo Server or using Nexus. Now, see AWS AppSync as an alternative to using Apollo Server or Nexus that you can also use in combination with Prisma. Now, there are a couple of advantages of using AppSync. First, we don't have to build or manage our own GraphQL server. Second one is we benefit directly from real-time capabilities, so subscriptions out of the box. We have access to a highly scalable and available infrastructure. And the final point I wanted to mention is we only pay for what we use. Okay, so we understand where AppSync sits and its benefits. So let's see how to set it up. To set up AWS AppSync, we need two things: a GraphQL schema written using a SDL syntax and a resolvers mapping configuration. Now, in AWS world, this means mapping GraphQL queries and mutations to one or multiple data source. AppSync supports various types of data source, including RDS databases and DynamoDB, or, and this is what we are interested about, a Lambda function. Now, when working with Prisma, we want to be using a Lambda function as resolver, as it would allow us to write our own logic using Prisma clients. Time to see how to combine Prisma with AppSync. Now, assuming we already have a Prisma schema ready, the steps required will be creating a GraphQL schema. Now, this is likely matching our Prisma schema. So, for example, if we have a post model, we want to create queries and mutations around posts. Then, second thing we'll need to do is to write our code for the Lambda function. Now, this is likely where we're going to be using Prisma client to interact with the database. Now, we could do that manually, obviously, but here's the thing. All APIs usually require the same common set of operations: get, list, create, update, delete, etc. And we need to create these for multiple models. Now, writing the business logic for this operation plus creating our GraphQL schema is very time-consuming and repetitive. So if you're wondering if we can do better, well, yes, we can. Introducing Prisma AppSync, a Prisma generator that will automatically generate everything we need to create a GraphQL API based on a Prisma schema. So now, with Prisma AppSync, we can use the same file and data structure to also quickly iterate on our API. And because it is built using AppSync, we get real-time subscriptions, advanced security methods, and high availability out of the box. But I think this is enough with theory. Let's get to practice. So we have about 5 minutes remaining for this talk, which should be plenty of time to build a full GraphQL API from scratch when using Prisma AppSync generator. Starting from an empty folder, we will install Prisma AppSync starter kit with yarn create Prisma AppSync app dot to kickstart a new project in the current directory. If we have an existing project using Prisma, we can also install it manually following the official documentation. Now, when prompted, we want to give a name to our API, so I will use Prisma Day. Do we want to add a sample schema Prisma file? There is a typo here, so yes, because we don't have one. And I will pass my database connection URL. So I have already set up a Postgres database, and for now it is completely empty. While the install is finalizing, let's look at the files that come with the starter kit. So we have a Prisma schema with 2 models, user and post, and relations already set up. Prisma AppSync generator is there. And we also have the right binaries configuration to use Prisma on AWS Lambda. Moving on, we have a Lambda function handler. So it's using Prisma AppSync client. See this as a Prisma client on steroid. The function itself is quite simple. So we receive the event coming from AppSync, we pass it, we resolve the query, and we return the result of the API call. Finally, we have a CDK folder containing everything we need really to deploy our API on AWS. So next step now is to run yarn deploy, which I will explain in a few minutes. But for now, while deploy is running, we want to sync our Prisma schema with our database by running npx prisma db push. So I've just added at the beginning my database URL so that it worked properly. Okay, so let's have a look on Table Plus to see that we have our 2 tables that have been created with all the relevant fields and obviously following our Prisma schema. Okay, so back to VS Code. Deploy is still running, so let's look at what's been generated from the yarn deploy command. We now have a GraphQL schema that is ready for AppSync. So again, matching our Prisma schema. We have a resolvers mapping config necessary for AppSync as well. And we have a documentation. So for example, here we can see how to use our API for the post model. Finally, we have a Prisma AppSync client that will be used by our Lambda resolver function. Okay, so deployment is finished. Time to try our newly created API. In the AWS console, I'll refresh and we can see our new Prisma Day API project. So let's open it. And let's go inside schema. So this is our live API schema, again, matching our Prisma schema. If we go in data source, we can also see our Lambda function resolver that's been set up for us. Now let's go to queries and let me clean the editor first and show you the docs. So we see we have a couple of queries that are available for us. So get user, list users, and same thing for posts. We also have mutations, create, update, upset, delete, and we have subscriptions for real-time events happening around our data. First thing we'll try is create a new user with some email and role data. Execute it. Okay. Now that we have a user created, we will create a new post. Now, because Prisma AppSync follows Prisma client conventions, we can directly connect the post to our previously created user via its email address. Okay, the first post is ready. Let's create a second one. Second post is ready. Let's try to list all our posts and get back the title and the author. So we have an array that is returned with two records, first post and second post, with the associated author. Finally, we will try something more advanced and query all the posts, filtering by a specific author email. So author email equal, and then we will use pagination to skip only one post return, and that is the second one that we have created. All right, so back to slides. As promised, we have created a fully working GraphQL API in less than 5 minutes. And that was solely based on a Prisma schema file. Now, in the demo, I only had time to show you the basics of Prisma AppSync, but note that you can do much more. So, for example, it gives you a way to extend the CRUD API, creating some custom resolvers. And it also allows you to use some advanced security mechanism, such as authorization that you can plug in with Cognito, as well as fine-grained access control. Now, if you want to try the generator yourself, you can find Prisma AppSync on GitHub at maosi, so my username, /Prisma AppSync. The generator is not ready for production yet, though it is already powering Travis that you can see on the right, which I also invite you to check if you enjoy travel and would like to discover some cool places around the world. All right. Thank you very much for listening, and I hope you enjoy the rest of your Prisma Day.
Thank you, Sylvia. That was pretty cool to see how quickly you went from a Prisma schema to a full-fledged GraphQL API on AppSync. We're now gonna take a short break and we'll be back in a couple of minutes. Quick reminder that the raffle is still open and you have the chance to win either a Prisma new t-shirt, $150 sponsorship to an open source project of your choice, a conference ticket up to $500, Lego robotics set, and a Bedrock license. So if you haven't already, you can just have to retweet the raffle tweet that is pinned to the Prisma Twitter. And in the meanwhile, enjoy your break and we'll see you soon.
Okay, that is a pretty neat bit.
And hit refresh, run that again. Do we get another one? We do. Oh, how cool is that? Nice.
Thank you for giving examples, Prisma. You're the best.
Ooh. Ah, look at that. This is so nice.
I'm not gonna lie, this is really cool. Like, I did not know that this was a feature, and this is a really, really handy feature that this is, you know, a thing that we can just very quickly stand up. I like that a lot.
But yeah, this is awesome. This is really cool.
Exactly.
This loads up in the browser.
Gonna submit these links. They're gonna go in the database. This is how easy Prisma makes working with databases.
This is Hudson. He's a 6-year-old Arctic fox who is one of the ambassadors of Woodland Park Zoo in Seattle. We wanted to ask Hudson a couple of questions, and these were his answers. Hey Hudson, are you excited for Prisma Day? Nice. Well, we wanted to ask you a couple of questions. Wait, we haven't even started yet. Come back. Okay, so we wanted to ask you a couple of questions, but before that, do you want to hear a joke? Okay, cool. So a SQL query walks into a restaurant, sees 2 tables, and asks them, "Can I join you?" Ah, come on, it's a good one. No? Okay, well, we have like an important question. Do you have any idea about like what happened to production yesterday? Hudson? Hudson? Hudson, where you go? Hudson? Okay, that's not suspicious at all. Hey, did you know you can use Prisma with Go?
Seriously?
Yes, it's part of the Prisma ecosystem.
So, like, what do we get?
You'll get an auto-generated type-safe query builder, declarative data modeling, schema migrations, and visual data management. So, the complete Prisma experience.
That's so cool. How can I try it?
It's still in early access, but we would love for you to try it out and to give us your feedback. So, if you're interested, go to prisly.com/go.
Welcome back. I hope that you're all refreshed after the break and ready for the third part of Prisma Day. In the first two parts of Prisma Day, we went on a journey up the stack, starting with databases, connection management, and so on. And then in the second part, we learned about how Prisma is used by companies in production, and finally got a look at how Prisma AppSync can help you generate a GraphQL API from a Prisma schema. Now, before we get into this part, I'd like to go back in time once again. The Node.js project is now 12 years old, and in that time, it has proven to be a robust and flexible runtime for modern applications. It's used by large corporations and indie developers alike. In that time, GitHub's rise in popularity facilitated the growth of an ever-expanding ecosystem of projects and communities. The universality of JavaScript with browsers and Node.js has meant that JavaScript runs on most digital devices, from your computer to a smart TV. This reminds me of Atwood's law from 2007 by Jeff Atwood, the co-founder of Stack Overflow, who said that any application that can be written in JavaScript will eventually be written in JavaScript. But Node.js is a double-edged sword. The lack of conventions and the rapid expansion meant that there's no single way to do things. Many of you may be familiar with JavaScript fatigue as a term used to describe the difficulty of keeping up with the change in the ecosystem. Nonetheless, we're now in 2021, and there's a lot of promise coming, as we'll see in the upcoming talks. In this part, we'll get an opportunity to look at a new wave of frameworks that aim to alleviate many of the pains developers have experienced with Node.js. And I'm absolutely thrilled for the upcoming talks. This part will open with a lightning talk about events at Prisma, followed by a number of talks about frameworks that use Prisma. So I'm now excited to invite my colleague, Natalia Voroniec. Natalia is an events manager at Prisma and the backstage master of TypeScript Berlin, GraphQL Berlin, and the Prisma meetup. In fact, she's worked hard behind the scenes to make Prisma Day happen. Her background is actually in a different domain. Her background is in fashion management, to which she pays daily homage with her Prisma hoodie and t-shirt uniform. In her free time, she likes to read and eat cheese. Natalia's talk title is Events at Prisma. And now I bring you Natalia.
Hey everyone, welcome to my talk in which I would like to give you an overview of the events here at Prisma. And it is a bit of a bizarre moment to be talking about events, as in terms of events, we have a pandemic. And it would seem that a pandemic would be the killer of all the events, unless. Yes, so let me tell you how Prisma dealt with the events in the pandemic, but I also want to give you a little bit of an overview of what we did before, and also what we plan to do and how you can get involved. Yes, Prisma Day 2019 is still in the golden days of in-person events. The seats were filled and the buffet options were aplenty, as you can see in the photo. We hosted our first Prisma Day here in Berlin, and it was just a great summer day where we could meet our community and the community could meet us. I have waited a little bit to introduce myself just so I can show you this photo of myself as I am making potato salad for Prisma Day 2019. My name is Natalia Voroniec, and I'm an events manager here at Prisma. You can find me on Twitter, where I usually tweet about Prisma Eventsy stuff at nvoroniec. But back to my point. In the following months after Prisma Day 19, we hosted a couple of meetups in our Berlin office, and these were to the subject of GraphQL, TypeScript, and we also hosted our friends from the local Rust Berlin group. We have lured the developers in with the promise of quality talks, networking opportunities, and of course, free pizza and stickers. Yes, I decided to include a couple of more photos of this really cute dog that was at a meetup once. I thought you folks would appreciate it. Yes, and then in the beginning of 2020, we all know what happened. Very, very challenging times have started in more levels than we could have previously imagined. So after the general first confusion and what do we do now, we decided to move our events online. The search for the perfect platform, the perfect format has started. And honestly, this search is still ongoing, as not a thing that we can organize online will ever match the sense of community, the connection, the companionship that we reached with an in-person event. But you know what? We tried, and we tried hard. During the pandemic, we have hosted 21 online meetups on the subject of TypeScript, GraphQL, Prisma, databases, and general web development. Over 1,300 developers attended these events. That is, if you believe the RSVP numbers from Meetup, which I wouldn't too closely, but it will do for the lack of better indicator. We have also hosted last year's Prisma Day and this year's Prisma Enterprise event entirely online. And all of these were recorded. You can still watch them online on our YouTube channel, and we have added professionally transcribed closed captions to these for accessibility. And we had a very wide array of speakers. We had beginners, we have professionals, some celebrities, but our main goal was always to make sure that everybody's voice is heard. Everybody can apply to be a speaker at a Prisma meetup, whatever project you might have, big or small, there will be place for it here. Yes, the quizzes that we organize during our online meetups have proved to be an especially popular part of these. You can win prizes, you can win swag, stickers, there's t-shirts, books, courses, licenses, you name it. Yeah, so why do we do all this? What is the motivation behind all that? Our goal was to keep the community active and connected, just to make sure that you know that you're not alone. And we miss you. We miss the developer communities, and we are very much looking forward to having you back here. Whenever it is safe and possible, we will resume organizing the meetups in our Berlin office here. But wait, there is more. I'm happy to announce our new project, Prisma Roadshow. The general gist of it is we meet you where you are. The fully vaccinated Prismates will visit the in-person meetups to, just to chat to you, give you some swag, see how you're doing. Our first Prisma Roadshow appearance will happen this August already. On August 11, we'll visit the folks from Warsaw.js meetup, assuming that the pandemic situation keeps improving as it is now. And the most important thing, are you a meetup organizer? Do you organize a tech event? Would you like to host us? Get in touch with us at events@prisma.io, and let's take it from there. Applying as a speaker for one of our meetups and inviting us to visit you, these are two ways of getting involved with Prisma events. But wait, there's more. Prisma Ambassador Program. We have recently launched the Prisma Ambassador Program. It aims to reward and engage our biggest fans and build a network of Prisma champions and experts. If it does sound like something for you, please do visit prisma.io/ambassador for more info. And the perks of being an ambassador, it is not just the limited edition hoodie. It is not just the visit to Berlin Prisma office, but it is also included, yes. We can also help you launch your event or bring the event you might be hosting already to the next level. And that's all, folks. This is all that I had time to tell you about Prisma events in this talk. Thank you very much for tuning in, and enjoy the rest of Prisma Day.
Thank you, Natalia. That was a great way to see all of the events that are bringing together the global Prisma community. I really enjoyed that. So thank you. And I'm now excited to invite Jed Watson. Jed is from Sydney, Australia. He's also the co-founder of ThinkMill and creator of Keystone.js, React Select, class names, and other libraries that you may have used. He's been a front-end developer since IE6 was cool, and he's passionate about improving developer experience and productivity through open source. Jed's talk title is Keystone, Next Gen, CMS with GraphQL and Prisma. Give it up for Jed.
Hi, everyone. My name is Jed. I'm from a company, Australian consultancy called ThinkMill, and I'm here today to talk to you about the concept of a next-gen CMS. It's hard to start that without going back to what is a CMS originally. And I think CMS is one of those things on the internet that was kind of the original problem that we solved. There's a lot of content and we needed to manage it. And back in the day, that meant that you have to handle a huge amount of things. Everything from database to access APIs, pages and modules. It was really quite comprehensive. And whilst that was really good, because if you picked up a CMS, you didn't have to build a lot of those things yourself. Over time, we realized that it's actually very restrictive having one system doing all these things. And CMS, well, it kind of became a dirty word for a while. And eventually, when front-end development in particular moved on, it got so restrictive that front-end developers called the revolution, said, you know what? We don't want this. Just give us the content over an API. We're going to program the front end ourselves. And we did. And that's where the concept of a headless CMS came from. And this is sort of the second major generation of CMS. And you see a lot of these around today. And really what they're doing is just taking care of the back-end concerns for content management. And it's great because as front-end developers, we're now completely liberated to program and deploy our own front ends. But not everyone's a front-end developer and not all the system logic lives on the front end. So the challenge with this is if you look at a headless CMS as not just a CMS, but actually in most sites and apps, that's your back end. Right? If you've got a back-end system that is doing all these things for you in its own opinionated way or closed-in little walled garden, well, that also kind of becomes a really limiting thing. And what I've learned over the years of building sites and apps and APIs and even frameworks on the internet is that the separation that we wish existed between content and data, it's not a real thing. Content always ends up being data. In fact, it's better if it's data. Most data relates to content. And this puts us in a challenging spot because suddenly if we want a rich backend system, and we're stuck in a limiting framework, what are we going to do? Well, the answer is we're at Prisma Day, we're developers, and we're just going to do it ourselves. The good news is in 2021, it's nowhere near as hard as it used to be. We have much better building blocks to build on when we're putting these things together for ourselves. Prisma is a great example of one of them. Prisma gives you schema, migrations, queries for the data layer. Like it actually makes programming for databases as a front or even backend developer a lot more fun. And that's really cool. I love that it exists. The thing is, if I'm thinking about a website or an app on the internet, it's not all I need. The things I need to put on top of my data layer are things like a GraphQL API and an admin UI. And these come back to the things that a headless CMS is solving for us. It's not often that you need to do all the work of putting GraphQL API together or all the work of the management UI, but if you don't have them, you're going to write a lot of code. And that's why we wrote Keystone.js. A Keystone.js is a project that sits on top of Prisma in its version 6. And it's here to answer all of the things that a headless CMS can give us, but do it in a way where we can actually program and deploy it ourselves. So on this programming thing, an important point here is that configuring is not programming. Configurable systems, most CMSs out there, no matter whether they're very flexible or quite rigid, are configurable. But configurable systems get unwieldy because scope is infinite. Right? It kind of guarantees two things. One is that you'll get a lot of stuff that you need for free, or well, license. Let's just say you get it. On the other hand, it's not going to suit you perfectly. And the more things the programmers of a configurable system try to add in, the harder it is for them to get the right answer for everyone. So as programmers, on the other hand, we can write exactly what we want. We can keep things simple by making them specific. And that's what we've built Keystone to do. Provide high-level building blocks, but that low-level flexibility that we really want as developers. And I think almost uniquely, Keystone is really laser-focused on making the developer experience of this really great. Let me show it to you. If we start with a simple project, we'll write a to-do app. I'm going to add some Keystone dependencies, and then I need to set up two files. The first is my Keystone entry point, and the second is a couple of models in my schema. We call them lists. So here you can see my to-do and my user and their fields. I've marked the email as unique and required, and that's enough to get an app running. If we go to the terminal, we run Keystone next dev. It's going to do a few things, and to step you through those, the first it's going to do is it's going to generate some files. One of them is our Prisma schema. You commit this to Git. It's part of your system. You can use it, but Keystone will ensure that it is in sync with your Keystone models. The second one is a GraphQL schema and all the resolvers and logic that you need behind that. So this is enough to actually get you two things in your browser. The first being Keystone's admin UI, which lets us create new things, view them, edit them, manage them in lists, mass change or delete them, even filter them based on very similar, very powerful features, just like Prisma Client has. We also get a GraphQL API with all of, it's almost like the same API as Prisma Client, but in GraphQL. So we can query through relationships across our models. We can run filters, we can count things, we can mutate them, update them, create them, delete them, all those sorts of things. But then you can start programming it. And this is where it gets interesting. So if I come back to my entry file and I add in a bit more code now, I'm plugging in an auth system into Keystone. And this auth system is going to mean that next time I go to the admin UI, I get to sign in. It also means that Keystone is going to manage our session, give us mutations for signing in and signing out, and for getting a password and getting a one-time signing link, and all of the sort of stuff that you don't want to actually build yourself. I can also take that auth and come to my schema, and now I can start plugging in access control. And this is, again, where defining a schema in TypeScript is a really important feature of Keystone. I can add functions to check the session and see if people should be able to read email addresses or change the admin flag at all. I can set who can access a list to update it. Either all admins or people can just update the things that belong to them. I can set that across multiple lists. And I can also hook into various events like resolving input to make sure that if you're not an admin, you can only create to-do lists that are assigned to you. You can't create them for someone else. This is just touching the tip of the iceberg of a really powerful system, but it's not that complex. There's not a ton to configure here because the key is you're just writing JavaScript functions and you're able to program it yourself to do specifically what you want. And we found that to be incredibly powerful. So what I've just shown you is a whole lot of create, read, update, delete that you get out of the box, but that's not what most systems end up being made of. It's great on day one. It gets you up and running really quickly. But the next trick is to gradually replace it. And Keystone's designed for this as well. We understand at a system level that you're going to end up over years building a sophisticated application or platform or backend for a content site. And we want to support you on that journey. So here's an example of adding in a schema extension to add statistics to the API that query the underlying database, which can use the Prisma client to do so. And importantly, they can also relate back to the types and parts that Keystone is providing for you. So you kind of replace and augment what is unique to your app without losing the automation that you got the benefit from, which you haven't needed to eject from. It's not an all or nothing thing. So programming Keystone is a really important feature. You can get custom fields, query your database. You can put your own React views in the admin UI. You can write queries and mutations for your logic. You can even tie in third-party services, microservice, stitch them into your schema. And really, what other CMS can you do that with? So there's a lot of other high-level features that you may or may not get benefit from. There are some rich fields like images, different ways of presenting the underlying data primitives that Prisma gives us access to. Also, a really, really rich document editor. This is extensible, powerful. You write basically prop types in your own React component and you get a WYSIWYG experience that manages structured data behind the scenes. This is actually one of the most exciting aspects of the project, but I don't have time to deep dive on that today. You can join me in the workshop I'll be doing at Prisma Day as well, if you want to learn more about that. But I'll leave you with two thoughts. One is that at ThinkMill, we really believe very strongly that focusing on developer experience is one of the biggest levers you've got for improving user experience at the end of the day. Keystone's been designed to focus on the code that matters, not also get you to write all the code that you didn't need to. It sort of tries to take that off you without blocking you from writing the code that you should be writing. So focus on what's important to your project. And secondly, it's designed for developers, it's designed to fit into your workflow. So DevOps is much, much better than ClickOps. You can commit your schema into Git, follow your CI process, run your tests, do branch preview deployments with your backend as well as your front end. It really wants to live in your world and not change the way you would have done the project. Just make it easier for you. And I think that is really, for me, what a next-gen CMS is all about. It's all the power of Prisma and GraphQL and a React admin UI that you can program yourself, that's not blocking you into someone else's system. So this is our take on what that looks like. I'd love you to check it out. Let us know what you think and enjoy the rest of the conference. Thanks for having me.
Wow, Keystone really looks amazing. Thank you, Jed. I guess you're probably sleeping by now, given the time difference. Nevertheless, I'm now honored to invite Sam Poda. Sam is a high schooler in Singapore who finds joy in building jazzy media experiences for people to enjoy. He's a massive fan of open source and collaborating with others to make things. In his community, he works hard to introduce students from all backgrounds to technology and support them. Sam's talk title is Prisma, Next.js, and Incremental Static Regeneration, Building Speedy Web Apps. The stage is yours, Sam.
Hello there. My name's Sam. I'm a high school student and I build fun things for the web. Currently, I'm interning at Hack Club where I work on engineering and student programs. Today, I'm going to be discussing using Next.js's incremental static regeneration with Prisma. And we've got a lot to cover today, so let's get right into it. All right, so here's our agenda for today. We want to start off by exploring our demo application, which is a virtual sticker wall, kind of like the one behind me, but virtually in the form of a website. We're then going to learn about what Next.js is, what incremental static regeneration is, and then why to use Prisma with Next.js and incremental static regeneration. And then we'll just wrap up and conclude. So let's start off by looking at a demo application. So you start off here by authenticating with GitHub. And that's how we're doing it, through Nextauth and the Prisma adapter. Then you want to type in a code to redeem a sticker. So this is how it works. So we're typing in Prisma Day here. To redeem our Prisma Day sticker. So it loads, it sends a request to a API route, which you can build with Next.js, and that creates a row in the database through Prisma. And then it updates through use SWR, which is a React library for data fetching. And that's what's updating the data on the front end. So we're just redeeming all our stickers. Hooray, we got some Prisma Day stickers, we got some Hack Club stickers. It's great. Then everyone's got a profile for themselves. So you can head to your unique profile link. So, and there it is. It's incrementally static regenerated, and that's where we're using it in this application. And you can see all our stickers are displayed there. So just a simple demo app of incremental static regeneration. So on the top of that, we also have an API because Next.js allows you to build API routes and Prisma makes it super easy. So you've got a super simple API that people can use if they want to build their own little custom applications. So let's get going with Next.js. So I'd say Next.js is an all-in-one React framework. And what do I mean when I say that? I mean, Next.js strips away a lot of the boilerplate from Create React App and provides you with a really simple setup to get going. You've literally got to have a package.json file and an index.js file, and you're ready to go. But at the same time, it still gives you all the capabilities of React and more. The developer experience of Next.js has been well thought out, and it makes building with Next.js great fun. Next.js is actually what reignited my passion for building websites. So I really love Next.js. And that's why Next.js for me is the perfect React setup. And a big reason of this is the features. So some of the features include file-based routing. So that means that index.js becomes your index page. About.js becomes /about on your page. Then you've also got API routes. These allow you to make express style like API routes. So you can make, and they run servicely on platforms like Vercel. And that's how we're doing our API like before. Then we've got image optimization, speeds up your site with faster images in modern formats like WebP. Code splitting, which speeds up your site by reducing the client-side bundle of JavaScript. Fast refresh, so when you're developing, the page automatically updates, but still maintains the state. And then you've got built-in CSS, environmental variables, web API polyfills, all this fun stuff. And obviously internationalization as well. So you can say ni hao, namaste, hola, and hello to all your users. But today's focus really is incremental static regeneration. So my favorite feature of all is the variety of rendering options with Next.js. You've got static generation, where all your pages are built and rendered on build time, and you just send HTML and JSON to the client. You've got server-side rendering, which is when a user makes a request, the page is then rendered and then sent to the client. And this makes sure all your data is up to date. And a combination of the two is incremental static regeneration, which we'll learn about now. So here's how it works. So you choose a set. Here we've got 8 users for our platform, and 5 of them we've chosen to build at build time, and 3 of them we've said will generate on request. So how this works is the 5, they're built when you deploy your app. The 3 are just left to not be built for now. But when someone visits one of those on the generated on request page, they move into the generated on build time page, and their page is generated on the server and then put there to stay. So that means it acts like a generated on build time. And then if a new page comes up, they go into the generated on request part of the part. But what if we want to update the data? Well, we can do that really easily. So in the bottom left corner, we've got someone and we want to update them. So we send one request, and in the background, now the page is updated in the background on the server. So then when we send one more request, so this just happens naturally. The user doesn't really notice this, but it's now updated. So on the second request, it's now got an updated version. Now the person's wearing a bicycle helmet. So where can this be applied? So we can apply it in things like a social network. This is Hack Club Scrapbook. It's a bit like a social network. It's basically a stream of Slack posts that have been put on a web front end. You can do embedded content like the static tweet over there, which makes it much faster to embed Twitter. You've got a blog, like the one in the bottom left, and you can build also e-commerce sites. All these are great options, but how does this look in the code? So here's our code. So if you take a look at it first, we've got the file name here. So it's got angle brackets, username.js. So that means that this page will be generated for every username, and depending on the user, it'll be either at build or request time. So to do this, we have to tell Next.js all the usernames that we want to generate at build time. So to do that, what we're doing is here, we're fetching our users. So we're fetching the top 300 with the most stickers. Then we're formatting those users so that they're in this very specific format. We've got to have a JSON object with a params key, with a JSON object as the value of that params key. And then inside that one, we need username to match with the username in our file title. And then we need to set that to the username of the user that we want to generate this for. And then we just want to return that. And we also want to return something called fallback true. That means that if someone is not on this list of 300 users, they will still get generated just at server time on the server at request time. So then this is the other part. This is where we get the data about the user. So this is run on the server if they're on request time, or run on build time if they're in the group that's meant to be built. So here we're just getting all the redemptions they have of every single sticker, and then we're returning. Then we're returning them in this format of props, and that can be used in our React application. But we also have this key called revalidate, and what that does is that means that every 30 seconds, this page have regeneration occur on the server. So every 30 seconds, we can regenerate this page on the server. So that's what that does. All right, so why use Prisma with this? So there are a lot of great reasons to use Prisma with Next.js and ISR. First up, you've got TypeScript support. I haven't used it here, but for much complex projects, having TypeScript support is great on both Prisma and Next.js, and they both support it really well. Second off, Prisma just generally has a really great developer experience, which pairs up well with Next.js's developer experience. And one of the best reasons is that you can use one language for everything. Your front end, your back end, everything can be done in either TypeScript or JavaScript or a mix of both if you want. You've got fast queries. A lot of what incremental stack regeneration relies on is these fast queries, and you've got those with Prisma. So that makes Prisma a great option for this. And then Prisma also works really well with Next Authentication or Next Auth, which I use in this demo app for authentication. It has an adapter that basically does it. You can set it up in 5 minutes. And just generally, Prisma is really easy to set up. It's a breeze, and that works really well with Next.js. So I guess the general reason why you should use Prisma is that you can ship projects really fast with it and Next.js. So that's great. So thank you so much for joining me. It has been a pleasure to present to you today. I hope you've enjoyed this presentation and learned something. If you're curious about the demo app, how it works, or anything else in the presentation, you can check out the GitHub repo at github.com/sampoda/prisma-day-2021. And whilst you're at it, I wouldn't mind a star or a follow if you'd like. But I hope you have a wonderful Prisma day. Always feel free to get in touch if you have any questions. And I wish you the best of days. Thank you.
Thank you for that concise introduction to Prisma, Next.js, and incremental static regeneration, Sam. Also, really loved your beautiful slides. Moving on, I'd like to give Chris Ball a warm welcome. Chris is the CTO and co-founder of EchoBind, a full-service agency specializing in Next.js, React, React Native, GraphQL, and Node.js. When he's not helping developers grow or creating amazing products for clients, you're likely to find him playing guitar, cycling, or camping. Chris's talk title is Supercharge Your Tests with Factories. And now, without any further delay, I bring you Chris.
Hey everyone, this is Chris from EchoBind, and I'm going to be talking today about supercharging your tests with factories. So it turns out that automated tests really love factories, and factories really love Prisma. So to kind of highlight why, I'm going to go over a few different things. The first being request tests, which you might also know as integration tests. And then we're going to be talking about resetting the database, making sure you're creating valid data in your tests. We'll touch on the factory pattern and how it relates to Prisma. Then we'll talk a little bit about end-to-end tests and how you can use those same patterns. Finally, we'll have some tips and tricks that I've picked up along the way doing this. So to start, let's talk through some of our testing types. Unit tests are great. They're important. Please write them. We are not going to be talking about that. That's all I have to say there. So in this request test, again, these can often be called integration tests. Really what I like to think of is almost like sort of like an end-to-end test, but for the API layer only. And the important part about integration tests or request tests is that you're actually using a live database. That's the important piece. So you're not mocking things out. You're actually using live data, test data. So, but yeah, basically I like to call them request tests because it's better in my head to say, hey, this is making a request and we are getting a response back. And what these are really, really good for is to test kind of permissions and edge cases, you know, make sure that a user can't call things only an admin should be able to. I can't go delete posts that you create, little things like that. So here's an example of what one looks like. And we'll go over all of these pieces. This is going to be a GraphQL example, but essentially just looking at, we're going to make the request and assert a response. So first I want to touch on these top two items. And I don't want to go too in depth on this, but essentially when you're doing this type of testing and you have a live database, you want to make sure that you reset your data between each test. So that's why we have a before each here with reset DB. So that's just a helper. You could use in that helper something like Prisma migrate reset. That would work. it's going to be a lot slower. So the best thing to do is do a truncate on your data so that every single test starts with no records in the database. It's a known state. That's really important. There's some great docs that the Prisma team has that sort of outline some of that for you. So the other piece here is after each, we want to just make sure that the database is fully disconnected so that we don't have any stray connections laying around. This is also pretty important. The final thing on this is that, using Jest, you want to make sure to use the run in band option for these types of tests. And what really that means is Jest does parallel test runs by default. We do not want that in this case because we're sort of looking at the same database across multiple tests and it's reset, but it doesn't help you if multiple things are writing to it. So those are important. And so now let's dive into the actual test. Here's the query that we're doing. So we're just checking that this mutation can be called, but there's no logged in user here. So it's just a mutation and we're going to get back some errors from the API. So in this case, we have a not authorized error is kind of the main thing that we're looking at. And you might notice I used inline snapshots there. So I actually think inline snapshots are really, really great so long as you use them properly. I like to use them to test the error responses and just basically assert that they're as I expect versus having to write them all out. So this example, you might not really understand the importance of that. It might not make a lot of sense. You could say, well, I can just write that as a normal Jest assertion, and you could. But when you have something that's a little bit more like this, this is where it's nice because then you have not only an array of errors and you can say, hey, I got back 4 items, but this is the text that's there. And anytime that changes within your app, you will be asked to update the snapshot. So they're good for that. Again, I use them for these error states pretty much only, but they're really good for that. So just make sure you don't abuse them. Next, we need to make sure we create valid data in our tests. And so we're going to look at one now where a user actually has to be logged in. So in this case, you can see that we are going to make a GraphQL request as a user. We need to create valid user data here. So to do that, we can just reach for Prisma and use Prisma's user.create and create the data we want, including things like hashing a password. So that's really nice. And we can actually not only do that, but we can create related data too. So if I have a profile for this user that I need to create, that's pretty easily done with all the nice functions that Prisma gives us. So that's just a quickly request test, integration test in a nutshell. So just make the request as a user or a guest and assert the response, create proper data for the test and nothing more, and make sure you're resetting this database. You'll find that doing these gives you a really great amount of test coverage pretty quickly. So to see how we can make this better, we're going to talk through the factory pattern. So what are factories? I kind of view them as these simple object makers. You say, hey, create me or build me an object that has these attributes. And what's interesting is you don't want to worry about the required attributes for these. We actually want to lean on the factory to give us the defaults for the required attributes. And you'll see why here in a second. So here's kind of what this looks like. We have a user factory that we're using that's creating things for us. And then we also have an organization factory. We're using these two together with a few different functions. So this looks really, really interesting. So to dive in a little bit further, you might notice that this looks an awful lot like a Prisma create call, and it does, because that's what we're actually calling under the hood. But what's important here is you can see here, I'm not passing an email on this top line. That's a required attribute for the database in a certain format, but I can override it here. And same thing for an organization. I'm saying create me an organization, just go build it. I don't have to worry about passing all the default attributes every single time. And then on this last line, it's something more like we're creating an organization, we're connecting to an existing user that we created above, but then we're also creating a new one. So this gets really, really powerful. And this is an example of how you might go create a factory in your app. So again, it's going to be just an object that returns a build and create function. And we're going to use those to build all of our objects up in the database. So if we look at the create part first, you can see that we're just calling prisma.organization create in this example. And we're telling it to use the build function that's above in order to build the proper data. And so in this case, I have a slug and a name attribute. These are both required for the database, so that's why I'm defining them in the factory. And that's also why they are using these sort of dynamic attributes as defaults, because you want in a test to be able to create multiple organizations and not worry about unique constraints and issues that you'll run into that way. So that's really helpful, and that's honestly all you need to get started with it. But then we can take it a step further. So in this example, we're actually using TypeScript, and we're pulling in the types that Prisma gives us for this organization create input. So this type's generated when you generate your Prisma client, and you can pull that in and use it. So what we're also doing is using a fake library called Chance that's allowing us to specify a word, a company. It'll automatically create a bunch of stuff that's randomized, but kind of related to that function that we're calling. And then we're just passing it through. The other thing that I added here is automatically including things. And so if you are passing in connect or create, like we saw on that previous slide, it's automatically going to add the include clause for you so that you don't have to worry about it. And so again, looking at that, let's figure out a way to make that a little bit more simple. And so this example takes all of the code that was here, and you might think about the fact if you have multiple versions of this, so you have an organization and you have a user, the code's going to look pretty similar. You're going to have a build, create, that build, the include, that's all going to be kind of the same. So this is a way to make it a little bit cleaner. You could extract a create factory function, and we'll come back to this type in a second. But the main point here is that you're telling the Prisma model that you want to use, in this case, organization, and you're giving it default attributes. And so you might call this required attributes. This is the current pattern that we've been using on a lot of apps at Echobind. And it's been pretty nice because, I want to make it so that this TypeScript attribute, again, that I had showed before, instead of being passed in manually, is kind of inferred from this Prisma model. That would be ideal. We're not quite there yet. We need to figure some stuff out. But at its heart, these 12 lines or so, this is what your factory definitions could look like in the app, provided that you have this create factory function. So you could go in and say the organization factory and a user factory and all these other ones that you might need throughout your app. This is pretty much the definition, and it's a pretty easy pattern to follow. And by the way, if you're ever extracting a library out from a code base, this is a really good pattern to follow, to where you just put it in lib, get it working, and then later extract it to an actual package. Okay, so again, those are the benefits we get mainly just due to the power of Prisma. And that's really, really great for us. So why might you want to use factories in this way? What's another reason outside of just not worrying about the default attributes? This is related to default attributes because let's say you go in and add a new one on a user called phone, and phone is now required. You, instead of searching across your entire test suite, trying to find every time you create a user and adding phone to that, we're here just going to update the factory and say, oh, phone is a required attribute for us. It's going to be in this type of format. We can use this kind of faker library to make it a little bit nicer if we want to and randomize it. But that's it. You just update it in one spot. So that's really nice. So factories in a nutshell, again, are creating an object, at least as it relates to testing in factories, creating an object that exports a build and create function. It's going to use those to build everything for you, adding defaults for required attributes, and then ideally using a faker library like Chance to help with generating random values. So next, I want to talk a little bit about end-to-end tests and how you can do the same kind of pattern there. This is where the fake library stuff is really helpful, in my opinion. So these are at the front-end layer of the code, and it's using something like Cypress as a runner. This is running into a real browser and then eventually using your front-end code to call the API and get responses back and render on the screen. So you might think, well, there's a little bit of overlap here between these requests or integration tests and these end-to-end tests, and that's true. But as long as you have a strategy to use them together, it's actually fine. So for us, what we do is, like I said, request tests for testing kind of edge cases and API business logic, still using a live database. End-to-end, it's really great to focus on critical software paths. And so those are things like logging in, creating an account, purchasing something, things like that. And then when you're creating features, make the end-to-end tests more of the happy path and maybe one error message case, but then test all of the other miscellaneous things or users trying to be bad, and that kind of thing in the request tests. So that's how we use them. To demonstrate how it's used, we're going to look at some examples using Cypress. So these are pretty much the same idea and the same pattern I just talked about. Here's what it would look like. So there's a couple things in Cypress that make this a little bit annoying. The first being you cannot use async await. And so you might notice that we're using promises and saying .then in the code. And then so we're setting something up and then just running our normal testing. It's kind of annoying, but it's not the worst thing in the world. The second is that you can't call Node code directly in a Cypress test because it runs in a browser environment. And so to get around that, you need to use tasks in Cypress, which allow you to use Node code. So we set up a task called factory. And in this case, the pattern we decided on was using, the name of the actual factory we care about, and then the attributes that we're going to build with. So very similar to how you used it in the previous type of tests. Very similar idea. And when you go to see how this is actually implemented in Cypress, we want to kind of share as much of our code as we can. And so to start, we're going to basically do this before run, make sure the database is in a good spot. And then these tasks are very similar to the others that I showed. We need to make sure we can reset a database between each test. We need to make sure we can disconnect a database. And then this is that factory function. And the factory function, again, in this case, we decided just to look it up via name. We're just importing the factories in our app and leverage it in this way. So that's pretty much all you need to kind of hook it together. There is this extra step, again, because of the way Node code works there, but that's just what it is. But otherwise, the way that you think about it and the way that you write it is identical. Let's talk about a few tips and tricks. So there's not a lot, but I just wanted to highlight a couple things here as you're thinking through some of this. The first would be, don't put relationships in your factory functions. It can be very tempting to say, give me a user with posts that has comments. If you do that, you're going to be creating records you might not need. So I really encourage you just to pass in all the relationships using Prisma's create and connect methods. It's nice. It's right in the test. It makes it very straightforward which records are created for that test. We talked about leveraging fake data to find some edge cases because using known quantities all the time can really create bugs. And so you want to use the functions provided by chance or your fake library. And then the final piece is to randomize your enum values so that you can have an active status or inactive status, and you randomize these values in your tests using something like pick one. So finally, with all of this, I'd just like to say that tests love factories, factories love Prisma. If you're interested in this type of thing and you want to help out with it, we have a discussion going on the Echobind GitHub for Prisma Factory. It's just discussions right now. And maybe by the time you watch this, there might be an actual library. And if you're interested in these kind of patterns and more, we've got a default web template that we use that has a lot of this type of stuff. So thanks so much, everybody. Thanks to Prisma for having me. And I hope you learned some stuff in this talk. If there's any questions that you all have, please reach out. That's my Twitter. Talk to you soon.
Chris, thank you for that insightful talk. I think it was filled with a lot of great tips for improving the readability of tests. Next up, we have our last talk for this part, which will be followed by a live Q&A and break. Quick reminder that you can post your questions in the Prisma Day channel on Slack. So on that note, I'm thrilled and honored to invite Malaysia McGregor. Malaysia is a senior software engineer, international tech speaker, and a mad scientist that works with hardware and software. She will try to make anything work with JavaScript first. In her free time, she enjoys learning random things like how to ride a unicycle and playing with her dog. Malaysia's talk title is Using Prisma in a Full Stack Redwood app. And now I bring you Malaysia.
Hi everyone, my name is Malaysia McGregor,
and I'm a developer advocate at iterative.ai, which is completely unrelated to this, but we do machine learning software where we make experiments easy for you. But today, I'm going to be talking to you about using Prisma in a full stack Redwood app. So if you have any questions about this during or after the talk, you can always reach out to me on Twitter at Flipped Coding, where you'll see I do front end, back end, DevOps, security, machine learning, VR. If you can use JavaScript for it, I've probably tried to use it somewhere. So that is how we ended up with this talk about Redwood. To get started, I always like to give just a quick little overview of what we'll be talking about. So we'll start off by explaining what Redwood actually is. Then we're going to do something that, I don't know, we'll see how it goes. Most of this talk is just going to be a live demo of actually getting Prisma to set up a database, migrate schema, and get a working full stack app. So we'll jump into the code and set up the app. Then we'll set up our Postgres schema with Prisma. And finally, we'll make our front end and back end all integrate with this database. And at the end, I just have a few points that I hope you take away from today. And with that being said, let's start talking about what Redwood is. So Redwood is a full stack framework that uses React for the front end, GraphQL for the back end, and Prisma to handle all of the database needs. And something you'll see throughout this talk is that Redwood has a lot of commands that just do stuff for you. Typically, I don't like black box type framework stuff, but Redwood makes it pretty easy to go in and edit the files however you need. So, with that being said, let's just jump into this live code part. So I'm gonna try to switch to, ta-da, we have a VS Code thing set up. So I'm gonna show you the command that you would use to make a new Redwood app. It'll be this yarn create Redwood app, and then the name of your app. But I'm not going to run it because it does take a few minutes to get Redwood completely set up, but I'll show you why. So over here, you'll see all of these files and folders. Redwood makes those automatically for you, but the main ones we'll be looking at are this .env file, will be in the API folder, which handles all of our Prisma stuff with the database and all of our GraphQL stuff for the back end. And we have this web directory, which handles all of our React front end stuff. So to go ahead and get started, I'm gonna go in the .env file and uncomment this database URL line. So if you have Postgres set up locally, you'll go ahead and put in your local connection string. So I don't mind you guys knowing my local password stuff is probably the same as yours. And I'll call this database Prisma Day. All right, so now we have our Postgres connection set up. We're gonna come inside the schema.prisma and change our provider to PostgreSQL because we're not using SQLite. And you'll see where we bring in that database URL. And now down here is where it gets fun. So Redwood has this example model schema for us, and we can go ahead and start making our own. So this app is just gonna be a really, really simple user dashboard. You can add different kinds of users, and you can have items that are maybe in different locations. So we'll just have 3 tables with the schema for these things. So first up, we have a user, and I'm gonna leave all of this the same. Then we'll have a location, which it'll have an ID, and we'll make it an int and go ahead with this auto increment. So this ID at default auto increment, that means that we're telling Postgres, this is our primary key for the table, and we want you to just default the next number every time a row is added to the table. So that's what we're doing with that. And we'll just give the location a name. And lastly, we'll add our item model. So this will have an ID, same as the others. So I'll just copy and paste that. And it'll have a name. I wonder why that looks like that. We're gonna hope that's not an error for no reason. And it's just, oh, model, not modal. There we go. So we'll have an SKU, which will be a string. And then lastly, we'll have our items attached to a location. So the way we do that with Prisma is with relations, and we will make a location ID field, and the reference will be to our location table, and we'll base that with the ID, and we'll come down here and make this foreign key location ID. So do some formatting there, and ta-da, we have our entire schema set up with Prisma. So we have a relation here which makes this location ID like a foreign key on the item table that references a row on the location table. And then this unique attribute, it just says, hey, this field can only have unique values, so no two email addresses can be the same. And last thing we need to do before we go ahead and migrate this schema to our database, let's add some seed data. So seed data is just some initial data that you add to your database when you spin up a new one. So with prod, that might be adding, I don't know, a list of drop-down options that you know aren't going to change, or maybe you need to set up a default user or something. That's what seed data is normally used for. So I'm gonna delete a bunch of stuff because Redwood does come chock full of comments, but we don't really need them. So I'm gonna delete some more stuff. So got rid of that, and I'm gonna uncomment this, get rid of a little bit more stuff, and I think that's it. Yeah. So I just deleted a bunch of stuff, nothing too crazy there, hopefully. But we're gonna go ahead and create a new user, a new location, and a new item. So I'm gonna copy and paste this a couple of times, and we're gonna update it to match whatever table we're seeding. So first, we know our user has a name and an email, and I'm just gonna hard code that in here because we're just adding one user. So we have Kaya at test@best.com, and then we'll add something to our location, which is just going to be the name. So I'll call this Compound North. And last, we have our item that we need to seed, which has a name, an SKU, and a location ID. So, I don't know, Morning Glory. We'll give it an SKU of me hitting random keys and a location ID of 1. So I'm putting 1 here because when this is seeded, it'll have an ID of 1 because of this default auto increment. So we already know what location we're attached to. So with all of this in place, let's go in the terminal and run yarn rw prisma migrate dev. And this is just gonna make our new migration. So it's asking for a name right here, and I'll just call this initial migration. All right, sweet. So I always clear the terminal. I don't know why. I guess it just bothers me if it's not clear. But I'm gonna switch over to PG admin so we can take a look at that new database. So I'll refresh. You see we have our Prisma Day database. If we go and check out the tables, oh, we got the item, location, and user. And right now there is nothing in them. So we'll head back over to VS Code where we will seed the database. So we'll do that with yarn rw prisma db seed. And this will run our seed stuff here. And it says it's been seeded. So let's see if we have data now. So if I hit play up here, oh my gosh, look at that. We have a name. If we go over here to the item, oh, look at that. We have that SKU, we have our name, location ID, we are good to go. So that is how you handle creating schemas with Prisma. It's how you see data with Prisma. It's how you migrate with Prisma. It was all pretty fast, wouldn't you say so? Like, that took maybe 7-ish minutes? I don't know. I'm trying to time it, but maybe I'm off by a little bit. Anyways, so you've seen how to make your database schema. We've seeded some data. Now let's talk about how we can integrate all of this with Redwood. So I'm gonna briefly switch back over here just so that I can change the slide. So we set up our Postgres schema with Prisma, and now we're integrating everything. So what that means for us is a bunch of Redwood commands. The first thing we're gonna do, I'll close out these just so we keep things clear, but I'm gonna blow your mind with this one because it blew mine. We're gonna run yarn redwood generate scaffold, and we'll do this for user. So what this scaffold command is gonna do, it finished a lot faster than I expected, but what it does, it creates our, actually, I'll just show you what it did. So over here in the API directory, we have this new users SDL, and it defines our GraphQL schema for the users schema. So all of these mutations, all of these types were created based on that schema we made with Prisma. And we didn't do anything to get this. We just ran one command. Then you'll see here in the services, we actually have our resolvers for all of those mutations and queries. So you can create a user, you can get multiple users, one user, delete them. It's all here for you. And we have tests, and we have like test data. It's beautiful. So that's the whole backend setup for you. All of your GraphQL stuff ready to go. So if we come over here to the web, look at this components folder. We have something for our user form to add new users. We can edit them. Edit them? Yes, we can edit them. You can look at a table of them. It has everything there. If there was a particular layout you want to apply to all of your user routes, it's here. Then in the pages, we have 4 new pages for our users. So it's just there. Like everything is just here. It even updated the routes for us. And if that's not mind-blowing, I'm going to clear the terminal and run the whole app with yarn rw dev and give it a little second to get going. So sorry if it sounds like I'm super pushy on Redwood. It just blows my mind every time. I'm like, I can't believe this thing just does this out of the box. So over here in the browser, yeah, I'm gonna say that's right. So let's go to the users route. And oh my gosh, it's already there. Like, this is our table that we didn't write anything for. It has our entry from the seed data we made. If you come over here and click edit, you can update this in any way. I don't know, test the best. And it's updated for us. We can add a new user just to show that everything's connected. And it's there. Like everything is just there from that one command. So if I delete Kaya, that goes away. And then just to prove to you all of this is updating like it looks like it is, I'm gonna come over here to the user table. And if you noticed, we just have Damien in here. Kaya is gone. And just to prove it one more time, I'm gonna come over and wait, let me get back to the browser. So I'm gonna add another user. Let's add Jacob. And just like that, Jacob is there. We go back over to PG admin, play this, and boom, there's Jacob right there. So this is how you can do things with Redwood really fast. Like, we just set up an entire database, a GraphQL backend, and a React frontend in less than 20 minutes. That, I don't know. Like I said, maybe I'm just a Redwood fangirl, but that just blows my mind. It was that fast. We didn't have to write any of this. Of course, you should really know about how GraphQL and Prisma and React work before you just jump into Redwood. But if you have a decent grasp on those things, it's just easier to get started with something that's already there for you. So now that I've shown you how to set all of this up, it's time for me to go ahead and wrap things up. So here's some key takeaways. Prisma makes it super easy to work with data from different databases. So we just used Postgres here for an example, but it works with SQLite. I think they've added MongoDB support. So you have plenty of options if you decide to use Prisma. And then Redwood, as you see, it lets you make a full stack app pretty quick. Like 20 minutes or less, you can have your entire startup bootstrapped. And just try out random stuff you find online. Like, I didn't even know Redwood existed until sometime last fall, and I just kind of stumbled upon it. Like, there was no real reason that I found Redwood. It just happened. So if you find those random things online, don't be afraid to try them out because they might become your favorite new tool. So my name's Melisha, and if you have any questions, feel free to reach out to me on Twitter at Flipped Coding. Thank you.
Malaysia, thank you for the insightful talk. It's always fun to see Redwood in action.
Yeah, thanks for having me.
We're going to do a live Q&A. So to our viewers, if you have any questions, now is the right moment to drop your questions in the Prisma Day Slack channel. So let's get right into it. Militia, you ready?
Yeah, bring it on.
All right. So one of the first questions that came up is, how can you add more complex table relationships with Prisma?
So to do that, you'll just have to use a bunch of those relation tags on different fields in your model. And you can make many-to-many relationships. You can make one-to-many. It's just making sure you're referencing the right fields in those relations. So it's pretty easy to just keep adding things as you need them.
Mm-hmm. And that all starts sort of with the Prisma schema and then sort of, right. And can you manually create all the files generated by Redwood, or do you have to use the commands to create them?
Oh, you can definitely manually create everything. It's just, if you have your schema defined before you have already started making files, Redwood generates a bunch of stuff for you right from the beginning. But after that, you can feel free to just make whatever files you would like normal.
So a bit of a good old copy pasta if you're not. All right. We also had a question from, I believe it was from Yogi, who asked if there's any ETA for custom email and password authentication in Redwood. Is that something that you have an answer for?
I know that there's already some auth integration with like Auth and I want to say AWS Cognito. But if you take a look at the docs, there's some auth integration already in there.
Cool. So I guess we'll be also dropping a link to that in the Slack channel. And we had another question that just came in, which was, do you ever feel like you're being limited by Redwood?
Ooh, that is a good question. Not really. It's like I said, if you have the Prisma schema already before you start making the app, it's easier to get the files auto-generated. But as you work with it, they don't do a lot of, like black box magic. You can go in and edit all of the files later, however you want. So I don't feel limited with it, or at least I haven't pushed it hard enough to find those limits.
Right. Let's see if we have any other questions. Okay. Looks like we have no questions from the audience. This is your last chance. And I guess I have one final question. Generally speaking, when you're building, and what is the first thing that you like to do? Do you like to dive into code? Are you more of you start data modeling first with perhaps the Prisma schema? What's sort of your first step when you start a new application?
For me, I always like to start with my data model just because, I don't know, that's how I think. I can start with the front end, but it feels a little weird for some reason. But I usually start with my data schema and build everything out from there.
Great. Well, on that note, Malaysia, I want to thank you once again for joining us. Thank you for sharing your knowledge and experience. And I hope to see you soon, either at a Prisma meetup or one of the other community events that we host.
Yeah, thanks again for having me.
All right, all the best. Okay, we're now going to take a break. But before, Natalia is going to join me and we're going to announce the raffle winners. So quick reminder, we have 5 prizes. We have Prisma's new t-shirt design, which I'm wearing. It has a lot of really cool like polka patterns, including the Prisma logo. We also have $150 sponsorship of an open source project of your choice, a ticket to a conference of your choice up to $500, a Lego robotics set, and finally, a Bedrock license. Bedrock is a framework that was created by Max Scheuber that aims to make it really easy to build web applications. So now I bring you Natalia. Natalia, how's it going?
Hi, it's going very well. The wait is over and we are ready to announce the winners of the raffle. The slides are
Ooh.
visible, right?
I don't think I can handle the tension anymore.
I know. It's terrible. So I'm just gonna explain quickly how we chose the winners. So I entered all the, let's say, candidates into a randomizer tool. I didn't want to do it live to protect your privacy, but I did record my screen when I was doing it. So if somebody wants to double check that everything is legit, they can hit me up and I can show them this recording. So yes, drum roll. Cool. The first prize was the t-shirt that we are premiering today. It's kind of like this very discreet Prisma confetti design. And that is going to Divian Doos.
Ooh, I believe we know Divi.
We do know Divi. He is chilling out downstairs. Next on, we have the $150 of donation to an open source project of your choice. And that goes to Swag Mysterio.
Swag Mysterio, you are
Swag
a winner. I'm really curious to hear.
Yes, we have everybody's emails so we can get in touch with everyone. The next one, Lego Robotics, the big one. And at Peter Joe 47, 69, 77, 42 will be having fun with this Lego set soon.
Okay, Peter.
Moving on to the Bedrock license, that goes to It's Me 5247. So it is you who will have the chance to use this license soon. And last but not least, we have the conference tickets to the conference of your choice. And that goes to Real Archer L.
So the Real Archer, you are a winner.
Yes, all of these are. And that is it for the prizes. Thank you very much.
Okay, thank you so much, Natalia. We're going to take a quick break now and we'll be back soon. I'm also going to share a short yoga at your desk video on Slack, if that's your cup of tea. You know, we've been sitting a lot on chairs today. So I hope you enjoy the break and see you soon.
Okay, that is a pretty neat bit.
And hit refresh, run that again. Do we get another one? We do. Oh, how cool is that? Nice.
Thank you for giving examples, Prisma. You're the best.
Ooh. Ah, look at that. This is so nice.
I'm not gonna lie, this is really cool. Like, I did not know that this was a feature, and this is a really, really handy feature. That this is, you know, a thing that we can just very quickly stand up. I like that a lot.
But yeah, this is awesome. This is really cool.
Exactly.
This loads up in the browser.
Now submit these links. They're gonna go in the database. This is how easy Prisma makes working with databases.
This is Hudson. He's a 6-year-old Arctic fox who is one of the ambassadors of Woodland Park Zoo in Seattle. We wanted to ask Hudson a couple of questions, and these were his answers. Hey Hudson, are you excited for Prisma Day? Nice. Well, we wanted to ask you a couple of questions. Wait, we haven't even started yet. Come back. Okay, so we wanted to ask you a couple of questions, but before that, do you want to hear a joke? Okay, cool. So a SQL query walks into a restaurant, sees 2 tables, and asks them, "Can I join you?" Come on, it's a good one. No? Okay, well, we have like an important question. Do you have any idea about like what happened to production yesterday? Hudson, where you go? Hudson? Okay, that's not suspicious at all. Hey, did you know you can use Prisma with Go?
Seriously?
Yes, it's part of the Prisma ecosystem.
So like, what do we get?
You'll get an auto-generated type-safe query builder, declarative data modeling, schema migrations, and visual data management. So the complete Prisma experience.
That's so cool. How can I try it?
It's still in early access, but we would love for you to try it out and to give us your feedback. So if you're interested, go to prisly.go.
Welcome back. If you're joining from the Americas, good morning, and thank you for joining us. I hope that you're all refreshed after the break and ready for the fourth part of Prisma Day. Before we get moving, just want to have a quick shout out to all of the winners of the raffle. You can find them on the Prisma Slack channel. And now we're ready to introduce our next speaker for today, and that is Mike Cavaliere. Mike Cavaliere has been doing full stack development for, well, a while. He's a senior engineering strategist at EchoBind and the author of Cut into the Jamstack, Build and Deploy a Full Stack Application Using React and Next.js. His talk title is Prisma and Next.js for Jamstack SaaS Applications. So now I bring you Mike Cavaliere.
Hey, everybody, I'm Mike Cavaliere. I'm going to be talking to you about a recent experience I had developing a software as a service application using the Jamstack as just an individual developer. So overall, I'm going to first talk about like motivation, like why I went down this path. I'll give you a little insight into the app itself that I've been building. I'll tell you about the individual libraries and tools that I worked with and why. And then I'll go into sort of the lessons that I learned from this, you know, what I love about the stack, a couple of challenges that you might run into if you decide to do something similar. So a little bit about me. I work for a company called EchoBind. We're an agency that develops all types of web and mobile software. Senior engineering strategist, which just means that I've been engineering for a long time, some 20 years now. And now I'm a little more on the strategy side of what to build and what not to build. I've been working with JavaScript for pretty much my whole career. I've definitely done a couple of years worth of PHP and Rails and different capacities, but JavaScript's my heart, the thing that I love the most, especially React over the past couple of years, lots of React and React Native. And Next.js in particular has really grabbed my attention over the past like year or two. It's what I reach for just about every web project nowadays. So in terms of this app that I'm going to be talking about, a couple of months ago, like around October, I realized that I had been, writing software for a long time, but not teaching nearly enough. And so I've got all this knowledge and I wanted to put some more of it out there. I've been doing a lot of blog posts, but I thought that it was a good time to write some kind of a technical book. I don't get necessarily engaged in just teaching someone one particular programming language or one particular tool. I like teaching people how to make a lot of tools work together. And at the end of the day, have them ship something that's a product, that's a working application. And I like teaching all those things together. It's really enjoyable. So I wanted to do that, but I didn't want to teach, how to build another to-do list app or something generic like that. There's just too much of that out there. So a software as a service application that did something valuable was what appealed the most to me. And it seemed like a really good teaching tool because in the process of doing that, you touch on a lot of different development topics. And I had a personal need at the time. My wife and I, we have two really cute kids, Leo and Max. Leo's 2 and Max is about to turn 2 months. So we're taking photos of them all the time. And I didn't have like a really simple way to share them with family members. Like Google Photos and the iOS Photos app, like sending a private photo gallery isn't always as straightforward as I'd like it to be. And I just kind of wanted a way for my wife and I to collaborate on an album and just send a link to our relatives so that they've got a consolidated set of photos. And I also wanted to build it myself because I love the Jamstack and scratching my own itch felt like an enjoyable thing to do. So the app was named Jamshots. I came up with a handful of names and I just had some members of the EchoBind team vote on them. This was the one we came up with. And it lets you upload photos. It's going to let you collaborate on a gallery pretty easily and share the photo gallery. And it's a pretty simple process. You create the gallery, name and description. You tap to upload a bunch of photos. And you click another button to share the link and you've got like a nice, pretty decent looking photo gallery. So the stack I used was based on Next.js, which includes React. React, I use pretty much anything web nowadays, and Next.js is my default framework for React to go to because it's performant. It's ready set up for SEO and speed and accessibility, and it just makes a lot of things easier, like route creation. So it's where I start all my web projects. For the database, Postgres is another solution in that way that it's the default one I reach for because as a relational database, it's been around so long, it's very established, it's performant, and it's good for just any generic purpose. Prisma, as we all know, is like a great ORM solution. I like the simplicity of it and the flexibility. And to me, Prisma is very much like, like when I discovered Ruby on Rails Active Record, and it gave us this really great way of versioning databases by telling the ORM how you wanted the database to change in every iteration. Prisma's like that, but it takes another step further where you just tell it how you want the schema to look and it does the changes for you. So in addition to that, the fact that it's got very easy ways of working with the database for finding and updating and manipulating, it just makes it a really elegant ORM to use. And then SWR is a data fetching library that uses React hooks that's written by the same people that made Next.js. And it just makes fetching information into your pages really easy. Next.js is a great authentication plugin. So I needed that to make it really easy for people to log in and log out of the app. And then on the design end, I'm not a designer, so I always reach for a UI toolkit, which by default is Chakra these days because it's unobtrusive. It's very easy to work with. It uses styled components and emotion under the hood and lets you pass styles into properties. So it's very composable. And then Chakra Templates is a site that has copy and paste UI patterns using Chakra UI. So it makes some common interface patterns really easy. Then React Hook Forms is pretty popular. React Form library that also boasts of being very performant. It has like a minimal amount of renders, and the API is really easy to use and great. For hosting, central to this app was the image API. So I picked Cloudinary. They're excellent and have a free plan, and they have a pretty good API interface. Vercel is the company that makes Next.js, and their platform is very easy to deploy to and fast. And Railway is a newcomer to the database world, which also boasts a free plan and has a lot of other great features as well. In the course of building the app, there was a lot of lessons learned, and a lot of it reinforced the stack that I chose and what's great about it. But it also opened. It also made me make note of a couple of things that are a little more challenging. That if any of you try to build an app in a similar manner with the Jamstack, specifically like Next.js and these other libs, then some things that you'll want to keep in mind as you go on and develop it. So an auth, Next.js is just phenomenal. I built into this app. I've got a one-click Google, Facebook, and Google and it's Google and I think GitHub sign up right now, but that'll probably be changing. But be that as it may, Next.auth integrates with just any provider you can think of. AWS, Discord, Slack. You can click and sign in with Instagram. You can click and sign in with anything. It also lets you use databases for managing users. And in minutes, it takes nothing to set up. You just install the package. You paste a little bit of pre-made JavaScript into an API route in Next.js, and then you add your API keys for whatever provider you want, Google or whatever. All of a sudden, you've got a very easy to use one-click sign up for one-click sign up and authentication. It's also fully customizable. So if you want to change the screens that are displayed when you prompt the user to log in, you can customize the visuals of that whole flow. You can also customize the behavior. So if you wanted, for example, to track authentication, depending on provider, you can send off a custom event anytime that happens. I've got a series of 3 blog articles on Next.auth, just so you can see a couple of the different things that you can do and how to do them and just how easy they are. So check that out if you're interested in learning more about Next.auth. I highly recommend it. UI was really easy and enjoyable with the stack. Since I discovered Chakra templates, it made designing easier without having any design sense, which I have just very little, even after 20 years. I didn't want to pull on a designer, as I typically don't want to do for an MVP, a minimum viable product, or a personal project. But I just wanted to look borderline nice. Like, I want it to look not hard on the eyes. It doesn't need to be award winning or anything like that, which for a first release, it never needs to be. It needs to be functional and decent looking. And that's exactly what you kind of get. With Chakra templates, you can copy and paste a lot of common use patterns. And then from Chakra itself, you can add all the buttons and the headings and the typography and the layout. If you take a look at this, this is a couple of screenshots of the homepage that I built for the book, which is built on Next.js and Chakra, and uses all of these copy and paste things from Chakra templates. So the hero unit is copy and pasted and customized from there. This little features module, this pricing module, the sign up form, and the footer, all from Chakra templates. And these two sections are built with Chakra UI itself. And all of this took like less than a day overall. And the rest was just like tweaking some pixels to make everything spaced consistently. The photo gallery world in React could use some improvement. If you do a Google search for React and photo gallery, you'll find a lot of libraries out there, but a lot of them are out of date. The one I picked looks really good, and it has this nice staggered effect for the images. But I found some bugs with the responsiveness of it and that are kind of deal breakers. And the thing was last updated in 2019, so it's not going to be fixed anytime soon. So either I have to dig under the hood of that gallery, plug in and fix it, or what I started to do, which is create a new one with CSS Grid, which has its own set of challenges. But the takeaway here is that the photo galleries could use another good open source plugin, because I don't think anybody's really done it well, at least not in the past couple of years. So async multiple file upload. I also didn't find a pre-built open source solution for that in Next.js. And there's a couple of different pieces. There's the front end, there's the back end, there's the integration with Cloudinary or Imagix or whatever API you choose. So I ended up rolling a custom solution, which was really fun to build, but a good amount of effort. It's just worthy of note if you need this feature in an application that you're going to spend some time on it. I may roll this into an open source plugin myself at some point, just to make it easier on other people. In this case, Cloudinary also, I had to use a couple of different APIs to get the best performance, because when you're uploading an image to an API from the browser, you don't want to go through your own Next.js API to do the actual upload. Which means you have to sign it. So just to give you like a quick overview without going into detail here, just note that this architecture here is significant. There's 4 pieces in the app: the front end, the back end of Next.js, or the front end and the API. There's the database, and then there's the image service. And you're going to have to make at least several API requests to do it to different places. So you just know that's a non-trivial amount of effort if you decide to implement file uploads. Hosting worked out extremely well. Vercel, Railway, and Vercel, Railway, and Cloudinary, as I mentioned, all have free plans, which is great when building an MVP, because you don't want to spend anything if you know you're not going to make any money, or if you think you might make money, but you're not sure yet until you get users and people actually paying for it. So whenever I bootstrap a project, I try and use as many free tools as possible. Railway is the only tool I know of that gives you free database hosting and lets you create a development and a preview database for free. So that's awesome, but it also integrates really well with Vercel. So Vercel is the company that makes Next.js, so their platform integrates really well with Next. But when you create a Railway application or a Railway set of databases, you click the integrations tab, as you can see in this image here, and it's just another couple of clicks to integrate it with Vercel. And it basically takes all the environment variables to connect to the database and puts them into Vercel automatically for you. So there's no copy and pasting of database strings and passwords and all that. It just does it automatically for you and keeps it up to date, which is a big hassle saver, so you can focus on coding. It is worthy of note that Railway is only in the US West location, so you have to point your Vercel app to use that for now. But they are a fast-moving team, and they're shipping new features every Friday night. So I suspect they're going to go into other regions, definitely eventually, but probably sooner than later. So notes about the image API that I had to create. You know, when you're using an API service like Cloudinary or whatever, you're going to have references to those images in your database, and you know, mash up the data with your database data about those images. So you do have to do a little bit of manipulation and aggregation of information from the Cloudinary API with your own database API. So it takes a little bit of work and a little bit of a paradigm for you to define. One thing that I'm going to have to do here, which I made a bullet of, is start caching some of that data offline too. Whenever I load a photo gallery, you need the width and height dimensions to pop into the Next.js image component, and also to help with rendering. And those, right now, I'm making an API called the Cloudinary each time I render that to get that metadata. Ultimately, something like that you may want to cache in a database just so you don't have to make an additional API request, because the more API requests you make to something like Cloudinary, the more likely it is you'll have to get to a paid plan when you get a little traffic, or you may get like throttled. You know, you may have your API requests reduced. So if you can cache something offline and manage it, then it's going to be helpful. Note on Next.js's image component is that it's really helpful because it lazy loads everything automatically. And on the gallery UI, when there's a lot of photos, or any UI like that that has a lot of photos, you're going to want to lazy load them, and it just automatically does it for you, which is great. I made a note here that it could use like an animation for when the photo is loading, because right now you just see a blank spot when, you know, there's photos loading, and you wouldn't know that there's a photo there. Luckily, Next has a feature for like this in their Canary release, so that's probably going to get integrated into the core soon. So you'll be able to see some kind of loading indication for that. They're doing a lot of great work on their image component, but just every other thing. A lot of good moving velocity on the Next.js project. Create, read, update, delete with database is really easy. Next.js and Prisma work really well in this case. In Next, you know, you just drop a couple of routes, API routes for all the different HTTP verbs, or for the database operations rather, that you want to create. So you can see here what I did for the galleries. There's a delete, there's a show, there's an update, create, and a list view. And in Prisma, basically each one of these has a single API call. Prisma's API is really simple and straightforward. So it's usually you just pluck in an ID from the route, calling find unique, or kind of calling update. So note about Next.js API architecture is that it's straightforward and simple and really easy to work with, but it's not built in for, it doesn't have an opinionated API structure. So the serverless functions are just pretty much, they take a request and they return a response. For this project, it made it easy enough to define kind of like a REST API architecture, because all I had in the database was users. Users have photo galleries, and galleries have photos in them. So we didn't need a crazy amount of API endpoints. So there's not, and I also didn't want to overcomplicate the teaching in the book by adding in like the whole discussion of API architecture. I wanted to keep it straightforward and focused on the tools. Just note that if you've got a simple project, this works really well. If you have something more elaborate that's going to require an API that you're consuming in all different ways, you're going to want to look to something like Apollo Server and GraphQL for a more robust API. You could also consider using something like Nest.js so that you've got all the bells and whistles of like a really good microservice in there. One thing that also I noted is in creating a fair amount of API endpoints, there were a lot of common tasks that I had to develop some kind of way of reusing for. Otherwise, it's just a lot of repetitive code. So in this code sample, I'm checking the request method, which I did on every non-get API request. And then if it's not the right form, I'm throwing a 400 error. Likewise, I'm checking if people are logged in and the session exists for most of the application. And this just became a lot of like redundant code. So I found online a really nice middleware function pattern where you're just essentially wrapping the Next.js API handler with another function that does something else and augments the request. So in this case, this is the with Prisma client handler. I have a globally instantiated singleton instance of Prisma. And in this wrapper, if I wrap a route with Prisma client, I'm taking the Prisma client and just attaching it to the request object so that the rest of the API route just has that available in it, and I don't have to repeat the code to instantiate it. I mean, you can see like this snippet on the left looks a lot cleaner with these middleware functions, and the snippet on the right is actually a little bit more. It's doing a little bit more and with less lines of code. It's got instantiating the Prisma client or retrieving it, checking that there's a session and the person's logged in, and checking the HTTP method before it moves on to the code that's specific to the endpoint. So that's it. Sum up, like Next and Prisma and then the rest of the libraries that I use in here are just an awesome stack. Great for developer experience, really enjoyable to work with. The performance is built in by default, so you're usually going to get a good Lighthouse score for performance, SEO, and accessibility just right out of the box. There are a couple of use cases, like I mentioned, where I think there's some good opportunity for open source libraries, namely like multi-file upload is one, a good photo gallery plugin would be really great too. Whenever you're using a stack like this, think about how you want your API to look. Is it something that's going to be easy and simple, where you could just do kind of a REST, like a simulated REST API with the Next.js serverless functions, or do you need something more robust like Apollo Server or Nest.js or any other API architecture? And you know, if you do decide to use the Vercel and Next.js API functions as your API, then just look for patterns for code reuse, which you'll probably need to do on the front end with a stack like this too. The middleware functions that I showed you are one pattern, but there's plenty of other opportunities for doing more, because there's with raw API endpoints like those, there's going to be some common tasks that you'll want to just simplify and dry up. And this is the book, sorry. This is the book that walks through the app in a lot of detail. There's a release right now that's 107 pages, and it goes through a lot more step-by-step process of how I iterated on the app, if you were interested in that. And basically goes through like full stack CRUD and deploying production. And right now I'm writing the portion that has to do with all the file uploads and that. And then later on, it's going to go through a lot of more user interface patterns and, the aspects of integrating with Cloudinary and manipulating data in the way I just showed you, but just in more detail. And that's it. Here's a link to my information. If you have questions on any of this or just want to talk about the Jamstack or any of these tools, reach out to me anytime, Twitter, email me. Check out the EchoBlind blog if you want some more topics, more articles on the topic and other JavaScript related things. And that's it. I hope you enjoyed the talk. Thanks for listening.
Mike, thank you for the wonderful talk.
My pleasure. Thanks for having me.
I think that was a great example of pragmatism when building as a solo developer. And I'm sure that many of the future indie hackers who are watching this will find this extremely useful.
I hope so. I tend to like to, when I'm working on solo stuff, I tend to like to, try to not do everything perfect and use like what is the most simple but effective way of doing things, which is kind of like with TypeScript, for example. Like TypeScript is amazing, and I use a good amount of it, but I also know that like there's a bit of a learning curve, and you can sort of you can go overboard spending too much time creating types. So in the book and in practice, like I tend to use like a certain amount of TypeScript that's just enough to be very useful at preventing bugs from getting into the code, but not too elaborate to where it like prevents you from getting things done.
Yeah, I also really liked how you approach image uploads with Cloudinary, especially like how you avoid routing unnecessary traffic through the API. Basically, I get, from what I understood, you get a token from Cloudinary and then you use that to upload directly. to Cloudinary without having to go through the API.
Yeah, and that's the way. I mean, we've done this for clients before with other APIs like Mux Video API, for example, and it's it takes a little more work to do that way sometimes. In the case of Cloudinary in particular, because you have to use a couple of different APIs to do it. There's like the Node API that you use for the metadata, and then there's the REST API that you use for the direct upload. But in the end, it's worth it. There's so many reasons to do it, namely like everything's going to perform better, and uploading an image or a video is already like a performance challenge, especially if you're on a mobile device. Then you add to that uploading multiple of them, and then there's the issue of you don't want to get charged more money because you're sending so much stuff through your API that it's just going to add to your bill. So yeah, certainly worth the work to do it. It just takes a little planning, and you kind of got to know, that you have to have something signed and return information, and then send it, and then return information, and then add it to the database.
Yeah, and I guess there's like, some of that logic orchestrating all of this is adding some overhead, but it pays off very quickly.
Oh yeah, absolutely. But I do hope to get some time to extract this into an open source library if there's enough interest, because I feel like, at least for myself, it would really save me time on future projects, because I know I'm going to have to do it again for something. So it would be great, specifically for Next.js, to have something that you can just kind of yarn install, and you have this functionality.
And essentially, this would basically allow you to connect both to Cloudinary or some other sort of static CDN, and do the whole metadata in Prisma. That would be the high level idea there.
Yeah, yeah. And I mean, it could be extracted out more to work with, different databases and ORMs, different API providers like Cloudinary, Imagix, and so on. And then there's the UI portion. So in the presentation, I have a little video clip of the UI that I built in Chakra. That could be another component as well, because if you've got multiple file uploads, going at the same time, each has a status. There's whether it started, whether it stopped, whether it's error. And in React, that was another piece of work that I had to do, which is to build this component that has a bunch of entries that are in progress, the file names, and then the current state. And then ultimately that would potentially have a progress bar too. So that component on itself was another little bit of effort to build it.
Yeah. Well, that was great. And I'd also like to open up the Q&A to our audience. So if you haven't already, feel free to drop your questions in the Prisma Day Slack channel. And let's get right in. So what was your motivation for working with this stack and the tools within it? Were you already using all of these tools?
Good question. So some of them I was. So at EchoBind, we have a set of tools that we use for what we call our greenfield stack, which means, the applications that will build from scratch for clients. Sometimes clients will hire us to take over their existing architecture and do something else with it, either add features or migrate it to a better stack. But when we're building these from scratch, we have a toolkit that we use that is now open sourced. It's called Bison. So if you go on the EchoBind GitHub repo, you'll see the Bison app, which is a generator for apps of this sort. And so I got familiarity. I already loved Next.js and React, and I got familiarity with Chakra and Prisma and Apollo, partially from using this Bison generator that we've got. So I was familiar with a good amount of them, but I wanted to go even deeper in a lot of these. Next.js is one of my favorites. Prisma, I had a good understanding of, but I wanted to really get deeper into it. Same with Chakra UI. Chakra UI seemed very appealing on the surface, but I wanted to do more with it. So, I utilized some of these tools that were already in EchoBind's Bison generator, and I augmented a bit. I found Next.js on my own when looking for a good one-click sign-up solution, and it just seemed phenomenal. It appealed to me immediately. So I took that, and Cloudinary was a solution that I knew about for image hosting. And I compared and contrasted, Cloudinary, ImageX, and S3, and Cloudinary is just the one that I decided to pick for this because they have a free plan and they have some good image transformations. So I had familiarity with a number of pieces of stack, and I augmented based on the needs for this particular app.
Got it. And what do you think is a good starting point for folks who want to start with these technologies?
Also good question. So I think my book is a good starting point, not to hard sell, but I wrote it because it's meant to be a crash course in the stack. But people can also ask me if they're looking for a recommendation for learning a variation of this stack. You could start with Next.js. I think that's a good one. And Next.js's documentation is phenomenal, and as well as the Chakra UI documentation. If you've got even just some basic JavaScript and React experience, you can grab those two tools and start building things right away. Same with Prisma. You guys have excellent documentation. But yeah, I've adapted to it really well, and that says something because I'm a slow learner. So the book is meant to be that getting started guide for this particular stack. Any of the individual tools have great documentation online, and I plan to write a lot more blog posts about using these individual tools as well.
I see. Look forward to those. Is there anything about this combination of libraries that you would change, especially after having already built out this app with it?
Yeah, so it's evolving as I work on it more and more. One thing which Bison solves really well that I didn't solve myself is that it's got good code generation capabilities. Having spent a lot of time working in Ruby on Rails, I think that was very spoiled by the Rails generators. And that and the the generation and the scaffolding I think is missing. Bison attempts to solve this very well with a code generator called Hygen. And if you look in the Bison repo, there's a number of code generators for components and pages and GraphQL snippets as well, where you could just run a command and it'll boilerplate a lot of this for you. I've yet to utilize this in the book or in the app for it, but I think that code generation for more complex pieces of functionality, like entire database CRUD and the screens to go with it, that's something that's missing. I know that Redwood.js is doing some work in that area, which is great. I think there could be, there's a lot of room for having one solution that does all of that. So that's something I'm looking for as well.
Yeah. We had a question from Cassidy, who's also one of our speakers for today. And she asked, you mentioned in the talk that the API isn't very prescriptive. And her question is, do you wish it was?
I don't know. That's a good question. Not necessarily. I like having the ability to choose. If I want to do something that's very basic, I can do it with Next.js. And if I want to do something that's more elaborate, I could reach for Apollo Server or Nest.js. I like it that I can integrate it with many things. I do think that it's for people that are new to API design, it's good to have a bit of a guide for what direction to go. So I think that would be helpful, maybe in the Next.js docs or maybe just in a number of articles.
Right. And we're going to wrap up the Q&A. I'd like to thank you once again, Mike. That was very insightful, and I really enjoyed having you on. So once again, thank you, and I hope to see you soon.
My pleasure. Thanks for having me.
All right. Okay, we're now moving on. And next up, I'm thrilled to invite Michael Leitek. Some of you may know Michael from his work as the author of Type GraphQL, the framework. Michael is a full stack developer with a tendency to perfectionism. He's also a GraphQL and TypeScript evangelist and Node.js and React enthusiast. Michael's talk title is Auto-Generate GraphQL API from Prisma Schema. Quick reminder that we'll have a Q&A and you can post your questions in the Prisma Day Slack channel. And now, give it up for Michael.
Hello, everyone. In this talk, I will show you how to automatically generate a GraphQL API based on your Prisma schema. We'll be talking about the type GraphQL Prisma integration. Before we start, I would like to introduce myself. My name is Michael. I'm a senior software developer, and I'm also a creator of the type GraphQL framework. You can find me on GitHub and Twitter using the handle on the bottom of the screen. So let's start with what is actually the type GraphQL. It's basically a tool that allows you to describe your GraphQL schema using TypeScript classes with decorators and introduce the GraphQL schema like the GraphQL schema SDL on the right based on the class recipe on the left. It not only produces the types, but also allows you to define your resolvers in a class-based fashion. So what is the type GraphQL Prisma? There's a few good answers to that question. It might be like a Prisma integration for type GraphQL. It's also a package that can be found on NPM registry. It's also a Prisma generator, so it hooks into the Prisma generate workflow. But the most broad answer to that question would be a tool that auto-generates a GraphQL API based on your Prisma schema. So if it's a Prisma generator, how do we actually can use that? The generator we always use is a Prisma client.js generator. We describe that using the generator block. So with the same syntax, we can describe the generator for the type GraphQL Prisma by providing the type GraphQL Prisma name under the provider key. We also have control of the output. By default, it's a Node modules, and it generates transpiled.js files. But we can also point to our ASRC folder. So it will emit the TypeScript source file. So what actually the type GraphQL Prisma do? It reads the Prisma schema, like the user model on the left, with all the properties, all the types, and all the Prisma attributes, and generates type GraphQL classes based on that. It's putting the decorators, like the object type for the generated class, and also all the properties like ID, email, or name in this example are annotated with the field decorator with all the nullability settings and all the types provided. But it's not only this. It not only generates the model types like the user, but it also generates a bunch of stuff that are reflecting the capabilities of Prisma client. It also can generate args type that corresponds to the parameters of the Prisma client methods like find unique or find first. In this example, it's find unique user args. It also generates the input types like user when input, which correspond to the nested properties of the find user args. We also have output types like user count aggregates, which corresponds to the data we return from the aggregate methods of the Prisma client. But the most important thing is that it also generates resolvers, two types of resolvers. The first one we see on the right is the CROT resolver, which generates some methods and queries and mutations that correspond to the most popular CROT operations like find first, find many, create, update, delete. But we also have relation resolvers. So for example, when single user can have multiple posts, we can easily generate the relation resolver, which automatically resolve the relations, fetch the data from the database. So we don't need to think about the relations and getting the nested data at all. So if we generate the resolvers, that the type GraphQL Prisma integration generates the resolvers, how can we then create the GraphQL API from them? So the integration generates a file which contains a resolvers export. So if we import the resolvers array from that file, all we need to do is to just provide it in the build schema function from type GraphQL package under the resolvers key to build a GraphQL schema, GraphQL executable schema. So in just two lines, we have the GraphQL executable schema. So all we need to do then is just to expose that to the HTTP, like using the Apollo server. We just need to provide the schema. And the most important part in this configuration is the context, because we need to provide the Prisma client instance inside the context like we see on the right of the screen. So let's make a quick demo to show the capabilities of that generated GraphQL API. Here we have the really simple query that will get all the users with all the posts that the user create, with all the details like ID, email, and name. And if you execute that query, it will return our data with all the nested relations like post of the user and all the data we have described in our database. But it's not only capable of simple things. We can also provide some arguments that corresponds to the API of the Prisma client. Like, for example, we can filter users by email if it contains Prisma, and we also can order by the name of the user in descending order. And if we look at the post, we are defining that we only care about posts where title contains Prisma, and we only want to take the first one. And here we have the results. We got the users sorted by name, like here is first Bob, the second is Alice, and we only have one post with the Prisma in title. We can also have execute mutations like create. In this example, we can create a user and we get the data with the generated ID, and we jump back to the get all users and execute that again. It will be on the bottom without any post defined. And the generated GraphQL API has much more capabilities and is capable of executing much more complex queries. Like here we have a group by post exactly. And we are grouping by a published flag, by the published status. And we only care about posts when the author name contains Alice. So if we execute that query, we will see that Alice has one post which is published and one post which is not published yet. But the GraphQL CRUD API in the fully fledged GraphQL API is not the only possibility of using the type GraphQL Prisma integration. What if you want to expose only selected models or selected Prisma actions? This integration generates also separate resolvers classes like user relation resolver for fetching the relations, either CRUD resolvers, or also the resolvers for selected actions like find unique, find many, or aggregate. So all we need to do is to import that resolvers we're interested in, and then put them into the resolvers array of the build schema function. And if we run, if we expose a server with such schema, there will be no way to, for example, create a post like we saw in the demo. Which is what more it is capable of. There are a few more features that are helpful in customization of our GraphQL API. For example, we can omit some model fields, like on the left we have the user model with the password field, And basically, we don't want to show our API users the password of selected user. So it has to be defined on the Prisma schema level because it has to be stored in the database, but we don't want to show that into the outside world. So we use the type GraphQL omit attribute. It's actually a Prisma schema documentation comment because Prisma does not yet support custom attributes, so it's kind of workaround. And if we use the type GraphQL omit attribute, the password field won't be exposed to the outside world at all. We can also rename model types and rename the fields. For example, on the right, we have model user, which will be exposed under the client type name in our GraphQL API. And the balance field, balance column in the database will be exposed as an account balance field in our GraphQL API using the similar syntax as the custom attributes, but under the documentation comments. We can also expose custom resolvers. So we have some custom logic we want to have in our GraphQL API. And the type GraphQL Prisma integration does not limit us only to the generated CRUD API. We can have our custom domain logic, like in this example on the left, we can see a best user query, which only gets the first user when email is natalia@prisma.io. It's a really simple logic, but allows to demonstrate the capabilities of custom user resolvers. So having that custom query user resolver class, we need to provide that into the resolvers array of the build schema function. And we can also extend the model by providing additional fields. To do that, we use the model, we create another resolver class, this time with the field resolver decorator. So on the right, we have the user favorite post field. And the implementation is really simple because it returns the first post of the selected user using the Prisma client from the context and just return it. And it's really nice. It's really nicely working with the type GraphQL Prisma because here we are referencing the user type, the user class, which is exactly the one generated by the type GraphQL Prisma integration. So we don't need to define that class again and use the decorators. It's all already ready to use. So to sum up, there are a few key things you should remember after this talk about the type GraphQL Prisma integrations. It's a Prisma generator, and that helps you automatically generate the type GraphQL classes, type GraphQL types, and all the CRUD resolvers for your Prisma schema model. It's really helpful for bootstrapping GraphQL API in just a few minutes, which is really great for prototyping and need to have something done in just a few minutes. But it's also configurable and customizable, so you can adjust that according to your needs and extend the capabilities if you want. So that's all. Thank you for your attention.
Michał, thank you for the talk and the in-depth walkthrough. And also, sorry if I mispronounced your name in the opening. I think it was really nice to see how the generated GraphQL API provides extensive filtering and sorting options all out of the box.
Yeah, that's really great. Thanks for having me.
You ready to take some questions?
Yeah.
Okay, let's get into it. And a quick reminder again that you can drop your questions in the Prisma Day channel. So we had the first question that we had was, so typically, as you covered in the talk, GraphQL APIs backed by a database, obscure database fields from the API, for example, password hashes, And Type GraphQL's approach to this is to explicitly omit fields by adding comments in the Prisma schema. And the question is there also a way with Type GraphQL to explicitly include database fields rather than explicitly excluding?
Currently, there's only a mechanism to explicitly omit, hide a Prisma model field from exposing by GraphQL. However, from a technical point of view, it could be quite easily implemented, especially when the custom attributes will become available in the Prisma schema.
I see. We had a question from Aman from the audience, and perhaps you can chime in on this. And he asked, where can I get a starter Type GraphQL Apollo server and Prisma starter? So do you have maybe an answer, or do you think you could share a link? I think we also might have an example.
Yeah, I think there are examples on the Prisma examples repo, and also in the Type GraphQL Prisma GitHub repo, there's also example repository.
Okay, so Aman, rest assured, we'll be sure to drop a link. Now, does Type GraphQL Prisma leverage the data loader in Prisma client to solve the N+1 problem?
Actually, Type GraphQL Prisma was initially using the data loader directly at the beginning, but when the data loader was become built-in in the Prisma client, the Type GraphQL Prisma now relies on that, and thanks to this mechanism, the generated relations resolvers allows for batching database requests by the Prisma client, so it solves the N+1 problem very well.
Oh, okay, I see. And in general, how do you think about maintaining backwards compatibility in the GraphQL API when the database schema changes? Do you have any sort of a high-level approach to this? How do you generally solve this issue?
Database migrations also need to be taken in a proper way, because in terms of GraphQL API, we can, for example, rename a field and deprecate the old one. But with database, we can only rename the column. We can't have duplicate values in the database. And with Type GraphQL Prisma renaming fields capabilities, we can, for example, rename the column in the database by still exposing that under the previous name in the GraphQL schema. There's really complex problems, so it may be a bit hard to describe all the details in this quick question and answer section, because we are limited in time.
Yeah, sure. And how would this compare to something like Hasura, for example?
Type GraphQL Prisma integration main focus isn't generating the fully fledged GraphQL CRUD API. The main purpose of this integration was to generate all the code blocks like model classes, input and args type for Type GraphQL, which can be then reused and composed in the custom resolvers written by the developers containing the domain logic, so that the developers don't have to manually write all the types corresponding to Prisma models and Prisma actions. So for now, it's not a competitor to Hasura. For example, it does not incorporate a really compatible pagination system. But even if that's not a main focus of this integration, the CRUD capabilities, the customization and extension options, I think they will be further developed in the future.
I see. On that note, Michał, I'd like to thank you once again for the talk and for sharing your experience and knowledge, and also for creating both Type GraphQL and the Type GraphQL Prisma generator. So I hope to see you soon at one of our meetups and events, and I'm wishing you an enjoyable rest of your day.
Thanks. Bye.
All right. Wow, this has been a packed day, and it's been absolutely exciting to see how developers use Prisma in a variety of use cases across many frameworks, tools, and paradigms. We now come to the talk that we've all been waiting for. Where is Prisma going, and what does the future look like for Prisma developers? And no one is more equipped to share this vision than Hervé, Prisma's VP of Product. Hervé was previously an entrepreneur, worked at Google and Contentful. Besides a growing passion for building guitars, he loves understanding developers and identifying opportunities to make their jobs easier. And on that note, I'm honored to invite Hervé Labas to the stage. And so with that, I bring you Hervé and the future of Prisma.
Hello, everyone. I'm extremely excited to be here. I'm Hervé. I'm the VP of Product at Prisma, and I'll be talking to you about, in this Prisma Day, about the product, the direction we are taking. More specifically, I'm here to answer these questions. First, what is our vision? Some of you might already have heard about it. I really think it's important for us to set the stage and really look at what we've been doing and where we're headed. So that brings us to what did we do since the last Prisma Day? I'm going to be talking specifically about the features improvement and also some of the first strides we made towards our vision. I'm going to stop briefly and talk about what is happening now, so at the time of this recording, and what you can expect in the coming days or weeks, and then where we're headed next. So really a glimpse at the things we're looking at building. All right, so what is our vision? So before the vision, it's interesting to just stop by our mission. And our mission is pretty simple. It's about making databases easy, easier to work with. Because let's face it, working with databases is hard. We strongly believe that we can make a difference in the Node ecosystem by providing you with a great product. And this is really about making you focus on what you love the most, is building applications, is coding. Spend your time there rather than figuring out the intricate details of dealing with database changes in the schema or debugging, troubleshooting production environments with like difficult queries that you had to handcraft. So really want to give you that control, that level of control to really deal with the specific needs of your applications towards the database while giving you as much productivity as possible. This is what our ORM product is focused on. Work with your data, support you in evolving your schema, and collaborate with your team, keeping you productive and happy with essentially your product. So to look at our vision, let's unpack a little bit what Prisma is made of first. This will be familiar with a lot of you, but it helps setting the landscape up for the vision. So it all starts with the schema. The schema is defining the data structure and the models of your application. This schema you can introspect from the database directly, or you can create it from scratch using our VS Code plugin. After updating a schema, you can also auto-generate migrations that will allow you to take care of everything you need on the database side. And that schema also generates a type-safe client, which really levels up the developer experience. It saves you hours of development, leveraging a lot of what the TypeScript language has to offer, saving you from mistakes, keeping you productive with super nice auto-completion support. So this is really what the client is focusing on. We also have a Go version that is available in early access. And finally, we offer a data browser called Studio that makes it easier to manipulate data from the browser or a desktop application. So now let's have a look at how this builds for the foundations of our application data platform vision. So first, the application data platform is really important to see where it draws inspiration from. It draws inspiration from companies like Twitter or Facebook, who created a system to keep developers productive while enabling them to meet the high scalability and compliance requirements standards that their products have. And we strongly believe at Prisma in bringing similar benefits to more organizations, to all of you. An application data platform is really meant to support developers in more complex environments. Like, for example, when data access can be done from multiple services, more databases are available as well, other services that also providing with data, or when there's more than one project available as well. In that context, the first major component of the application data platform is the data plane. The data plane is bridging the data infrastructure using connectors and the application through a data API. So it aims at solving problems arising with application that needs scaling, essentially translating into solutions like caching or accommodating with data access policies for each project without requiring you to massively refactor your application over time. It's really about that. And next to the data plane is what we call a control plane. The control plane holds the repository of information necessary for the data plane to function. This really brings solutions to more organizational problems that your team face while collaborating on the data layer of their application. So this may translate more into fine-grained permission control, like a data catalog to understand where the data is, account management, and some productivity tooling, like simplifying the way you collaborate with your teammates. So that combination of the control plane and the data plane constitutes what we call an application data platform, and this is what we're really building towards. All right, so now that this landscape is set, what did we do since the last Prisma Day? So the first thing we focused on was to grow our ORM product to provide you with the best possible experience with it. We really believe in the ORM to be the foundation for building great applications, and that builds the foundation for that application data platform. The second thing we did was starting to build that vision. So we started off an early access version of the control plane, which exposes Studio as a data browser, but hosted on the cloud so that you can invite your colleagues, providing them with specific permissions so that you can collaborate on the data your application is using. This is still in early access, so you can expect some rough edges, but we're actively working on them and listening to your feedback to improve it constantly. You can access that at cloud.prisma.io and just subscribe using your GitHub account, import your Prisma project, and get started straight away. So now, looking back, here's a large cloud of terms that cover the significant changes we've made to the product since last year. A big, obvious one is regarding migrate and introspection workflows. So you can really deploy changes to your schema with confidence. So this came with seeding, native database type support, distinguished workflow between development and deployment. We also made a ton of improvements to the Prisma client, which would be too long to read through. But this is the bread and butter of working with data. So we really want to continue expanding the surface of that API so you keep having more and more value out of that and less reasons to resort to custom SQL. We also worked on new database connectors. So you can see here a SQL Server has reached preview for some time now. And we also had an early access running of our MongoDB connector, all of which will open more possibilities for people to use Prisma, or people who were expecting Prisma to support these databases to be starting working with it. This is pretty exciting. I'm really looking forward to see what new kinds of applications will come out of using those. And last but not least, we've made Studio GA, Prisma Studio. We packaged it as a desktop application. And as I mentioned earlier, we started building a cloud version of that. So that's a lot of things. And I really want to take the time to really warmly thank all of you for all of the feedback, the discussion, raising GitHub issues and reports, and be constructive in all of those, so that we really could take a lot and understand what you were expecting from us, and really continuously improve Prisma. This is really thanks to all of you, and I strongly, on behalf of the whole team here at Prisma, I really want to thank you all. So what is happening now? Let's just take a look at three main things I wanted to briefly bring up. We've been hard at work on referential actions. So this is really about giving you more control over what happens upon deletion or update of relations. This is going to happen in preview behind the feature flag before we'll bring into GA the main version. We are finally making SQL Server GA, so you can start to use that. It's production ready. It's been battle tested, and this is going to be opened up very soon as well. On the same line, we are making MongoDB preview. So we have a pretty restricted feature set by now, but this is definitely working out already for Greenfield projects specifically. You can start writing your schema and working with Prisma and Mongo. And we're going to continuously add some more features until we consider that complete for making it GA. So all of that is happening, either already happened briefly shortly before that talk happens, or is happening in the coming few days or weeks. So now where are we headed next? So pretty simply, we want to further grow the ORM. So from where it is to an even bigger surface, we really want to cover some more ground and give you more foundational features like long-running transaction support, more native types, runtime validations, computed fields, like anything that really makes Prisma more and more complete and gives you more and more flexibility. I'm taking the opportunity here to outline that we have a public-facing roadmap. You can click this link, or you can go to pris.ly/roadmap and check out where we are at, what are we actively working on. We also have, obviously, GitHub releases and announcements on our Slack community, so you can subscribe to GitHub issues to also be notified when we're done with them, and also provide your input on the API designs that we suggest in there. Another section of improvement we're really looking at doubling down on is in enabling Prisma for larger projects. So it happens that people working on mono repos want to split their schemas in multiple files to share modules across projects. They want to have better understanding of which environment they're working on, so they don't mistakenly apply something in production while they were looking at doing that on staging or in development. We also want to bring some more observability capabilities, so you can really better understand what's going on your production application. The second aspect we want to grow is our application data platform vision, and essentially double down on adding some more capabilities to it, so that essentially it supports developers throughout the entire development lifecycle of the application. A couple of things that we're going to look at is improving the way you can run migrations. So also from the cloud, having a better understanding of the history of your migrations, mostly per branch, so you really can see what's going on and have more confidence about where you can run what. We also want to provide a query console, so you can try out your Prisma API once schema has changed. That really builds up that confidence and collaboration across the schema that the team is working on. We also want to bring up a first version of the data plane. This component will be an infrastructure component we're going to host that will proxy your database and provide you with some advanced connection pooling so that your deployments, especially in serverless environments, will be made way easier. You don't have to worry about like super difficult settings and end up with potentially connection exhaustion problems in your application. So this will work in conjunction with the control plane, so you can really have one central place for your team to build up your application and collaborate on it. All right, I hope this was insightful. I'm really looking forward for your feedback on all of what I explained here, and feel free to ask any of your questions. I'm looking forward to that in the Q&A. Meanwhile, take care. Thank you.
Hervé, thank you so much for sharing so clearly Prisma's vision, our progress, and where we're headed next.
Thanks. Very happy to be here.
Oh, wow. Hervé, how did you manage to grow a beard so fast? Is this part of a move fast, grow beards philosophy?
Yes, exactly. 5 seconds.
All right.
Thanks.
Cool. We'll do now a live Q&A with our VP of product, Hervé, and we're closely watching the conversations happening right now in the Prisma Day Slack channel. So this is your opportunity to ask the questions that matter to you most about Prisma's features, roadmap, and vision. Hervé, are you ready?
Yep.
Okay, let's get right in. When speaking about scaling, there are usually two aspects that come to mind. The first is organizational scaling. How do you maintain productivity as the number of developers grow? And second, technical scaling. How do you ensure that your infrastructure can handle increased loads as your customer base grows? How do you think the application data platform addresses these two aspects?
Yeah, that's a great question. That's a broad question too. Let's start with the organizational scaling. I think there's another proxy to that problem that is usually about collaboration. The more people you have, the more it's difficult to share context across teams, departments, and that means also making changes visible to other teams, understanding the impact of changes you're trying to do. So we think that these classes of problems do appear, and the data platforms, especially the control plane, is a place where we really want to make room for these problems to be solved. So really providing solutions so that teams can really understand better what is happening, who is trying to make what happen on the schema, sharing access to some data with certain set of restrictions so that we make sure that we follow the rules of the organization that are set in place. So all of these kinds of problems are really things that the control plane is looking at doing. I would say the technical scaling aspect, like more really taking in the load, is something where we're talking about the critical path, the runtime aspect of applications accessing data, where the data plane is really the component we're looking at for most of that part of solving this category of problems. So scaling it can be about performance, but there are like multiple aspects. This concurrency is one problem that, for example, you can actually really quickly face when you have a serverless environments with lots of functions trying to access your database at the same time. And this is why actually Alberto shared an early access program that we just getting started with to a Prisma data proxy that is aiming at solving some of these problems. Another aspect of scaling is really just the sheer load and volume of data that you're dealing with. So it's really just about how big is the information you're trying to really pass through and query through and ingest. We had a great example of that with the Triggs presentation, where they do have quite a lot of data and a lot of data sets to consume and to work with. That came with obviously a different kind of architecture. What we really want to do with the data plane is make these kinds of architectures a lot easier to build and a lot easier to get to.
And I see, and sort of leading from the previous question, how would you characterize development teams that would benefit from the application data platform?
So our goal, I think we share something with PlanetScale that I think was really really interestingly put by Nick earlier today, is really looking at small teams who really can benefit from these workflows and collaboration features and ability to really work more efficiently and effectively as a team. This is productivity is another aspect that was very well called out during the panel discussion about one of the benefits of Prisma, just the ORM, and we want to just grow that for teams. So small teams can definitely benefit from these capabilities. The further the team grow, we believe that the data plane and technical scaling will become increasingly important, and so this is where the data plane will start to appeal to that. So companies of bigger sizes will start to be demanding for more of the capabilities from a data plane. So really what we're trying to reach is a really wide spectrum of people and companies that are really looking at improving the way they work with data as a whole.
I see, thank you. We had a question from James from the audience who asked, Hervé, so we can use control plane both to start an MVP and also scale up for production as well as grow an application? Sounds like a critical tool in the kit, in other words.
Yes, this is the intention of Prisma is already in the critical path, we believe, of your application in a way, because it handles the access to data, which is quite critical. The control plane is really there to enhance and improve the experience you have dealing with the process of working with Prisma. So that is really trying to make it indeed an important tool, at least like a critical tool, if you're really leaning on Prisma a lot for your projects. So that
I see. And we had another question from Leo. He asked, do you think eventually there may be an issue if Prisma client grows too much, as it's essentially a giant object in the context which goes all over resolvers and endpoints? Just wondering if you take such considerations into account when you're adding more features into it.
That's a great question. And I think this is also where the data plane will also start playing a role. So when you start having like really bigger and bigger needs for your clients, We like the data plane will essentially offload some of the things that currently are packaged within the Prisma ORM, the Prisma client. So like just from a purely library perspective, you will have a much more lightweight library to package with your app. So that's the first aspect that is really essential. I think then when it comes to the actual API, our hope is that you really will import the things that you need and that you're using. So the types that we generate will be something we can look at. Yet this is something to unpack. I would say the best is to really look at a specific use cases, open up issues, and we were really keen to understand like the ins and outs of specific use cases and see if like really large schemas require some specific optimizations in the future.
Got it. Thank you for sharing your perspective. Well, finally, one final question. What will be the pricing model of the application data platform?
Yeah, that's a tough question. This is something we will still figure out. Like essentially, we will have a free tier. We want to make sure people have a very easy, smooth, and natural transition to be able to use more capabilities with Prisma. This is really not the goal to have a very steep step to climb to suddenly be paying hundreds. We want to make sure that that smooth transition happens. The models we're looking at right now are pretty much a SaaS, typical kind of SaaS model where you would pay depending on how much you use of the platform. The leading idea is around charging per project. So you would have free projects that would be limited in amount of people working on them, or volume of, for example, models or schema complexity. Depends on how we really looking at that. So no details there yet, but we're looking at projects. That's one dimension. The other dimension is going to be essentially usage, meaning data processed through the data plane, especially once you start reaching a certain set of certain scale where you will lean on the data plane to really deal with that, and having the extended capabilities to manage that scale. For example, I don't know, caching or any sort of feature that helps you with that scale. This is where like the actual paper usage will start to become a thing. Hopefully we'll make that really clear and easy to understand. This is also another thing that's crucial for pricing, to really have a clear, transparent pricing model that you can understand, project, and really plan on. But yeah, this is heavy work in progress at the moment.
I see. And one final question quickly from Emil. He asked, does the data plane mean basically not running the engine on the back end directly?
The data, yeah, that's a way to put it. The data plane would essentially, part of the data plane would be hosting what the binary of the query engines are currently, would be hosting what the binary is currently having within the backend. So you would deport the query engine to that data plane. It's a way to imagine how it would work. The details of that is always obviously going to be more around that, like infrastructure components, managing that piece of infrastructure and the interface with that, the authorization and authentication of all of that, and the security aspects of all of that. So that's more than that, but this is indeed a way to put it.
I see. Now, before you leave, Hervé, I'd like to invite our viewers to try out the Node API preview feature, which I think you touched on. In case you're not familiar, Prisma client currently communicates to Prisma's query engine over either HTTP or Unix domain sockets. After some experimentation by Prisma's engineering team, we found a way to reduce the communication overhead by using Node API, which provides direct memory access across processes. Yesterday's 2.26 release includes improvements to the Node API preview feature. To try it out, all you have to do is add the NAPI preview feature to your Prisma schema and run Prisma generate. With Node API, you should see some performance improvements. So give it a go and share your feedback. We'll also share a link in the Slack channel to where you can leave your feedback on this specific feature. And on that note, I'd love to thank you so much, Hervé. We have loved seeing what the Prisma community has built with Prisma so far, and I can't wait to see how Prisma's application data platform and ORM will fuel the amazing products developers are building every day.
Thanks a lot. Thanks a lot, everyone. And also super excited about seeing what's next.
All right. See you soon.
See you soon.
Okay. Wow, so we have spent today learning so much about Prisma, but of course, as developers, we recognize that our space is constantly expanding. Thus, we are delighted to be able to present one additional talk for today about Jamstack and database. And for this, no one is better suited than Cassidy Williams, whom I'll be introducing in a moment. So, before I introduce Cassidy, many of you have asked about the recordings of the talks and the workshops from yesterday. All of these sessions will be uploaded to YouTube in the coming week. And now I'm thrilled to invite Cassidy Williams to the stage. Cassidy is a principal developer experience engineer at Netlify. She's active in the developer community and one of Glamour magazine's 35 women under 35, changing the tech industry and LinkedIn's top professional 35 and under. As an avid speaker, Cassidy has participated in several events, including the Grace Hopper Celebration for Women in Computing, TEDx, the United Nations, and hundreds of other technical events. Cassidy wants to inspire generations of STEM students to be the best they can be. And her favorite quote is from Helen Keller: "One can never consent to creep when one feels an impulse to soar." She loves mechanical keyboards and karaoke. And Cassidy's talk title is Databases in the Jamstack. Cassidy, the stage is yours.
Hello, everybody, and welcome to this talk, Databases in the Jamstack. My name is Cassidy Williams. You can find me at Cassidoo most places on the internet, and I'm a principal developer experience engineer at Netlify. I'm really excited to talk to you today about this concept because I think a lot of people are aware of Jamstack concepts and aware of database things, but not as much on how well they play together. And so first of all, I just want to talk about the Jamstack because a lot of times people are just like, isn't that just building websites? And it kind of is. So the term for Jamstack was first presented in 2016 by Matt Billman, Netlify CEO, and it was introduced as JavaScript, APIs, and markup. And it was a way of architecting your sites in a way where sites were hosted on CDNs and they were pre-built up front. And the term went from Jamstack with the capital JAM to Jamstack in 2020 for flexibility because yes, it's still JavaScript, APIs, and markup, but you can do a lot more dynamic things with your Jamstack sites that isn't just necessarily strictly static. It might be static first in a lot of ways in how you host it, but it's a little bit different from that. And so first of all, JavaScript. All dynamic functionalities that you might have in your sites are handled by JavaScript. There's no restrictions on how much JavaScript that you use. There's no restrictions on which frameworks you use, which libraries you use. It's just JavaScript, and it's what you use for all dynamic aspects of the site on the front. APIs are for server-side operations. They're abstracted into reusable APIs and accessed over HTTPS with JavaScript. They can be third-party services where you're pulling in data, or they could be your own custom function. And that's where it can get really, really powerful, where you can write functions in Node, in Go, in Rust, and in all kinds of different languages, and use that API to add that kind of server functionality to your sites. And then finally, with markup, it's sites that are served as generated HTML. That's what's given to the user. But again, that's JavaScript, APIs, and markup. But what about that flexibility thing that I mentioned? I think the easiest way to really describe it is you're compiling as much as you can up front and then pulling in as much data as you can as needed. Now, when you think of it this way, this is how it made the most sense to me. When you're thinking about mobile applications, iOS, Android, Windows Phone, rest in peace. When you're thinking about these mobile applications, you have these apps that are mostly compiled. You're using these languages like Java, like Swift, like Kotlin, these languages where you compile an app together, and then whenever you want to get information from the internet, data that is pulled in, that happens when you're actually using the app, when you're actually running the app. But otherwise, it's mostly compiled up front. You can still load quite a bit in these mobile apps without an internet connection. It's kind of similar that way with Jamstack, where you're kind of treating the browser as an operating system, where you're compiling as much as you can up front, and then pulling in data as needed. And by doing it this way, it's not necessarily a new concept. None of this is new. We build sites this way to be able to add the kind of flexibility and treating the browser as an operating system to be able to reframe how sites can be built. Sites have been built this way for a long time. We have better technology now, but none of these concepts are completely mind-blowing, where they're borrowed from a lot of different places. It's all about reducing complexity and increasing portability. Everything lives in Git for easy cloning and deployments. What's really nice about this is I don't necessarily need a container to be able to run a Jamstack site. I should be able to just clone it and run it locally. And then scaling and performing is much better too, because as much as pre-built as possible, so you don't have to worry as much about your site being DDoSed. A really fun example of this is a friend of mine, her startup decided to switch their site to a Jamstack approach just to see how it might work. And she works with a lot of live streamers, and there was a point where they had this form that was being run with a serverless function and triggered, and normally their site kind of struggled whenever they would have a big streaming event where they had thousands and thousands of people filling out the form at the exact same time. But by doing it in the Jamstack approach, because all of the JavaScript was built up front, all of the site was built up front, it was just the serverless function that was being pinged, their site had no latency whatsoever because it was just built as much up front. You didn't need to serve extra JavaScript to actually load the page. It wasn't server-side rendered, and all of the data was still submitted because she was using serverless functions for that. So it's very, very exciting. I love this concept, and it's very cool. But I've been talking a lot about that. Where the heck do databases come in? Now, databases thrive on that API layer, the A part of Jamstack. And you can kind of reframe the question where, what if accessing a database is like working with a data API? Your servers don't, or your users don't necessarily need to access the data directly, but instead you can build an API kind of like with a serverless function or with built-in functionality from your databases, and then use that to connect to the database. And by doing it this way, you don't necessarily need to think about DevOps. You don't necessarily need to think about containers, which I really like to not have to deal with. You don't need to think about any of that. I can still be in my front-end developer comfort zone while still doing really complex, dynamic, data-driven apps without feeling like I have to learn an entirely new skill set. And that's really, really powerful. And it's all about decoupling your services and decoupling all of your information. By cleanly separating my database from my site via an API, rather than deeply integrating it into my systems, I can more easily reason about all of the different parts. If I have a database living out somewhere and a CMS elsewhere, and maybe authentication living somewhere in between, my design system being pulled in via data, treating everything like an API, each of these components can be swapped out with and upgraded easily without taking down everything at once. And you can kind of have specialists on your team focus on very different parts of your application and do all of their updating. And as long as the API aspect of it works, that's all that really matters. And it's a really powerful modular way of thinking that will help your site scale really well and help you be able to, for example, let's just say you want to change your database to a different service or change your CMS to a different service or something like that. You can just do that and not have to worry about taking down your entire site or redoing a bunch of code. Okay, so that's most of the slides I have for you. Now I want to go through a quick demo just to explain how I do this really quickly in an application. And so if you'd like to jump over to cast.run/adventure, this is an application that I made a while ago and I've updated here and there, but a lot of these core concepts are the same. And so let me switch over to that really quick right now. Okay, so this is an application that I made, and it's called A Lonely Code-Filled Night. And it's kind of just a fun application I made that is using Next.js. It's using XState for state management. It's using Netlify Forms for submitting forms, and it's using serverless functions in Hasura and using all of that to query a database. So in this application, I can click Get Spooky, and it'll let me go through this choose your own adventure story. And so I can say, once upon a time, there's a developer named Solar who was working very late at night on Halloween. You can tell when I first wrote this story. Solar decided to take a break to get a snack. He went to the kitchen and couldn't decide what to eat. We could eat some candy. He munched on the candy, enjoying the delightful thought of getting a cavity someday. But then outside the doorbell rang. Trick or treat echoed outside. We're going to answer the door. He opened the front door, but nobody was there. It was spooky, but probably good since his stomach had the last of the candy. We'll ask if anyone is out there. He called out into the night, "Who's there?" Suddenly, a werewolf comes up and says, "Have you heard of TypeScript?" and eats him. The end. Ooh. So this is just a silly little story, but I wanted to kind of show how this all works. Now, this character named Solar is not the same character that you will always see when you load up this website. And that's because it's being pulled in from a database, and that database is being queried with a serverless function. So I'm going to show one more thing before I go into the code and have you look at it. There's also a way to contribute a character. And so I mentioned we're using Netlify forms. You can populate this with a character name, pronouns that they have, their character's favorite smell, and your email. And then when you hit send, that triggers a serverless function that then hits a database and then populates the database with that character's information. And then when you go home, you can then go again through the story and see all of that. So if I were to go into the code now, you can check this out. Again, it's cast.run/adventure or under Casadoo, my GitHub, and it's next adventure. And so in this code, we have all the different pages that populates the story and stuff. I won't get into that too deeply, but what I do want to touch on is the serverless functions here. Now, these serverless functions are directly interacting with my database. And so if I do getCharacter.js, this one right here, this is run whenever the site is run at first, and we're querying get characters, and then it passes all of this information into my site, and it's just an API call that I made. And in get characters, this is where I'm querying Hasura, and it's a GraphQL function. I'm just pulling the data in from my database that way. And if I were to go to the other serverless function, oops, sorry about that, my page froze for a second. If I were to go to submission created, this is actually a magic function name on Netlify, which is kind of fun. Whenever you use a Netlify form and submit it, submissionCreated.js is automatically pinged if it exists. And so it's a nice little thing to hook up to your forms. But anyway, let's just say you hit that submission created. We have this exports handler, and that takes in the form data, the name, the gender, the smell, and then we add that character to the database. And then this, again, is an API call, and it gets all of my keys, and then it passes that to my database this way. And this is really, really exciting because we're reading from the database, and we're also passing to the database, all with serverless functions. Serverless functions in general have a lower operational overhead than managing full-blown servers. So the setup and maintenance takes a lot less time. And as you can see, these are two files, these two JavaScript functions. And it's really, really exciting to see. And these secure credentials here, you might have seen that I have this process.env Hasura admin right here. And then we have the Hasura URL and stuff. These credentials are protected with environment variables. So our functions can make secure requests without having to expose any keys publicly to our database. And these serverless functions are built to automatically scale with increased traffic. And so I don't have to deal with DevOps. I don't have to deal with those kinds of burdens. I can just have my team or myself ship faster without having to have extra overhead when running these functions. I think this is so powerful and so cool. And so really quick, I want to show you what the database looks like. And so this is my Hasura database right here. And this is what has been populated from the form. It's a fairly simple table where there is someone named Zombie, and they had masculine pronouns, and their favorite smell was flesh. And then Lindsay is feminine and likes the smell of success. You didn't see the smell in the story, but that was there. So anyway, I get all of this data from those serverless functions, and then later when I want a random character, it's just pulled from this database. And I didn't have to do any extra configuration besides getting my keys, adding the environment variables, and making those two queries. And it's really, really exciting to see. And so I'll show you how these are queried really quick in the application before we start heading out. And so we have our different pages in the application, and in Next.js, there's an app.js _ app.js, and this wraps our entire application right here. And so this is just a big app context, and then that app context component is one that pulls in a bunch of data and passes it to our pages. And then the index.js, you don't need to see all of these pages. This is just the home page, and then the other pages are the form page and everything. And so that's what those ones are. And so the pages aren't as exciting as the context in here. Now in the app context, this part is very, very cool. We have our nice gigantic context file right here. It's actually not that big. I bloated it in my mind. And so we have this use random character hook that I made that uses a use effect. And this is calling our serverless function right here. It's using get character, and it pulls it from our API that we've made, because that's how our API works. And that's populating it from the database. And then it sets the character in the application. And then when I do that, that passes it down into my story context, and then my story context is passed to the rest of the app. Now, and this is the story context right here. And when it's passed to the rest of the app, we get a state machine and generate pronouns. Generate pronouns, this is a quick library where I generate pronouns based on the gender that's passed in, and so it can make the story a little bit more specific. And so here, this is where our gigantic story is. And so because we have our different levels right here, these are all the different phases in an X state of our whole choose your own adventure story. And so as we go, you can see, like, once upon a time, there was a developer named Name who was working very late at night on Halloween, the developer, and then you can see the generated pronouns and stuff, all pulled from that database in that one hook. And now really quick, I'll show you the form that I had over there. And this is under components, character form. In here, because it's a Netlify form, again, I didn't need to actually call submission created anywhere. All I had to do was add this data Netlify equals true. And so that means that Netlify will automatically detect this form and then call that function as needed. And so whenever I submit this form, we've got the character name, the pronouns, and then the favorite smell, and then again, that is passed to the database. So this is a very small example. It's a silly example, but this is an illustration of what you can do with a much larger application. Imagine if you had just a really dynamic application with authentication and users and user data. By having it use this serverless function way of doing things and having it live in the API layer of the Jamstack, that's when you can have really well scaling applications that a lot of people can use without you having to deal with a lot of overhead. That being said, thank you so much for your time today. I've been Cassidy Williams. Once again, you can find me at Cassidoo all over the internet. And thank you so much for your time. And if you have any questions, please feel free to reach out.
Cassidy, thank you so much for that insightful and approachable talk. This was also our last talk for today.
Ooh, we made it. It's been so fun seeing all of the different talks today. Everyone has been so interesting. I've genuinely enjoyed all of it.
Well, I'm glad you enjoyed it, and I'm sure the audience also enjoyed your talk. We are going to do a live Q&A now. Are you ready to take some questions?
I hope so. Let's go.
Let's go. All right. Well, to the audience, just you should know that you can drop your questions. I've said this many times today, but really, if you have questions, there's no such thing as a stupid question. So feel free to ask anything that might come to mind. And with that, let's get started. So the Jamstack architecture is pretty loosely defined, and in many cases is associated with static generation. How would you compare the Jamstack architecture to, say, single page applications?
Totally. And this is, I touched on a little bit in my talk, but it's definitely something that I'm just going to reiterate because it's confusing. And it was something where when I was first learning about this term Jamstack, I was like, isn't this just making websites? It's not particularly novel. I don't understand. But it's loosely defined, but it's also kind of just giving a name to not necessarily fully static sites, but static first sites. where you build as much as you can upfront and then pull in data as needed. And so I mentioned in my talk a phone metaphor where when you look at phone apps, whether it's on iOS, Android, whatever, Windows Phone, you pre-compile as much as you can upfront, and then you pull in the data as needed. And some of that data is pulled in upfront, and some of that data is pulled in when the user hits certain parts of a page or of a part of the app. And it's incredibly similar with Jamstack apps where you are treating the browser like an operating system. You're pulling in as much as you can and then populating it with data as needed. And so in a way, aspects of single page applications can be considered a Jamstack because you are compiling some things, but a lot of it is just coming in as a user requests it. And so a really good example of this is actually just the Netlify website, where we have a few different aspects of where there's like the marketing portion of the website and then the app portion of the website. And that's using a bunch of different frameworks. We actually use, I think, Vue and Eleventy on the marketing side. And then once you get into the app, it uses React. And there's certain parts of the Netlify app that is pre-compiled, but then a lot of it is very single page application, like we use React Router and everything. And it's all still considered Jamstack because we do compile as much as we can up front, but then we have the users query things and pull data in as needed, pull routes in as needed, and that sort of thing.
I see. Thank you for that answer. Now, sort of moving on from this, many Jamstack libraries have this concept of hydration. Could you explain what this means?
You know, it's really just a fancy word for pulling in data. Like it can happen at different points of your application, but for example, if you were to have a page that is mostly static, a good example of this, I don't know if you've seen the new Astro framework that just came out. It's a very static first framework. I think the website is astro.build. I've been playing with it all week and it's very interesting, but they do very, very static first, where it's so static that like if you put a React component on the page, it won't be interactive at all. It'll just render onto the page unless you tell it to. But what's interesting is it has the hydration element where if you say, okay, as soon as the component is visible on the page or as soon as like certain data is loaded, then you can actually use it. That's an example of hydration because suddenly the data has been added to the page and is usable on the page. And so it's really just a matter of being able to populate data as it is queried.
I see. Now, in your talk, you demonstrated how easy it is to pull data using a serverless function that fetches data from essentially a stateless GraphQL API. How would you sort of compare this approach to one where you directly fetch data from a database using something like, for example, Prisma?
For example, well, and I think they both have such great use cases. And it really depends on what you're using. And I think that they can actually work together in a lot of ways. It just kind of depends on what you want to do, where with serverless functions and the benefits of serverless functions, you can kind of hide your environment variables because you don't want anybody on the front end to be able to access them. You can make sure that you have that separation with the API. But then with something like Prisma, you can kind of query a database anywhere, and you can expose environment variables if you want to. You can and you can hide things at different levels and stuff. And so I don't know if it's never really a fun way to just say it depends and kind of leave the answer that way. But I think that depending on where you want to query your data and how you want your data to be exposed and used and stuff, there's those different use cases for both. I tend to like using the serverless function approach when I don't want to run a Node server, but I still want to have the benefits of a Node server and pulling stuff in. But if I can query something client side, I really enjoy doing that because then I can just do a quick fetch and run things on the front end as well. But luckily with the technologies that we have today, front-end developers are really empowered to be able to write front-end and back-end code, querying data and manipulating data without being uncomfortable about it because of these tools that let us do that.
Absolutely. And what do you look forward to the most in the current web ecosystem?
Oh, that's a good question, because there's so many interesting things to look for. And what I appreciate about the web ecosystem is because it grows so fast and is changing so much, people are very, very open to ideas and everything. And what I'm currently really excited about is some of the new build tools that are coming out. And so I've been playing a lot with Vite, and Vite is just so fast, and no shade to the wonderful folks and the wonderful technology of Webpack and stuff, but it feels like a game changer. And I'm really, really excited to see that and ES build really making a splash in the web dev ecosystem. And what I also am liking seeing is, because of some of these build tools and a lot of these tools, I keep saying, just developer tools that make it so it solves just one problem really, really well. A lot of developers will be able to bring what they want to the table. And so, for example, I mentioned Astro. There's some aspects of Vue that I like a lot, and there's some aspects of React that I like a lot. With Astro, I'm able to write both in the same code base because it just solves the problem of compiling the static pages. And then I can write my components however I want, where I can say, oh, well, if I want a component that can delete itself, I'll use Vue. But if I want to use something with lifecycle methods I'm comfortable with, I can use React. I can use them both in the same application there. And with Vite, I'm able to compile things super, super fast. And it has a lot of nice little tools built into that. I can use that with React because I'm most comfortable with that. And so that's a very, very long way to say the things that I'm looking forward to the most are more of these tools that specifically solve one problem, so that way developers can kind of bring their toolkit and just improve incrementally what they build with at a time.
Yeah, no, I can totally relate to that idea of like tools that do one thing and do it extremely well. I mean, the whole Unix philosophy has this idea, right? And it creates for so much potential for composability between these different things. Now, what domains are you seeing lagging the most behind in the Jamstack sort of philosophy and ecosystem?
Ooh, that's hard to say because let me think.
Because everything is so amazing.
Yeah, everything is spectacular. Well, and especially just with all the announcements between Prisma Day today and then Shopify did an event yesterday, and there's all these events that have been happening. Like I think e-commerce is growing a ton and media management is growing a ton. There's a lot of really, really cool things. I think what would be interesting is more of an advance in the real-time area of APIs and stuff. Like I know there's some really cool tools, like Supabase has been growing a ton, and even a lot of our database tools have been growing a ton. But I think it'd be interesting to see more advancements in the WebSockets space and any sort of real-time thing where you can still do a lot of that compilation up front, but get real-time data better. I think there's a lot of opportunity there.
Absolutely. We also had some questions from the audience. I believe one of them was partially answered, but perhaps you could chime in too. So Jonathan K asked, so if you wanted to use Prisma with auth on Netlify, could you run Prisma client in a Netlify function?
Short answer, yes. I'm pretty dang sure that you can. If I recall, there's actually documentation in Prisma or like a guide for something like that.
Yeah, so we have a guide, a deployment guide to Netlify. However, I don't believe so. Netlify also offers some kind of an authentication system, if I remember correctly. And I'm not sure, I don't believe that the guide does that, but it would be interesting to create an example for that.
Yeah, it would be interesting to play with that. Maybe that's something that you and I can work on together, Daniel.
Yeah.
Because we do have Netlify Identity Works, and that uses GoTrue, the open source authentication library. And so I'm sure we could do something interesting with that Yeah, but totally possible for sure.
Great. So Cassidy, I want to thank you once again for sharing your experience in this really approachable talk. It's been a pleasure having you here, and you were also the last talk for today. So I really wish you a nice evening or morning, depending on where you're joining us from. And I hope to see you soon. And I'm sure we can get something going with that Prisma with Netlify auth going.
Yeah, that's awesome. Well, thank you so much, Daniel, and to the whole team here. And also, I'm sure you'll get plenty of kudos, but I want to say you've been doing an awesome job, Daniel, at emceeing, and I know how difficult a job that is. And so thank you so much for guiding the ship on this one.
Much appreciated. Ciao. Okay, wow. We're now coming towards the end of Prisma Day, and it's been a really, really amazing day. I'd like to thank all the speakers once again who worked so hard to share their knowledge and experience and help make this happen. I'd also like to thank you, the viewers, for being part of the Prisma community and joining today. There is so much work that happens behind the scenes to make Prisma Day happen. And I'd like to give a shout out to the team behind Prisma Day. So Prisma's developer relations team, Natalia, Etel, Vladi, Mahmoud, Nico, Alex, Ryan, and Justin. Prisma's amazing design team, Julieta and Nilu, Marjena and Piotrek from iStream, the production company that ensures that everything runs smoothly. As we've mentioned, Prisma Day is a community-focused event, and we're interested in hearing how it was for you. You can also fill out, and we'd love to hear from you. So you can fill out the feedback survey at pris.ly/day-feedback. We'll also drop a link on Slack, and we'll also be sending it out in an email. And also feel free to share what you're building with Prisma in the showcase channel in our public Slack. We love seeing all of these cool projects that all of you are building. And on that note, I'd like to once again to thank you for joining us today. It's been a pleasure.